As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address human needs and these challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact.
Thank you for the inspiring video. The International Alliance of Academicians, IAA, is committed to fostering global collaboration among leading scientists and scholars, with a shared vision to advance knowledge for the betterment of humanity. Its mission is to promote interdisciplinary innovation, bridge academia and society, and address pressing global challenges through collective intelligence. The IAA Forum serves as an important platform to connect global thought leaders, encourage cross-sector dialogue, and explore forward-looking solutions, particularly in areas that shape our future, such as health and education in the age of intelligence. Before we proceed, let us take a moment to acknowledge the distinguished guests who have graced us with their presence today. They are Professor Nancy Yip, Founding Chair of the International Alliance of Academicians and President of the Hong Kong University of Science and Technology. Professor Dong Sun, Secretary for Innovation, Technology and Industry Bureau, Government of the Hong Kong Special Administrative Region. Mr. Mao Zhou Liu, representative from the Department of Educational, Scientific and Technological Affairs, Liaison Office of the Central People's Government in the Hong Kong SAR. Professor Shing-Tung Yao, Fields Medalist 1982 and Director of the Yao Mathematical Sciences Center and Chiu Zhen College of Tsinghua University. Professor Ariel Washoe, Nobel Laureate in Chemistry 2013 and Distinguished Professor at Large and Director of Washoe Institute for Computational Biology, CUHK Shenzhen. Mr. Ivan K.B. Lee, Commissioner for Innovation and Technology of the Innovation and Technology Commission, Innovation, Technology and Industry Bureau. Professor Alexander Ping Kong Wai, President and Vice Chancellor of the Hong Kong Baptist University. Professor Yi Ke Guo, Provost of the Hong Kong University of Science and Technology. Professor Chak-Shing Lau, Vice President and Pro-Vice Chancellor Health of the University of Hong Kong. Professor Vivian Wing-Wah Yam, Vice President and Pro-Vice Chancellor Global Innovation Center of the University of Hong Kong. Professor Li Wenjiang, Pro-Vice Chancellor, Vice President, External Affairs of the Chinese University of Hong Kong. Professor Beng Yang, Vice President, Student and Global Affairs of the Hong Kong Polytechnic University. Professor Anderson Ho Chen Shum, Vice President, Research of the City University of Hong Kong. Professor Xin Yao, Vice President, Research and Innovation of Lingnan University. Engineer Professor C.C. Chan, Distinguished Chair Professor of Electric Vehicles and Smart Energy, the Hong Kong Polytechnic University. Dr. Yin Xing Hao, Executive President of the Hong Kong Institute of the Legislative Council for the Technology and Innovation Functional Constituency, Hong Kong Special Administrative Region. Mr. Hendrik Sin, Hong Kong's Deputy of the 14th National People's Congress. Engineer Dr. Alex Chan, President of Hong Kong Academy of Engineering. Mr. Lawrence Chi Chong Chung, Chief Technology Officer of the Hong Kong Productivity Council. Dr. The Honorable Hui Simon Lee, Member of the Legislative Council for the Election Committee Constituency, Hong Kong Special Administrative Region, will join us later. And our distinguished speakers from all over the world, IAA Executive Committee members, renowned scholars, and industry leaders. We'd also like to extend our sincere thanks to the Innovation and Technology Commission, ITC, for their funding support and on-site attendance, and our valued sponsors, Lenovo, MetFirst Limited, and Huashan Technology and Education Group Limited for their generous contributions and in-person support. Let's give another big round of applause to welcome and thank you all our guests. Now we'll officially commence the opening ceremony. First, we are honored to have the video opening address from the Honorable John K.C. Lee, Chief Executive of the Hong Kong Special Administrative Region, who places great importance on this forum despite his busy official schedule. Now please look at the screen and welcome his address.
Professor Nancy, Professor Sir Christopher Medalist, Professor Pierre Louis Lyon, Professor Shing-Tung, ladies and gentlemen, good morning and welcome. I'm pleased to join you all at this year's International Academicians Hong Kong Forum. For the second year in a row, this forum is organized by the International Alliance of Academicians. This year's event brings together Nobel laureates, Medalist, and a host of globally renowned experts and academics in the fields of medicine, AI, higher education, and more. Among the finest minds from around the world, we will gather here to promote the transformation of outstanding academic research into application. Hong Kong is well placed to hold this important dialogue. Under the one country discipline principle, we are the only world city that enjoys both the China advantage and global advantage. We boast 5 universities in the world's top 100. Our research environment is open and vibrant. Our intellectual property protection is robust and aligned with international standards. These lay a solid foundation for the development of our innovation and technology ecosystem and talent regime. The National 15th Five-Year Plan, approved last month, gives strong backing to Hong Kong's development into an international innovation and technology center, an international hub for high-caliber. More than recognizing our potential, this is a call to action for us to devote our strength in promoting innovation and economic cooperation. This year's forum puts a much needed spotlight on artificial intelligence and crucial how to bring about innovation in higher education and an aging population. In our ever-changing world, the application of AI is pivotal for economies to make new breakthroughs in technological development. Hong Kong is taking forward the National AI Plus initiative by promoting industries of AI and AI industry. As a key driver, the Hong Kong Artificial Intelligence Research and Development Institute will commence operation in the second half of this year. The institute will be tasked to promote AI plus development and transformation of R&D output, thereby empowering industry such as healthcare, legal service, and finance to adopt AI. As part of the Hong Kong initiative, the Hong Kong as a government established the Hong Kong Generative AI Research and Development Center in 2023. The center has successfully launched Hong Kong's first large language model and a series of generative AI applications based on Hong Kong Chat, the generative AI chatbot, created by the center, has over 700,000 total registered users. We are committed to nurturing a new generation of users and innovators of AI. The Hong Kong as a government endeavor to have at least 35% of the students in our publicly funded universities studying STEAM-related subjects by the next academic year. We have also introduced the Hong Kong Future Talent Scholarship Scheme for advanced studies to attract more local students to pursue advanced studies in areas crucial to the development of Hong Kong, with science, technology, and digital transformation very much included. We have also launched the Fund for Innovative Technology in Education, which helps universities harness innovative and breakthrough technologies to transform teaching methods and enrich learning experience. All to nurture a digitally competent and technologically responsible generation with future success on all young people in the digital economy. The people of Hong Kong are blessed with longevity and healthy lives. The life expectancy at birth increased from 67.8 years old and 75.3 years old in 1971 to 82.3 years and 88.2 years respectively in 2024. That's one of the highest life expectancies around the world. As fortunate as we are, we know that chronic diseases will also be more prevalent in an aging population. The Hong Kong government is accelerating clinical trials to promote the development of Hong Kong into an international health and medical innovation hub. To expedite patient access to advanced diagnostic and treatment services, we are rapidly expanding our clinical trial facilities. Clinical trial, as you all know, is a key process in driving the translation of innovative governmental R&D outcomes into clinical applications. Just last month, we launched the Greater Area Clinical Trial Collaboration Platform. It was set up alongside the Legal Study Academic Center under the Greater Area International Clinical Trial Institute. Both are located in the Shing-Tung Science and Technology Innovation Cooperation Zone, and heavily driving development in Hong Kong, Shenzhen, and rapidly becoming a global identity. We work closely with our main partner to streamline cross-boundary clinical trials. We aim to provide a one-stop support platform for medical research and development institutions worldwide, and accelerate the translation of cutting-edge medical technology into clinical applications. Ladies and gentlemen, we look forward to working with a world of experts and professionals to solve the problems and embrace the opportunities brought by the rapid development of technology. I'm confident that the International Alliance of Academicians and all of you here will continue to play a vital role in fostering global scientific cooperation. While you enjoy the forum and this especially of gathering of bright minds in Hong Kong, do take some time to rejoice in this world city as well, which is fast rising as an East-West center for international cultural exchange. The pursuit of knowledge knows no boundaries. Neither should our cooperation. I wish you all a very productive and inspiring forum. Thank you.
Thank you, Chief Executive. Next, let's give the warmest round of applause to welcome Professor Nancy Yip, Chair of the International Alliance of Academicians and President of the Hong Kong University of Science and Technology, to deliver the welcoming speech. Professor Yip, please.
Professor Shing-Tung, Mr. Li Maozhou, distinguished guests, esteemed colleagues, ladies and gentlemen, good morning. As the president of the International Alliance of Academicians, IAA, it is my immense honor to welcome all of you to the 2026 International Academicians Hong Kong Forum. The IAA was established to foster partnerships across borders, across disciplines, in order to advance scientific knowledge and drive innovation to address humanity's current pressing challenges. Today, we are very proud to bring you this forum in partnership with the Hong Kong Association of Overseas Returned Scholars and with support from the Innovation and Technology Commission. Centered on the intersecting themes of AI for aging and AI in higher education, this transformative event aims to explore AI innovations across both health and education sectors and identify practical pathways in order to accelerate the real-world impact. From supporting healthy aging and managing chronic diseases to adaptive leading platforms for learning that widen participation and boost outcomes in universities, AI technologies indeed have the potential to reshape societal approaches to both health and education. We have a truly world-class lineup to share their insights with us. Nobel laureate Professor Arieh Warshel, a pioneer in computational studies of the functional properties of biological molecules, and Fields Medalist Professor Shing-Tung, renowned for his contributions to mathematics and theoretical physics, will present the plenary lectures this morning. We are grateful for the unwavering support of our local academic community. It is our honor to welcome the presidents and the vice presidents from all 8 publicly funded universities to participate in our university presidents' roundtable discussion later this morning. Together, they will explore how higher education can contribute to shaping a more intelligent and a more sustainable future. We also welcome both local and international academicians and pioneers in the fields of medicine, AI, and higher education. They will share their insights during the roundtable discussion, as well as in 2 thematic sessions. One theme is on AI and chronic disease management, challenges and innovations. The second theme is on AI and innovation in higher education. Today's forum aims to inspire fresh insights and innovative ideas. I encourage each of you to challenge your own perspectives, engage in meaningful dialogues, and foster new connections. Your participation in this forum will play a crucial role in transforming the ideas and solutions that will emerge today into impactful outcomes. In closing, I would like to extend my deepest gratitude again to Professor Shing-Tung for officiating this flagship event. My heartfelt appreciation also goes to my co-chairs, Professors Pierre-Louis Lyons, Professor Chris Persevardes, and Professor Zhang Xiang, as well as the executive committee members, our distinguished speakers, partners, sponsors, and all those whose dedication has been instrumental in making this event possible. Thank you once again for joining us today, and I wish you all a day that is filled with insightful intellectual exchange, and we look forward to the cross-disciplinary alliances that are certain to emerge after today's forum. Thank you again for being here today to join this very meaningful event. Thank you.
Thank you, Professor Yu. Please be seated. Next, may I invite Professor Dong Xuan, Secretary for Innovation, Technology and Industry Bureau, Government of the Hong Kong Special Administrative Region, to deliver his opening remarks. Professor Xuan, please.
Professor Nancy Yip, Mr. Liu Maozhou, Professor Tu, Professor Yao, Professor Waschel, distinguished guests and speakers, ladies and gentlemen, good morning. It is my great pleasure to join you all today at the opening ceremony of the 2026 International Alliance Hong Kong Forum. As an international academic organization rooted in Hong Kong, the Alliance of International Academicians, IAA in short, has demonstrated remarkable foresight in fostering deep interdisciplinary collaboration by building a distinguished platform for high-level academic exchange. IAA has capitalized on Hong Kong's connectivity and academic strengths to enhance academic excellence, accelerate knowledge transfer, spark innovation partnerships, and reinforces Hong Kong's role as a nexus for global scientific excellence. Today's forum exemplifies this vision, bringing together leading minds to explore two themes of profound global relevance, namely aging and chronic disease management, challenges and innovation, and AI and innovation in higher education. The Hong Kong SAR government has introduced a series of forward-looking initiatives in recent years to strengthen our innovation and technology ecosystem, particularly in AI and life and health technologies. We are investing strategically in research funding, talent development, and world-class infrastructure. At present, there are 30 research centers under the two Inno-Hong Kong research clusters, focusing on health technologies and AI and robotics, bringing together 3,000 top-notch researchers from more than 12 jurisdictions. 8 more centers on sustainable development, energy, advanced manufacturing, and materials will be established within this year. We are also pressing ahead with the development of the Hong Kong Shenzhen Innovation and Technology Park, as well as the construction of the 17th Technopole and Sandy-Ridge Data Facility Cluster. Through funding schemes such as the research, academic, and industry sectors 1+ scheme, and the forthcoming Innovation and Technology Industry R&D Fund, we are building robust cross-sector collaboration platforms that connect the government, the industry, academic, research, and investment sectors to create an ideal INT environment where scientific discovery can translate swiftly into real-world impact. Hong Kong's solid R&D capability and unique role as a super connector and a super value adder place us in a pivotal position to foster international INT collaboration. This week's events offer a vivid demonstration of Hong Kong's role. Alongside this forum, Hong Kong is hosting 2 flagship INT events: the World Internet Conference Asia Pacific Summit and InnoEX. Their presence here underscores Hong Kong's capability to gather global talent, capital, and enterprises, and to bring together scientific leaders, industry pioneers, and policymakers within a single week. It is a powerful reminder that Hong Kong is a place where the world comes together to chart the future of innovation. As we look ahead, I encourage all participating experts to make full use of Hong Kong as a platform for deeper collaboration with both Chinese mainland and international partners. Whether in health aging, chronic disease management, AI-enabled education, or frontier technology yet to emerge, Hong Kong offers a fertile ground where ideas flourish and global challenges addressed. May I also take this opportunity to invite you to visit our InnoEX, which is taking place next door at the Hong Kong Convention and Exhibition Center, to experience Hong Kong's robust INT ecosystem. In closing, I wish you all an inspiring, impactful, and visionary day ahead. Thank you.
Thank you, Professor Sun. Please remain on stage. Thank you. Ladies and gentlemen, the kick-off ceremony of IAA is about to commence. To mark this exciting occasion, it is my great honor to invite the following guests to join Professor Sun on stage for the launching ceremony. Let's put our hands together to welcome Professor Nancy Yi, please. Also, let's welcome Mr. Mao Zhou Liu. Professor Shing-Tung Yao. Professor Ariel Warshall. Mr. Ivan K.B. Lee. Professor Alexander Ping Kong Wai. Professor Yi Ke Guo. Welcome, Professor Guo, please. And Professor Chak-Shing Lau. The Honorable Duncan Chiu. And Professor Wen Wei Tu. Welcome all our distinguished guests on stage. Now, may I invite our guests, please put your hand together on the LED screen. Before we start our kick-off ceremony, let's take a photo first. So would you please face the photographer in front of the stage? Maybe secretary, right hand please. Thank you. Excellent, thank you, thank you. All right, would you please face our camera in the front? And let's take a photo out together. Please keep your big smile. And also, please face our media friends at the back. Our media friends, camera, please. Thank you. So are you ready to launch the 2026 International Academicians Hong Kong Forum? Ready? 5, 4, 3, 2, 1. Congratulations! I hereby announce the official opening of the 2026 International Academicians Hong Kong Forum. To mark this memorable moment, may I invite all our distinguished guests to please proceed forward to take another group photo at this important occasion. Thank you. Would our guests please step forward and please step closer towards each other. In one row, please. Closer and closer, please. Thank you. And then please face our official photographer at the center point in the front, please. Thank you so much. All right. Are you ready? 3, 2, 1. Smile. And also, our media friends at the back, please. Ready? 3, 2, 1. Thank you. Would our guests of honor please remain on stage? We now warmly invite all speakers and distinguished guests to join our honorable guests on stage. This is truly a moment to celebrate. The gathering of so many brilliant minds under one roof reflects the power of international collaboration and shared vision. Let us take a moment to acknowledge the extraordinary efforts of the International Alliance of Academicians and all partners who have made this forum possible. Congratulations once again to everyone here for being part of this historic occasion. We all look forward to seeing the fruitful outcomes that will surely emerge from today's exchanges. Now, as our distinguished guests make their way to the stage, please join me in a warm round of applause to honor their outstanding contributions to science and humanity. We are already right, so now let us warmly welcome Engineer Professor C.C. Chan. Mr. Hendrickson. Let's put our hands together to welcome all our distinguished guests. Thank you for joining us. May I invite Mr. Lawrence Chi Chong Cheng, Dr. Yin Xing Hao, and now may I invite the following guests to join us on the second row. We have Professor Vivian Wing Hua Yam, Professor Li Wenjiang, Professor Ben Yang, Professor Anderson Ho Cheng Sham, Professor Xin Yao, Professor Dragan Geshufic, Distinguished Professor of Learning and Analytics of Monash University. Welcome. Professor John T. O'Brien, Professor of Old Age Psychiatry, Department of Psychiatry, University of Cambridge. Professor Zheng Zhang, Founder and Chief Scientist of the Hong Kong U Shanghai Cross Innovation Lab. Professor Wenming Wu, Vice President of the Peking Union Medical College Hospital. Professor Dae-Hoon Kim, Professor of Medicine of Harvard Medical School. Professor Hidenori Alai, President of the National Center of Geriatrics and Gerontology, NCGG, Japan. Professor Jacqueline Kwan Yok-yoon, Clinical Assistant Professor of Department of Medicine, the University of Hong Kong. And Engineer Dr. Alex Chan. Welcome our guests. Let us take another group photo at this memorable moment. With our guests in the second row, please make sure you can face the camera in the front. Please show us your brightest smile. And our honorable guests, one step backward, please, closer to our other guests at the back. Thank you so much. All right. Are you ready? Please face our official camera first. 3, 2, 1. Excellent. Dear friends, ready? 3, 2, 1. Thank you. Please remain on stage. We now invite our EC members and representatives from supporting organizations to join us on stage for our final photograph. Let's give them a wonderful round of applause. The distinguished guests are Mr. Ken Wong, Executive Vice President and President of Lenovo Solutions and Services Group. Mr. Guanhua Chen, Director of MedFirst Limited. Welcome. Ms. Yi-Man Liu, Executive Director and CEO of Huashang Technology and Education Group Company Limited. Ms. Phoebe Leung, Executive Director of Smart City Consortium. Mr. Hoi Shan-Shu, Director of Beijing Hong Kong Academic Exchange Center. Professor Lin Qin, Assistant Dean, Mainland Affairs of Faculty of Medicine, the Chinese University of Hong Kong. Professor Jian Lu, Dean of College of Engineering of the City University of Hong Kong. Professor Hui Lin, Emeritus Professor of Departments of Geography and Resource Management, the Chinese University of Hong Kong. Mr. Alfred Zhang, Honorary President of the Hong Kong Association of Overseas Returned Scholars, HKAORS. Professor Jian Guo Dai, Head and Chair Professor of Structural Engineering, Department of Architecture and Civil Engineering, City University of Hong Kong. Professor Song Guo, Chair Professor of Departments of Computer Science and Engineering, the Hong Kong University of Science and Technology. Professor Jun Yu, Director of the State's Key Laboratory of Digestive Disease, the Chinese University of Hong Kong. And Mr. Hong Yang, Board Member of the International Alliance of Academicians. Welcome, all our EC members and representatives from supporting organizations. Thank you. So please take your places and let's get ready for our final group photo. All right, please make sure you can face the cameras in the front. All right, would you please face our official photographer? Ready? 3, 2, 1. Smile for the camera, please. Also, please face our media friends camera at the back. Ready? 3, 2, 1. Also, we are taking video. On my count of 3, would you please give a big like, show through a thumbs up. Ready? 3, 2, 1. Thumbs up. Excellent. Let's give another big round of applause to thank all our honorable guests on stage. Thank you. Please be seated. May I firstly invite our visiting guests, please return to your seats first. Thank you so much. And also thank you to all our other honorable guests on stage. Please be seated. Thanks a lot. Today's forum brings together numerous distinguished academicians, leading scholars, and participants from around the world. Together, they will share the latest research findings, spark ideas, and co-create a vision for an intelligent future, with a focus on the innovative applications of artificial intelligence in health and education. As we prepare to dive into the first plenary lecture, let us take a brief moment to reflect on the significance of this gathering. Today, you will hear from world-renowned experts who are pushing the boundaries of knowledge. So please sit back, perhaps take a sip of water, and get ready for an intellectual journey. We will now kick off our first major session of the day. For your convenience, a QR code is posted in the top right corner of the screen, allowing you to submit questions at any point during the presentations and discussions. To chair this session, we are honored to welcome Professor Wen-Wei Tu, President of the Hong Kong Association of Overseas Returned Scholars, HKAORS, and Secretary General of the International Alliance of Academicians to the stage. Let's welcome Professor Tu, please.
It's my great pleasure to open today's plenary lecture by introducing our distinguished speaker, Professor Shing-Tung Yao. Professor Yao's work has fundamentally reshaped our understanding of geometry and physics. In 1982, he was awarded the Fields Medal for his groundbreaking contributions to differential geometry. Most notably, he proved the Galilee conjecture as a recipient of the Wolf Prize, the Crawford Prize, and the MacArthur Fellowship, and the Marcel Grossman Award and the Shaw Prize. Professor Yao has inspired generations of mathematicians globally. Please join me to welcome Professor Shing-Tung Yao.
Professor Nancy Yip and the conference organizer, thank you for your invitation. Ladies and gentlemen, today I stand before you to talk about mathematics, not only out of my lifelong passion towards mathematics, but more importantly, because mathematics is the fundamental cornerstone of science and technology. There can be no cutting-edge science such as AI or innovative technology without a solid foundation in mathematics. The truth is equally vital to Hong Kong's development as an international hub for innovation and technology. Hong Kong's pursuit of high-quality development for drive to build a world-class innovation
ecosystem and its efforts to enhance core competitiveness all depend heavily on mathematics as the underlying support. Developing mathematics and advancing technologies are not separate endeavors, but two sides of the same coin, highly aligned in their goals and mutually reinforcement. Throughout the history of global development, nearly all major cities and countries have come to a profound realization. It is a misunderstanding to believe that focusing solely on technological development is sufficient. In fact, technological breakthroughs and sustainable development can only be achieved by building a solid foundation in basic science. And mathematics is the most core and essential component of basic science. A classical example is the great famous university MIT. Its engineering disciplines have long stood at the forefront of the world, gaining global acclaim for their innovation and influence. Yet, what many fail to recognize is that MIT's engineering excellency is built on its world-class mathematics development, constantly ranked the top 3 in the whole world. It is the strong support of mathematics that empowers MIT's engineers and scientists to continuously break through technological bottlenecks, explore new frontiers, and maintain in leading positions in global technology and engineering. This is why we attach such great importance to mathematics, why we take pride in the development of Chinese mathematics, and why we firmly believe that hosting International Congress Mathematics True Field in Hong Kong will not only showcase the progress of mathematics in China and Hong Kong to the world, but also further promote the integration of mathematics, science, technology, and regional developments. So I would like to say a few words about the history of such a development. As the Republic of China began, a group of young scholars driven by a deep belief that science would save their nation went abroad to study, where mathematics were already flourishing, places like the United States, Europe, and Japan. They studied under the giants of the field at well-renowned institutions like Cambridge, Princeton, and the University of Chicago. This group included brilliant minds such as my teacher, Shing-Tung, and the famous Chinese mathematician Logan Wang. Yet, even as they earned international acclaim, their hearts remained at home, deeply devoted to building up mathematics in China. This is a very important fact. Later, with the founding of the People's Republic of China, the country faced a critical need for scientific and technological talent. Mathematics, the very foundation of so much scientific progress, has stalled, suffering from a severe shortage of experts. Then, Professor Wang returned to China in 1950 and formed the Institute of Mathematics at the Chinese Academy of Science. In the 1980s, Professor Chen returned to China to lead mathematics research and nurture young talent. He later continued to support Chinese mathematics and helped establish the Chen Institute of Mathematics in Nankai University. Together, they formed the core of modern Chinese mathematics. Looking back, the return of overseas scholars was a monumental turning point. They didn't just build China's modern mathematical research and education system, they brought with them a perfect blend of scientific brilliance and a deep enduring devotion to their homeland. Well, let's look at the future, the present and the future. Up to back in 1950, Professor Chen made history as the first Chinese mathematician to be invited to give a 1-hour plenary lecture at the Congress. That happens in Harvard University. Up to now, Chinese mathematicians have received a total of 160 invitations to speak at the ICM, International Congress of Mathematics, including 14 1-hour plenary lectures. In 2022 alone, 28 scholars were invited to present their talks. These numbers are a testament to the steadily growing influence of Chinese mathematics on the world stage. In my view, a pivotal movement in China's global integration was hosting the 24th International Congress of Congress of Mathematicians in Beijing in 2002. The momentum began in 1994 when Professor Chen and I went to Zhongnankai to propose to President Jiang Zemin that China had to bid for the ICM 2002. President Jiang Zemin expressed great enthusiasm and full support of the for hosting the Congress. When the Congress took place, he personally presented the field medals in the Great Hall of the People. This level of national support reflects Chinese recognition of mathematicians as the cornerstone of basic science and the nation's commitment to integrate into the global academic community. The success of ICM 2002 proved to be a powerful catalyst for Chinese mathematics. In the decade that followed, a billion new generation emerged. Many who would go on to become global leaders in their fields. This group includes outstanding mathematicians like Konglun Leung, Zhao Shen in CUHK in Hong Kong, Fu in Fudan University, He in Hong Kong University, Wu Hao and Shan Peng in Tsinghua University, Tian Ye in the Chinese Academy, Yuan Junyin in Peking University, Yun Ziwei and Zhang Wei in MIT, and Zhu Xinwen in Stanford. These are very distinguished young scientists, young mathematicians that are changing the world. The momentum from the 2002 ICM has been growing, nurturing rising mathematical stars such as Deng Yu, Ding Jian, Li Si, Tang Yunqin, and Wang Hong, most of whom pursued graduate study in Europe or North America. In recent years, many outstanding mathematicians have returned to China to conduct research and nurture talent, helping modern mathematics to take root in China and thrive locally. This is very important for the development in the last 20 years. With this momentum, Chinese applied for Hong Kong to host the 2030 ICM, which will boost China's mathematical community and enable greater contribution to global mathematics. Since 1979, I have returned to China every year to help developing mathematics in this country, in my motherland. In those early days, I noticed that Chinese mathematicians were scattering all over the globe, with very little communication between them. They lacked the networking to stay connected in cutting-edge breakthroughs, and they didn't have access to top-tier spaces for collaborations. To solve this, I found an organization called the International Congress of Chinese Mathematicians, ICCM. In 1998, and later I established the International Consortium of Chinese Mathematicians. The goal of this ICCM was simple: to unite the collective talent of Chinese scholars worldwide, breaking down the barriers of isolation and build an open, world-class platform for collaborations. After more than 2 decades of dedicated efforts, the ICCM has become a vital bridge. It connects scholars and young talents at home with the cutting edge of global research. At the same time, it makes it easier for overseas Chinese mathematicians to stay engaged with the remarkable progress happening back in China. It has amplified the voice of Chinese mathematicians on the world stage and played a major role in the rapid rise of mathematics in China. For a prime example of this remarkable progress, we can look at the major academic breakthroughs in the last 10 years. One is achieved by Yu Ping, and one other one by Xue-Jinsheng at Tsinghua University. Yu Ping, after returning from Princeton University, had made a major breakthrough in high-dimensional shortwave theory. And Xue-Jinsheng, after coming back from the University of Chicago, he solved the century-old mathematical problem called the plenary conjecture concerning many body problems. The ICCM had also established other prestigious awards, including the ICCM Mathematics Award, which is widely known as the Chinese Fields Medal. Many of our past laureates have chosen to return home, where they continue to achieve landmark results. Take, for example, the gold medalist of the ICCM Mathematics Award, He Xufang, Tian Ye, and Ding Jian. They are affiliated to Hong Kong University, to the Chinese Academy of Science and Peking University, respectively. After they return, they have solved major long-standing problems, which many of the results published in the top international journals. And many ICCM award-winning scholars, including Liu Yifeng, including Li Si, Wang Guozhen, have returned to China to build world-class research teams at top universities. Chen Gao, Chun Miao, and others have made major breakthroughs in geometric analysis, nonlinear partial differential equation, and other fields after their return. They have not only lifted Chinese mathematics to the forefront of the world, but also play a key role in nurturing the next generation of domestic mathematical talent. In addition to attracting the outstanding Chinese scholar back from overseas to pursue academic careers, we have also successfully drawn many distinguished non-Chinese mathematicians to join in full-time. Taking Tsinghua University alone, it has recruited a group of well-leading non-Chinese mathematicians to its faculty, including the Fields medalist Koji Becker, who has been there for 4 years, and Keiji Fukaya, who won the Shaw Prize last year, and McCovis, who is a chair professor from Oxford University. Li Shutikan is a chair professor from Berkeley. Futaki is a major figure in geometric analysis. Don Rubin from Harvard University. All of these people are highly sought after scholars, even by the very top university, such as Harvard or MIT. So these are remarkable group of people. Expanding on this reason, I formed the Chinese International Congress of Basic Science a few years ago. It has been a major event focused on mathematics, physics, and engineering. We also launched the Basic Science Lifetime Award and Frontiers of Science Award. And over the past 3 years, many great scientists leading the science in the whole world have come and joining the event. Throughout years of relentless efforts, Chinese mathematics has entered a golden age. As someone who has both witnessed and helped derive this progress, I feel this deeply personally. China now produces groundbreaking efforts in pure mathematics, applied mathematics, and interdisciplinary areas, with its research frequently published in top journals. Well, these breakthroughs published in top international journals across many different fields, including fluid dynamics and algebraic geometry, etc. They have built a solid foundation for our bid to host ICM International Congress of Mathematics 2030, will showcase collective strength of Chinese mathematics to the world. Well, having reflected on the broader journey of Chinese mathematicians, I'd like to turn to focus on Hong Kong. I grew up in Hong Kong, and this city was the starting point of my journey in mathematics. Hong Kong has a profound history and has a great tradition since World War II. I graduated from a high school called Puijing Middle School, and the school alone actually has nurtured about 6 to 7 members of the National Academy of Science in America, and 3 of them, including Alfred Cho, Dan Chu, and myself, was awarded the National Medal of Science in America, a highest scientific honor in the United States. And Danny Chu was awarded the Fields Medal, the Nobel Prize later. Hong Kong has a profound gathering of highly influential mathematicians who has advanced and dedicated to applied mathematics and also statistics. 2 absolutely outstanding statisticians, Wing Wong and also Feng, Professor Feng, has been the professor in Chinese University of Hong Kong. And there's a large group of outstanding leading statisticians and applied mathematicians in Hong Kong, including Zhao Bingxin, Tony Chen, Raymond Chen, and many other outstanding people. And I'm proud to say that Hong Kong is doing very well in terms of these recruitments and has educated first-class people. Now, Hong Kong has many international renowned scholars, including Ngai Mingmo, S.Y. Cheng, and several many outstanding people have been promoting science and also applied science. Hong Kong is home to 10 Science Fellows and 5 AMS Fellows, and including 1 Fellow of the Royal Society of Canada and 1 member of the Academy Europeans. These applied mathematicians have been invited to speak at the ICM, and over 1/3 of faculty members serve on the editorial board of leading international mathematical journals. And these are really outstanding achievements, but we should still look at the future. We have invite and recruit outstanding mathematicians like Yi Ma to Hong Kong University and Wei Junchen to CUHK. Well, years of experience in talent cultivation has led to the firm conviction China must nurture world-class mathematicians on its own soil. This is something that I think Hong Kong should do. With strong support from the from the central government, we launched an 8-year program in Tsinghua University, forming Children's College. With the blessing of the President of China, the Children's College was able to recruit the world-class students, and they will come as a first grade in undergraduate and all the way to, after 8 years, to earn their PhD. And this has been very exciting event because this broke through the existing difficulty in the Gaokao system in China. But after just 5 years, Children's College has already delivered remarkable early results and even exceeded my expectation. Drawing in the middle model of Children's College, the Zhizhen College at the Chinese University of Hong Kong just started last year. It adapts a similar approach and leveraging Hong Kong's unique strength with the aim of nurturing outstanding leading talents locally in Hong Kong. I expect to grow homegrown leaders by 2030, achieve great honors in the world, and I hope they will be awarded the Chen Prize and Fields Medal breakthroughs by 2034 by the local grown Chinese mathematicians, not just from outside trained scholars. And therefore, Hong Kong's bid for ICM 2030 will be utmostly important. Well, beyond fostering world-class research and nurturing exceptional goals, we also reach out to high school, junior high schools at more than 50 top high schools across mainland China. We have established a robust talent pipeline, channeling a large number of outstanding middle and high school students to both Children's College and also many important universities in China, including Beijing University and all that. Each year, we train 3,000 students. These are the most talented students that I have ever seen in my life. And they are extremely original in their thinking, and I think we should encourage this more. At present, such a training has not occurred in Hong Kong. And I really encourage the government in Hong Kong and the university in Hong Kong will adapt this system. And I think this will be very important for Hong Kong. Well, while major countries struggle to separate academia from politics, we understand the ICM this year being held in Philadelphia in America is being boycotted by more than 2,000 mathematicians because of the American involvement in the Iran war. And last time in 2022, ICM was supposed to be held in St. Petersburg in Russia. It was boycotted because of the Ukraine war. So both 2022 and 2024 or 2026 ICM was encountering great difficulty because of geopolitical problem. But Hong Kong is very unique. Hong Kong remains one of the few fully open and truly global cities. Backed by the Chinese mainland, we can steadily host top scientists worldwide and build Hong Kong into a world-leading academic hub. We have proposed establish an Asian Mathematical Society center in Hong Kong that will cover China, Russia, India, Japan, Iran, and beyond, regardless their politics across Asia and the globe. And we believe this will be a future of Hong Kong being the hub of the whole world in advanced mathematics. And collectively, we can work together with both Hong Kong universities, Chinese universities, and beyond. And I see a bright future of Hong Kong mathematics community. Thank you.
Thanks, Professor Yao, for your wonderful and inspiring lecture. So please remain on stage. We have collected some questions, but since the time constraint, only one quick questions. So the question is, what does Hong Kong's unique position mean for hosting an international academic congress like ICM? Please.
Well, I just mentioned, Hong Kong is almost a unique city who has very solid background in mathematics, as I explained to you, and with the backing of the whole Chinese community from whole China, we have no problem in the string of mathematics, but at the same time, it's the only city who does not visa for more than 170 countries. In both Russia and America, the hosting of ICM encounter great difficulty because of the geopolitical problem. They deny visas to speakers. They deny visas for people attending the conference. And Hong Kong, by law, would not have that problem. And our students are enthusiastic. We have more than 3,000 students has expressed great interest to come to Hong Kong to attend the conference. And beyond that, the ICM or the IMU strongly support third world countries participate. And all the developing countries, including African, including Latin America, including India, South Asia, and Mid-Asia, they all supporting Hong Kong. They feel strongly Hong Kong is a country which does not give any racist or discriminatory comments about their presence. And I think this is a unique and best place for ICM.
Okay, thank you again, Professor Yao. Please be seated. Now it's my absolute honor to introduce another touring figure in global science, Professor Erin Washoe. Professor Washer is a distinguished professor of chemistry and biochemistry at the University of South California and the director of Washer Institute for Computational Biology at the Chinese University of Hong Kong, Shenzhen. In 2013, he was awarded a Nobel Prize in Chemistry for developing multiple-scale models that allow computers to map complex chemical reactions. His groundbreaking work bridged the gap between classical and quantum mechanics, fundamentally changing how we understand biochemistry today. We are incredibly honored to have Professor Washer share his insights with us. Professor Washer, the floor is yours.
How do I control it? What?
Going one, yes. Okay.
How do I go backward?
We have reversed. If you want to just tell me.
Okay. It is a very great pleasure for me to attend this forum. I particularly want to thank Professor Joy Quinn, the president of Nanyang University, for inviting me this time to Hong Kong. Now, because of the time, I will try to go to my main subject of the lecture. By the way, I completely agree with the previous speaker that mathematics is the basic of almost everything. But though my mathematics was mainly numerical one at the time where numerical mathematics was considered a very bad idea. Now, what I will try to describe in my talk is the connection, the interplay between physical-based simulation, which is my main field, to artificial intelligence. And extremely small, okay. Okay, so I will start with the action of enzymes. Enzymes are protein molecules that do the chemistry in the body, and they do it much, much faster than regular chemistry without the enzymes. And one of the main puzzles has been for a long time of why enzymes are so powerful and so fast. It's related to the barrier of breaking bonds, which is reduced by the enzymes. And of course, there is a question how it's being done. And this puzzle, I was interested in it since 1964. So enzymes play a major role in every life processes, also not in life processes. There are many enzymes. They involve, of course, in biology, disease, and industry. Now, I started to be interested in enzyme in the university in 1964. And during the year, I was kind of felt or said that one day I will figure out how enzymes work. This took very long time. And a key stage was developing a way to model the chemistry of bond breaking and bond making in enzymes. Now, this was a major challenge at the 70s because to describe chemistry, you have to describe you have to use quantum mechanics, which is in principle could solve everything, maybe not gravitation, but it takes a lot of computer time, and it would have been completely crazy to try to model quantum mechanically protein with thousands and thousands of atoms. So we come with the multi-scale idea of restricting quantum mechanics only to small part of the system where the chemistry occurs, and to describe the rest of the system by much simpler force field approach, where the electric field of the surrounding is incorporated into the quantum mechanics. This approach was found to be very powerful, and for example, we use it for many types of key enzymes which are involved in diseases. For example, there is the enzyme RAS, which when it has the wrong mutations, you get sick with cancer. And this happened because the hydrolysis of a phosphate-oxygen bond become too slow. So we try to understand it by the QMMM and by simulations, by doing what is called free energy perturbation. And we clearly could produce these nice movies of the chemistry when a water molecule split and the OH minus attack the phosphate. So we could produce nice movies of the time dependent, but the key question has been and still is, could you reproduce the work of breaking the bond of what is called the activation barrier? The higher the barrier, the slower the reaction. So what you see here, the lower one is the barrier in the good enzyme. Above it, we see the barrier when we have mutations that lead to cancer. So we could reproduce this. We could study many enzymes, and we could also ask the question, why enzymes are so efficient? And the reason why we could ask this question, which could not ever be solved experimentally because enzymes is too complicated, so you need a computer to do it. I mean, it does not mean that the computer will do it correctly, but only simulation could actually do it. And what you see in these slides are the barriers in the absence of the enzyme. These are the blue lines. The red one are the barriers with the enzymes for many enzymes. And after we reproduce the catalytic effect of many enzymes, we could go back and ask why they are so fast. And we came up with the very simple, not fast accepted, that the enzyme apply electric field that stabilize the broken bond. When you break a bond, you create usually charges, and the enzyme create complementary environment to these charges. It's in fact a little more complicated, but this is the short story. Now, in addition to figuring out why enzymes are so powerful, there remain a problem because people do not necessarily believe to this result, and they want to be convinced by prediction. Now, our computer predict the overall catalytic power of the enzyme, but people want you to perform miracles, which means to create new enzymes. I'm not excited from this expectation, but people want you to do something that proves that you know what you are doing, rather than believing the computer. And they want you to be able to design mutation in enzymes that could be verified experimentally. So there are several ways to design or to change enzymes. One is what is called directed evolution. This is an experimental way where you take an enzyme, put it in solutions, create many mutations, and pick the fastest enzyme, and then you do another round and another round, and you get better enzymes. So this approach, which gave Arnold her Nobel Prize, it's basically used the trick of evolution, no computer, and it works to some extent. We are more ambitious. We want to be able to use computers to predict it. And again, from my point of view, it's much more important to explain why enzymes do things much faster than without the enzymes, but the popular demand is to do predictions. So we could use our computations to do mutations by changing gradually one residue to another by what is called free energy perturbation. We have been doing it since 1987. We got kind of moderate success of predicting known mutation, but people are more interested in taking artificial enzymes, which were designed from scratch, and predicting or reproducing what was found by directed evolution. So we could predict known mutations in this artificial enzyme camp eliminase, but at some stage we decide to take the major challenge of predicting what would be found by directed evolution. For this, we use major computer power, major effort, and we end up with moderate success, which means that we generated many mutants automatically. Our best mutants were at the lowest energy, but not exactly at the same energy of the observed mutant. So this is a kind of moderate success. We don't know what it will take to get perfect results, maybe more powerful computers. I never give up, but again, when we got stuck in this, not being able to reproduce exactly directed evolution, we turn out, like everybody else, to artificial intelligence. So the question, why I'm showing this slide, I think I remember. So our competition with artificial intelligence started essentially in 1975, where we generated the first computer simulation of protein folding with Michael Levitt and me. And it was done by simplifying the protein, replacing the amino acid by spheres. We were interested, or I was interested, in the process of folding, proving that it could happen in reasonable time, because there was what was called the Leventhal paradox, which claims that protein could never be folded because it has too many degrees of freedom. So we showed this but we were unable to predict the exact structure of the protein. I did not care too much, but the scientific community was still obsessed in predicting structure. I felt that I want to understand how you take structure and get function. So this is where AI has a major victory many years later. 2 years ago, they got the Nobel Prize. This was the year of 2 Nobel Prize to AI, and this is AlphaFold. Okay, so this is where AI did something remarkable. Still in the field of enzyme catalysis, they have not done much. We were aware of studies that use what is called maximum entropy, which is the chance that a given residue will be at a given site, and that people show that this gives correlation with activity. So my Chinese postdoc, Wan Junxi, came with the suggestion to use it. And what is maximum entropy? As I said, you run over many, many proteins of the same family and try to see what is the chance of a given residue from the 24 possible amino acid to be at a given site. And to our surprise, not really surprise, we got beautiful correlation between, anyhow, all of these slides look the same, a beautiful correlation between the maximum entropy to the speed of the enzymes. So this meant that we could predict what mutations will make the enzyme faster, or that we might be able to do it. These are different enzymes, and this is a table that we don't have time to see. And one of the things that we did that to me was the most impressive, we took an enzyme called allohalogenase. It's the one that split carbon chloride or bromide bond, and we found sequences that could be faster than the nature evolved enzyme. Now, to me, this is much more. It's extremely easy to take artificial enzyme, which is extremely bad, and to make it better. But to compete with evolution is really difficult. So we found sequences which could make the enzyme faster than evolution. And I will skip this because we have, oh, no. Okay, it's not in this presentation, but we were able to predict mutations that will make the allogeneic faster than the wild type, and we verified experimentally. We also use maximum entropy to predict the stability of enzymes, and it works very well. I will go faster because, okay, this is the experiment where we predict mutations that are faster than the wild type enzyme. Another directions where we went, which is a little more complicated than regular enzyme catalysis, is bioluminescence. There are these creatures that want to shine light, but they want it to be in the blue or the violet because otherwise the water will absorb the light. So there is huge interest to find the enzyme called luciferase, and to have mutations that make it work better. This is the active factor in luciferase. We studied theoretically by figuring out how it works, but again, at the time that we spend simulating the enzyme, we also try to use maximum entropy. And again, this was even bigger surprise because this is not a real enzyme. It absorbs light, reacts with oxygen, and then it emits light. Again, beautiful correlation of the wavelengths with maximum entropy. And maybe the right slide will come. We succeed to predict mutants that will go further to the blue. Another directions where we try recently to use maximum entropy was something that I tried for a very long time. It's fighting with drug resistance. As you know, it's one of the main problems in medicine. People take drugs, the pathogen gets used to the drug and mutate itself not to bind the drug. So we studied this first by computations, by physically based approach. We try to find mutations that will not like to bind the drug, but we also exploit the fact that the pathogens want to do chemistry, and it cannot mutate in a way that will make its chemistry less good. So we focus on what is called vitality, which reflects the strength of binding and the ability to do chemistry. Sorry, this is the vitality. It's the catalysis and the binding product. And we try to calculate vitality for different diseases, like this is HCV. We got decent result for the catalysis, decent result for binding, but not good enough computations. For small numbers, it's really tough to get the exact result. We still don't know why. So again, this showed the problems. We went to AI. I had a great hope. We find, again, very nice correlation, but unfortunately, one of my students, this is bad, one of my students noted that we obtained the same correlation by what is called the Hamming distance, which is the number of mutation. So we could use the correlation if we have enough experiment to figure out which are the best drugs to fight the disease. But you could do it just by saying in HIV protease that the more mutations you do, the harder is for the pathogen to work, but this is not really good. And the problem is that HIV protease has huge number of ability to mutate. Fortunately for other type of pathogens, we got better result. I don't have time to talk about it, so just one more example. We spend a lot of time learning how kinosine and myosin work. Myosin is what apply your muscles. Kinosine carry load in the cell. And the fascinating thing is that it works only in one direction. And there is a great question. Why does it move in one direction? By the way, this question is taboo for the people who study experimentally. I don't know why they don't ask it, but I try to figure it out. This shows the problem that usually two people walk in different direction in the same speed. It's very rare that when they go, it's very rare that one of them walk, and when both of them are healthy, in a slower way. So we spent on it several years, and eventually we came out to the very simple but remarkable conclusion the reason for it is that the barriers for moving forward and moving backward, the rate determining barriers, are slightly different. People in the field believe in words like power stroke. They believe that you move faster to this direction because you leg push, which is of course incorrect, because in the other direction I move in the same speed. So we figure out that clearly what determines it is the slowest step, and we even show that the proteins open in a different way in the rate determining steps in the forward and backward direction. And we were able to simulate it. There is a movie here, but it does not show. And this is crucial because many diseases like heart disease are controlled or happen because of mutation change the speed of movement. So we done several studies proving these points, and in one of the nicest case where this moving kinosine exists, we found that there are mutations that make it move backward, mutations that make it stop, and so on. And we calculate the free energy of the mutations of pulling a group phosphate from the protein and show almost exactly that we could reproduce the height of the barrier and therefore the trend to move forward and backward. We don't have to, these are the mutations. So you have a system where in some cases it moves forward, some mutation it stop, and in one of them it moved backward. And we could reproduce it very nicely by computer simulation, by free energy perturbation, which is the gold standard. We tried to use, again, maximum entropy. It works reasonably well, which led us to believe that we could predict the disease by maximum entropy, but in other cases it did not work. So I think I will skip this and go to the end. We have many stories, but we don't have time. I'm trying to go to the end. Okay. So the end is that there are still many fields where there is a competition between physical-based simulation, where you could understand why things are happening, to artificial intelligence, where you would find what will happen but not always understand. In some rare case, like in the kinosine, we understand what happened by physically based simulation, but we could get prediction by AI. So the takeaway lesson that my knowledge in AI are extremely limited, but I have advantage that I know what to ask, so it sometimes compensate. And there are cases where AI could be extremely important, cases where you have to be very careful. Essentially, this would be my last point. Recently, we will try to see what other people do in enzyme design by AI. My student did, this was about 2 weeks ago, my student did a literature search and found major study by major group, huge groups, which tried to study enzymes by AI. There is one problem. These people have zero clue what enzymes are doing. So what they did, they took a computer program, Rosetta, and trained it on every possible properties stability, binding, everything except on catalysis. So I think this is example of a very bad direction. When you do not know the field and give information which have nothing to do with the property you are studying, and of course, you do not succeed. So thank you very much.
Thank you, Professor Washer, for your fantastic and inspiring lectures. So please remain on stage because our staff sent me a lot of questions from the audience. Since the time that's very limited, so I only choose one maybe interesting questions from maybe I guess from maybe postdoc or young scientists. She or he asked, with the rapid development of AI, such as your Alpha, folds 2, 3, or maybe later 4, 5, or even let's say ChatGPT, do you think AI will one day completely replace the scientists in conduct research for, in the future?
Will AI replace completely what?
AI will be replace scientists to conduct research, such as AlphaGo maybe will replace, let's say, structural biologists.
Try to guess your question. You ask if AI will replace physical-based computations or scientists?
Yes. Yes. What's your perspective?
First, I hope it won't be during my lifetime. And my answer, I don't know, but we have a month and a half ago a Nobel conference in Dubai where the question was, would AI or was AI able to predict general relativistic or quantum mechanics? And I felt that eventually maybe AI could have figured out quantum mechanics. I don't know if so I don't know. I still hope that, just with the example that I gave, that you have to know what to ask. So hopefully no.
Okay, thank you. Again, Professor Washer, please be seated. On behalf of our organization committee, I would like to extend our deepest gratitude to our distinguished speakers, Professor Shing-Tung and Professor Angel Washer. Thank you for sharing your extraordinary insights and wisdom with us today. So this concludes our plenary lecture section. Thank you.
Thank you, Professor Tu, and thank you, Professor Ariel Washoe. Please return to your seats. Thank you. Thank you once again for that fascinating and groundbreaking lecture. Thank you so much for sharing your extraordinary insights and wisdom with us today. It is indeed our great honor to hear from world-renowned experts who are pushing the boundaries of knowledge. Their insights will no doubt inspire new questions, new collaborations, and new solutions. Our next session is the highly anticipated University President Roundtable discussion, titled The New Renaissance, Forging an Intelligent Future for Health and Education. Over the next 60 minutes, these university leaders will engage in an in-depth dialogue focusing on education and health innovation in the age of AI. At the end of the dialogue, there will be a 10-minute segment to share further guidelines and key takeaways. We'll also open the floor for questions, so please use the QR code at the top right corner of the screen to submit your questions anytime for our upcoming speakers. Today, we have the rare privilege of gathering the leaders from 8 local universities in Hong Kong. Without further ado, please join me in welcoming them to the stage. May I invite Professor Alexander Peng Kong Wai, President and Vice Chancellor of the Hong Kong Baptist University, who will serve as our session chair and moderator for this panel discussion. Professor Wai, please. May I also invite Professor Yike Guo, Provost of the Hong Kong University of Science and Technology. Professor Li Wenjiang, Vice Chancellor, Vice President, External Affairs of the Chinese University of Hong Kong. Professor Chak-Sing Lau, Vice President and Vice Chancellor, Health of the University of Hong Kong. Professor John Chi Kin Lee, President and Chair Professor of Curriculum and Instruction, the Education University of Hong Kong. Professor Anderson Ho Chan Shum, Vice President Research of City University of Hong Kong. Professor Xin Yao, Vice President Research and Innovation of Lingnan University. As well as Professor Ben Yang, Vice President, Student and Global Affairs of the Hong Kong Polytechnic University. Welcome. So gentlemen, please be seated. Professor Alexander Wai will lead the discussion for us. Now, let me hand over the time to Professor Wai, please.
Thank you. We have 7 of you, okay? And we are only given 60 minutes. I think 60 minutes for one will be not enough, right? So, all our credentials are in the screen, so I'll save some time by going straight, to the discussions. The format is as follows. Each of you will have 2 minutes to give an opening statement, okay? Then I will ask you a question, and then you have 3 minutes to, answer it. The clock is over there. I don't think it'll ring, but please keep to the time. All right. The theme of the discussion today is around the theme of this conference, the new Renaissance, forging an intelligent future for health and education. Now, you all know this is a very pivotal time for our country. It's the start of our country's 15th five-year plan, and Hong Kong also the very first inaugural five-year plan. So our discussion will explore how we can align our institutional strategy with Dean's broader visions, try to harness the technology, AI in this particular, to address challenges in health and education, and strengthen Hong Kong's role as a bridge connecting the region with the global scientific community. So I look forward to a rich and candid discussion among us. So let's start from my left-hand side, okay? Professor Yong, you can start with an opening statement, 2 minutes.
Thank you. 2 minutes is a long time for me, okay? So I guess I have just 2 points I want to cover, and then certainly there's a great enthusiasm of incorporating AI into health and education. So my first point is for anything which bring in great benefit, we should consider potential risks. There's no free lunch in this world. Okay, that's especially in areas like health and education. When we move AI into it, we need to consider ethical aspects of it, especially in healthcare and education, in terms of equality, in terms of fairness, in terms of security, reliability. The second point I would like to plead to everyone is health and education issues are societal issues. They should not be discussed without a context. Some of you might have followed this AI news. In the latest AI index report published by Stanford, They raised two pieces interesting data I can remember. If you do Grok 4 training, it generated carbon is 72,000 tons, which is equivalent to 17,000 cars running for the whole year in terms of generation of carbon dioxide. Is that related to health? I don't know, but I would like to see a robust debate of it. If you look at the inference, I have this data, GPT-4o's inference each year, consuming the water will be equivalent to 17 million people's drinking water for a year. Is that a health issue? I don't know, but I would like to debate for it. When we are enthusiastically embracing AI into different domains like health and education, I think we should take a broader picture in terms of implications and in terms of impact on humanity as a whole, on the society, and on the planet. That's my 2 cents.
Thank you, Professor Yao. And John, your 2 minutes opening.
Testing. Thank you. I will speak something about education, of course, as I come from Education University of Hong Kong. Now, education, I think now really calls for, I would say, a revolutionary reconsideration, the meaning of curriculum, learning, and assessment. According to one of the paradigms or perspective about curriculum, we talk about a few elements like the role of teachers, the time and space for learning, as well as the organizational experiences within university, within schools and beyond schools, and even embedded into the community. Of course, we also talk about these days the impact of AI on learning. What does it really mean about learning? Of course, when we talk about AI, come across machine learning, about human AI interaction, human-computer interaction, and also about the real meaning of learning, meaning what sort of aspect of learning. We talk about social emotional learning, we talk about interpersonal skills, 21st century skills, and so on. Last but not least, in different levels of schooling and university education, it also closely linked with the notion called assessment. When AI comes in, I'm sure many colleagues here, experts here, can throw light on how personalized assessment together with uniform or more standardized assessment could be coupled all together to chart a new way forward for not only measuring, but also giving feedback to individuals, to institutions about the level and also the nature of learning. So I think it calls for really a dynamic change. As far as the 15 five-year plan is concerned, the AI plus definitely comes into the horizon. I think it links with education, talents, development, and of course, technology. On the one hand, on the other hand, how geographically we could connect. Now with AI, with emerging technology and so on, we can connect almost every part of the globe across time and space. So I've stopped here to provide a backdrop for all of you to input. Thank you.
Thank you, John. Professor Zhang, your 2 minutes.
Hello, everyone. I'm from the Chinese University of Hong Kong. Actually, since last year, our university has been working very hard to develop the next CHK strategic plan, 2026-2030. Okay, we have 5 priorities under the framework, so-called the TIGER. T stands for talent attraction and development. I stand for institutional development. G stands for global and alumni engagement. And E stands for education and student experience. R stands for research and innovation. So I'll give a few examples. For example, under the E, education, we will develop some new AI course for the general education because we have the college system, very unique in CHK. And also some of the faculties, like the faculty of science, we developed the postgraduate program called the AI for Science. So for research, we have 5 strategic area. One of the strategic area called artificial intelligence and mathematics. Professor Yosing mentioned it's really important area at future case. So this really the time for us to develop the strategic area aligned with this new development that will relate with the AI. Thank you.
Thank you. Mr. Guo?
Yeah, thank you. I come from HKAORS, and we at the university now, these two subjects is really deep, very, very close to us. One is the health. As you all know, we are now approved to have the Hong Kong third medical school. So for this, we are really in the stage of planning how this medical school will be. But in our proposal to the new medical school, we focus very much on the technology-driven, in particular AI-driven healthcare. So this is a very, very close to our strategic plan for building the medical school. The second thing is probably you all know, and HKAORS was the first universities which embraced all ChatGPT when it come to the world. And we actually have the long experience about practice use the AI, particularly generative AI, for education. And we learned a lot. You know, there are some lessons to learn, but also a lot of experience. And we are now in the stage of reforming our whole education structure along with the AI technology, in particularly, as John mentioned, right? How do we think about many things? For example, a lot of people criticize the AI can be used, right? If you use AI for examination, then there's a big problem here. But now we have to question ourselves: is the examination, assessment, the mechanism of assessment is probably already out of date. How we change it in the area for AI. So that is a lot of work, and we introduced the whole curriculums of the AI education and make the common core programs as really like mathematics for all the students, and how to actually balance the general AI education with the AI with a discipline focused. So this is a lot of the practice we are doing now. So I'm very happy to hear and discuss this subject.
Thank you. Mr. Lau?
Thank you very much, Alexander. And in the short time that I have, I will try to perhaps mention 2 points. First, how AI actually can definitely, I think, improve health through drug discovery, through conducting clinical trials, etc. We've just heard from Laureate Warsaw how AlphaFold actually is now able to quite accurately predict the protein of the target protein for our drug molecules, etc. So that has really sped up the process of drug discovery. AI can actually also quite accurately predict which group of patients might potentially respond to what treatment to provide more precision treatment, etc. And in terms of clinical trials development, for example, AI could also help through the analysis of big data, help us recruit the patients that we need, monitor the effectiveness or efficacy, as well as the adverse events of new agents, etc. So I think AI definitely will help improve our health. But in the short time that I have, I would also like to sort of raise one concern that I have, and that is how fast AI is moving. We have already heard that, it's really moving too fast. Whether we have the capacity as an institution to really, embrace everything that is in AI, and whether I have the capacity and I have the ability to teach my students or my colleagues to teach my students to embrace the use of AI. And lastly, of course, and I will perhaps talk about this later on as well, about the ethics and the use of AI, as well as while we're using AI, we must never forget, as a doctor, right, the human interaction, which is most important. Thank you very much.
Well put. Thank you. Professor Shen?
Thank you. So the topic, our topic, New Renaissance, I think here calls on universities like us to really work together and forge an intelligent future. And as President Alex Wei mentioned, this is really an opportunity for health and education, especially at the intersection of the nation's 15th five-year plan and also Hong Kong's inaugural five-year plan for our International Innovation and Technology Hub, especially with the Northern Metropolis really getting momentum now. So City University of Hong Kong anchors this by positioning our CityU Hong Kong Academy of Innovation as well as our research platforms as core parts of the Northern Metropolis University town, also using our Hong Kong Tech 300 program to turn from 0 to 1 research into the new quality productive forces via the deep tech commercialization as well as our Great Bay Area-wide ecosystems. Also in health and education, we have some initiatives and some changes as well. We advance human AI symbiosis through our efforts in our Institute of Digital Medicine, our Institute of the AI for Science, as well as our new programs such as the Master of Science in Artificial Intelligence for Science, AI for Digital Medicine track, as well as in terms of education, we have revamped our MBA with AI as our strategic backbone. So overall, we are optimistic, yet also realistic. We believe that the technology only succeeds when we pair technology with strong institutional leadership, ethics, and genuine system transformation. And we'd like to start here and look forward to more discussions with our esteemed panel members.
Thank you, Wilson. Last but not least, Ben.
All right, thanks, Alex. Let me share the experience of PolyU in terms of education in AI. In fact, at PolyU, we are not only educating students, like students from engineering disciplines or computing in AI, but AI for all students. In fact, we started this 4 or 5 years ago, where we have this compulsory subjects for all students, that is AI and data analytics. So we are talking about 4 or 5 years ago. That is even people start talking about DeepSeek and ChatGPT, back then. So that means for all graduates from PolyU, they would have some sort of knowledge. It's a free credit, free credit-bearing subjects that all students must take. We also started this Education 4.0 initiatives. It's driven by this new VP Education, Professor Chao Jianong, who is an AI expert. So we will embed this AI-enabled pedagogies into our curriculum, and we will start with language education first. So in the new academic year, that is 2026-27, that started this September, we will have new compulsory subjects for all first-year students. That is using AI, that's AI as a tool for in language education. The purpose of that is to enhance the Chinese and English proficiencies of all PolyU students. So that's the education in terms of AI at PolyU. Thank you, Alex.
Thank you, Ben. Thank you all for your opening statement, thought-provoking. Indeed, it's a lot of issues. It's not fair to have you cover such a big topic in such a short time. Now, so we focus a little bit in the discussion part. The question that I would like you to share your thought on is, now we know the country just start the 15th five-year plan. This is the first year. And the emphasis of the 15th five-year plan is self-reliance and strength in science and technology, and also building a strong education system by 2035. Now, Hong Kong, as we started to this topic, is also started to do its inaugural five-year plan, also focus on developing into an International Innovation Technology Hub, and also the construction of the Northern Metropolis. Now, with these two directions, one from the country, the 15th five-year plan, and also from our own government in Hong Kong, how do you think Hong Kong University or your own university should, whether you need to, if you do, how do we define your unique role in the nation's development? Okay, so under the election of five-year plan, and we pretty much can guess what Hong Kong government will do in the five-year plan, what your role will be. Okay, to further our country's development. I'll start with Yao again.
Right, thank you, Chairman.
You have 3 minutes.
I have 3 minutes, okay. So I want to say a little bit more about this education. I think one of the very popular use and very effective use of AI is to make what we do or what we used to do more efficient. If we look at how AI is used in student learning, how AI is used in terms of lecturing, preparation, assessment, etc. But one question I would like to pose to all of us or have a discussion about is, I think AI will change the way we think about education, will probably change the way we define what education is, especially in the longer term. So whatever we do, I hope we have a robust discussion how AI changed the way we think rather than do things more efficiently. In terms of this 5-year plan, how AI plus could be promoted or speed up within the mainland, what's the role of Hong Kong? I think Hong Kong, especially Lingnan University, is sitting right in between the high-tech zone in Shenzhen and then the Hong Kong International Airport. So I always said if you want to go overseas for high tech through Hong Kong International Airport, you have to pass Lingnan University. So in any case, back to the serious part. I think Hong Kong is a unique place where we can balance our long-term thinking about education and the AI and the short-term demand of the society. I see there is a competition between the two. If you think of graduate employment rate, you look at something shorter term. But that might or might not be what the society needs in 10 years or in 20 years. How do you balance these two? Because government are interested in 5-year plan. But from education point of view, I think educators ought to be interested in 50 years plan. There's a competition between the two. How do we balance that in that 5-year plan such that we can sort of look at the 5-year objectives, also look at the 50 years objectives?
Thank you. Very true. A student takes 4 years to graduate and a few more years to develop. Okay, a 5-year plan might not fit education. Okay, John?
Thank you. I think if you talk about China, our country as an example, we talk about 2035, where China is envisaged to be a leading country in education. So we are talking about only 10 years, actually less than 10 years as a national target. So in that way, I think we need of course, a slightly longer time span in planning. I totally agree with that. But how long, we cannot predict, especially when we have to ask AI experts how AI could progress in 5 years or maybe 10 years. But for education, I think as far as our university, Edu Hong Kong is concerned, we have a unique role to nurture teachers because we're the largest teacher education providers in Hong Kong. So for education, I think it means what we have to rethink, what does it really means to be an educated person in the 21st century, especially under the backdrop of AI and the backdrop of emerging technologies. So we have in our university developed a comprehensive AI and digital competency strategy. And we have, of course, mandatory courses related to AI literacy, digital literacy for all first-year students. We are also working with colleagues because the colleagues also need some upskilling, upgrading in AI skills and teaching skills as well. We are also working with some industries to develop AI-related learning chatbots, AI tutors, as well as projects with primary and secondary schools. So it implies that it's not just teaching with AI, but teaching more about AI. And also, behind the AI, we all understand there's some limitation about AI, especially about the ethical concerns behind using AI. So this is, I think, as far as an educated person is concerned, as far as the remits of education is concerned, I think ethics and values is very important. I think we also need to consider the meaning of talents when we talk about talents in future. According to many international consultancies, it refers to 21st century skills like problem-solving skill, interpersonal skill, critical thinking, creativity. Recently, there are also some discussion when AI comes to a point of development, what sort of areas, subject areas may be more important. Some AI experts, maybe entrepreneurs, say that in future maybe languages, cultures may be even more important than AI. So it calls upon a reconsideration about the subject matter. While we talk about interdisciplinary learning, while we all propose that we need to embrace AI in the general education domain. Thank you.
Thank you, John. Professor Zhang.
Thank you again. I think, as I mentioned earlier, our university have been working on the next 5-year strategic plan, okay, which will be finalized in the coming few months. Okay, so our strategic plan aligns well with the 15th National 5-year plan. Okay, university contribute through the cultivation of talent, the advancement of knowledge, and the integration of education, science, and technology, while maintaining a strong commitment to academic integrity and international engagement. I think in our university, we have a very unique system. We have a CHK Xiatian, CHK Shenzhen. So we have a one brand, two campus framework, okay? So we have a lot of this collaboration between these two campus. I think in addition to research, I think one is that we have a joint program, 2+2 program with the CHK Shenzhen, also CHK Xiatian, and the AI and math under with Professor Shing-Tung. So this is something like a timely development under our strategic planning. Okay. Thank you.
Thank you. Professor Guo.
Yeah, I think now China is obviously the world's second largest economy. And I think it's unthinkable as a world's second largest economy, we don't have the international university, right? And if China will develop its own international universities, the University in Hong Kong will be in the first cohort. So we have the historical opportunity to make our universities becoming China's international universities. That's obviously is strategic objectives of HKAORS, and I do believe is also strategic objectives of all our Hong Kong universities. So I would emphasize on the internationalization will be a very important object in the next 5 years or even further. The second opportunity we do have is we enjoyed very great flexibility given by the autonomy of management of our university. I think this is a very unique, and I think we should grab this opportunity. And we can design our curriculum freely, and we can have our education strategies, mechanisms done largely by the university management. So from this point of view, and I think the university in Hong Kong should really play this role well and developing our thought leadership skill. I think this is very important for the nation. And many things, I think in Hong Kong we can try, and we can use the autonomy we have to try the new things, right? And then use this one to actually align with our international strategies, working with everybody in the world, actually developing the new education approach and the new mechanisms, as well as the new materials and the new teaching, and also new research. Use this one to enhance our thought leadership position and to be a champion in our country's development in the science and technology. I think we are not only play the role of a hub, but also have to play the role of a thought leader. I think this is what I think in the uniqueness of Hong Kong University.
Thank you, Professor Guo. Professor Lau.
Thank you very much, Professor Wei, and I cannot agree more with Professor Goh that in fact we must take this opportunity to enhance ourselves and to be the international universities of China in the next 5 years, the next 5 years, etc. But as far as the China's 15th five-year plan is concerned, allow me to focus on its plan on health, because this is what I know better. And in fact, a lot of what China's 15th five-year plan on health is not so much everything on AI and technologies, but also indeed on what exactly we do in training the next generation of health professionals. And that is, of course, they must be knowledgeable. They must be able to apply the knowledge, but they also must actually work as a team and be able to lead. So maybe I will just touch on some of the key points about the health 15th five-year plan of China. And that is really to achieve what we call Healthy China 2035. And in order to achieve that, we want to make sure that the medicine that we provide our people is affordable. We want to make sure that everyone naturally is able to access health service when they need it. So there is a lot of needs actually in the healthcare system reform. And I think this is where perhaps Hong Kong can actually help to support that with the experience that we have gained over the years in how to manage hospitals and hospital systems, etc., and then learn it together with our Chinese mainland counterparts. The other thing is about primary prevention of disease. So we talk about primary health care in Hong Kong. In China, we talk about community health. That is, we must not wait until the patient has developed, very advanced cancer or very bad coronary artery disease before we act. So all this actually requires doctors, nurses, and other healthcare professionals to work with the public as well as the patients. So these are the two main key points that I would like to highlight, not exactly related to AI. But then, of course, in health policies, it's very important. We as doctors from the hospital must work with the public health people, with the global health people. There, perhaps the use of the big data will actually help us determine certain healthcare policies. The third thing about China's healthcare 15th five-year plan is on how we could accelerate innovation and translation of health and medicines, etc. I have already touched on, the importance of conducting clinical trials that will link up perhaps the rest of the world with the rest of the Chinese mainland. And as the chief executive in his opening highlighted the importance of the Greater Bay Area International Clinical Trial Institute and platform, and we are fortunate to be the operator of this institute, so we will try our very best to facilitate that. The last thing that I would like to highlight, and that was actually one thing I got from when President Xi actually visited us during the political conference last month, and that was most important, irrespective of what innovations are doing to us, besides being able to afford our people medicine and health care. It is very important that we train our next generation of doctors and other healthcare professionals in a professional way, with humanism, with human touches. Thank you very much.
Thank you, Professor Lau. Professor Sam.
Thank you. So the question is about redefining Hong Kong University's unique role. I think I would look at two adjectives. One is we have to be unique, and also we have to be integrated when we are considering Hong Kong as well as Hong Kong universities. Because I think in China, in the national 15th five-year plan, I think the nation already has a lot of capacities to do a lot of things. So how can Hong Kong contribute in a unique way, yet in a very integrated approach? I think it's important. And universities in Hong Kong, I think, should also do that. I think resonating with Professor Guo and Professor Lao's mentioning international universities, that is one area. So I think we have to look into how we can enhance our internationality, as well as how we can do things that we think Hong Kong provides a more possible platform to do things that will ultimately contribute to our nation. For example, I think a lot of our leaders have mentioned our unique legal system, well integrated with overseas, our financial markets, etc. So how we can work together. So my other two points is about action. One is work together. How do universities work together? How do academia work with other important stakeholders in our society, our financier, investors, our legal experts, our healthcare experts, for universities in Hong Kong to contribute to talent development, education, and beyond, because I think universities in Hong Kong are given very unique opportunity and also responsibility. I think our general public and also our nation place high trust on universities in Hong Kong, and I think how do we maintain that? How do we leverage that to do things in a very unique way? Also, working between universities and industries become also very important, especially we have a lot of AI experts here. I believe that some of the leading experts in AI and also contributions in AI cannot do without industries. So how we work with industries where they have maybe top computing power databases that we can harness, and at the same time, how do we diversify? So working together doesn't mean that we lose our own identity. We have to diversify based on our unique strength and attributes. So universities' mission fundamentally is to educate. So how do we come up with new programs in preparation for the demand for talents, etc.? So this is some of our thoughts. Thank you.
Thank you, Edison. Ben, last but not least, your thought.
All right, okay, thanks, Alex. So talking about the 15 5-year plan, I'm sure all the universities in Hong Kong fully support Hong Kong to be an international education and talent hub. I see that the Northern Metropolis University Town as a key platform to attract, nurture, and retain high-caliber talent who can actually serve Hong Kong and the mainland. And one of the agenda in this, the 15 5-year plan, is promoting high quality and development of service industry. So I would like to talk about the PolyU School of Hotel and Tourism Management. I'm sure some of you heard about this, the Hotel Icon. The Hotel Icon is located in Tsim Sha Tsui East. It's only a few minutes walk from PolyU main campus. It is 100% owned by PolyU. It is a teaching and research hotel. Recently, it is also named as a Michelin Key Hotel. So in Hong Kong, there's only a few Michelin Key Hotel, and Hotel Icon is one of these Michelin Key Hotel. And in the hotel school, they actually provide, smart tourism, including artificial intelligence, robotics, technology innovations, and so on. Imagine, so we have this Northern Metropolis University Town. In the town, you have universities, laboratories, lecture theater, and so on. But more importantly, we also need to have a world-class hotel, international hotel. And PolyU can contribute to this for sure. The hotel that, we could host guests from overseas, organizing conferences, and so on. So that part, I'm sure PolyU can contribute. On the other hand, actually, PolyU already, put things into practice. We have a practical model that talking about translational research institutes. We have already set up 12 translational institutes in the mainland, such as, Wenzhou, Hangzhou, Nanjing, Zhongshan, Wuhan, Hefei, and so on. So we work closely with the local government, and the local government, basically, they provide funding, land, and PolyU, we have our expertise, and we work together closely with the local government. So this we really turn in our applied research into technologies, products, and service. Thank you.
Thank you. I really like to continue this line of discussions, but in interest of time, okay, let's go to the question on the floor. But I got a very good one, okay. It said here, as society embrace new technologies, AI in this case, okay, how can we ensure that technology continues to serve people, rather forcing people to adapt to the new technology? In particular, for university, how can we preserve the human connection and empathy that matter most in education and healthcare? So, and it is not unique to AI. I mean, we faced that before, okay? And particularly in education and healthcare, how do we ensure that, we become, slave to technology rather than, have the technology serve us? Now this time, Ben, I'll start with you.
All right, okay, thanks, Alex. Okay, now for this, I would say we should leveraging AI with the human core. So in other words, AI must serve people, not the other way around. So we're not serving AI, but AI serve people. That's important. And earlier on, I mentioned about PolyU. We already started this Education 4.0 initiative by integrating AI into our education, also into our curriculum. So talking about research, at PolyU, we have a team of professors who actually make use of AI. I'll give you some of the examples, such as portable eyes disease screening. It's a handheld, portable, very mobile. You can take it anywhere, everywhere with you. And it makes use of the AI, and then it helps to screen the eyes disease screening. The other team actually works on a liver fat meter. In other words, this handheld meter that could scan your liver and determine the level of fat from the liver. And the other example is the 3D ultrasound assessment system that scans your spine. So some of these are just the example. And I also would like to talk about PolyU. Last year, we actually April last year, we started this PolyU Academy for Artificial Intelligence. So we're actually bringing together world-leading AI scholar and also tap on the PolyU strength in computing, data science, and engineering. Some of the projects that in this academy, they actually focus on the AI-driven medicines, projects such as cancer, Gen AI projects, and also AI for infectious disease control. So some of this detail you can find out from the PolyU website. Okay, thank you, Alex.
Thank you, Ben. Now, Anderson.
Thank you. So I think as was mentioned, I think with AI we may have better efficiency, but I think efficiency must never erode empathy, and also technology should augment the human touch instead of distinguishing it. So extinguishing it. So I think at City University of Hong Kong, we try to embed humanities and social sciences alongside our responsible AI governance to build trust and also prevent isolation. So we have new master's programs such as the MSc in Artificial Intelligence in Business, featuring core courses in AI ethics and regulations, training students to assess societal impacts critically. And also for inclusiveness, we understand that AI is becoming a very important tool in education. So we have a program which is partnering with Tencent on AI programming boot camps, not just serving university students, but actually also serving our communities with secondary schools or even primary schools with the Code Buddy, Work Buddy, enabling the participants with no coding background to create solutions, including for elderly, chronic disease management, making technology accessible without replacing our educators or caregivers. We also have initiatives with our Institute of Digital Medicine, with our College of Biomedicine, with our vet school, etc., that try to ensure AI also serves healthy aging and also being outreaching to our community. There are community health screening programs. So we hope that with technologies, we have more efficient means to preserve compassion and also cultural sensitivities. On our environmental and climate side, we also have energy saving initiatives to help some of the more underprivileged families to save cost in electricity and others. So we hope that technologies, including and especially AI in the coming years, can be harnessed to enhance our compassion and to increase our human touch and our care for the community.
Thank you, Edison. Personally, you are a healthcare expert. How you ensure that human connection and empathy will be preserved in the AI era?
This is very important. In fact, I started off by saying how AI and technological advances could improve health, etc. And then I spoke about, health is not all about AI and innovations, but also humanity. Perhaps allow me to share with you in the next 2.5 minutes or so a study that I recently read from the journal Science. I think it was published only last week, about a group of conservationists, their observation of the behavior of a group of chimpanzees over the last 30 years in Uganda. And there were 200-odd chimpanzees, most of the time, and then these chimpanzees were friends with one another for a long time, until around 2014 or so. They started to sort of slowly polarize into two groups. One they call the Central Group, the other the Western Group. And then a few years later, the polarization became more obvious in year 2018. And then 1 year later, they observed some of the chimpanzees who were used to be very friendly with each other actually started attacking each other. And indeed, one of the Central Group actually got killed and murdered by 3 of the chimpanzees from the Western groups. And they actually analyzed why it happened, and then discovered that, in fact, the reason for the first split in 2014 and 15 was perhaps down to the death of 5 male adult chimpanzees and 1 female adult chimpanzee. And those 6 chimpanzees used to actually, link up the Western and the Central groups of chimpanzees. They died, so they lost that connection. And then in year 2017, there was a respiratory epidemic. So the chimpanzees were actually forced to split from one another. And then ever since then, they never became friends again. So I think that interactions with one another is very, very important. Particularly, chimpanzees are primates, our closest relatives as such. So same with human interactions is most important. So while we try to innovate health, I think it is important that we always must remember that we should also inspire humanity all the time and never forget the human interactions and working together. And perhaps in the last 10 seconds or so, I will also remind people, actually, one of the other hypotheses as to why these 2 groups of chimpanzees started attacking and killing each other was because probably there was a dominant chimpanzee, from one of the groups. And this dominant chimpanzee disregarded, the rules of the chimpanzee world and started raising war on each other. Thank you very much.
That's a fascinating study. It shed a light on what's happening in the world right now. Professor Guo, okay, you are expert in AI, so what's your view about human connection and empathy?
Thank you. Yeah. We are entering into the human-machine symbiotic world, a symbiotic society. I think I agree with you entirely, the communication, right? But this communication not be just a human to human, and a human to machine. That's actually very complicated now. I think one of the important focus in AI research and also in the humanity work is to really try to make a machine understand people and the people understand the machine. That's the first step. Otherwise, there's no connection can build. On the machine understand the people side, there's a lot of work AI people doing. We call it, for example, value alignment. And in fact, In Hong Kong, when we build our Hong Kong models, Hong Kong systems, this value alignment is critically important because Hong Kong runs a very special social systems, one country, two systems. So we have to make this, our models reflect this. So therefore, you have to make the machine understand the society, understand social values, which is specific to Hong Kong. So this is actually very interesting and very important research. Along this line, there's a lot of work now on how make a machine understand human. But on the other hand, there's other things called the human have to understand the machine. That's what people call the AI literacy, right? I think that all our universities doing this hard work now, but also we have a responsibility to actually enhance the AI literacy in the society, right? That is a very important work. And we come to HKAORS, right? We are now focused on building our third medical school. And the medical school will be very much with the AI as a foundation technology. But that time, we really have to understand, right, how to actually have the AI systems in such an environment with a strongly human touch. So we set up this kind of Institute of Health Innovation. One very important part is empathy, right? And how we actually not only educate the machine, but also have to make human aware, right? How to have the machine in with intelligence in our environment and how to work with them together. So, and a lot of our work now in education for our students on the common core of AI is not just about technology. It's really about how human can understand the machine. That piece, I think we have to pay great attention. So for example, how you understand that the contents generated by the machine is actually, you can carefully examine it, assess it. What's the truth and how you evaluate it. That's all about human understand the machine. But I think the AI literacy is a very important subject now for this society. Yeah.
Thank you. Professor Zhang, your thought?
Yeah, I think I just share my personal experience. I think I'm a plant cell biologist. What we a lot this image, okay? We do a lot this so-called electron tomography. Yeah, using transmission electron microscope, collect many sections of the image. One way we later on we need to draw the model. We used to do it by hand drawing. A student may take overnight to draw one model. Okay, recently I have a very good final year project student. He has been using the AI, so-called using a Dragonfly software with a powerful computer, and then he can finish the model maybe in maybe 1 or 2 hours, compared to the old version may take several weeks. Okay, and one day he come up with me, Dr. Zhang, I want to buy the Dragonfly with a computer. I say, how much would it cost? It's $500,000 for a final year project student. I said, go ahead to do it. And then later on, I find out search more. We may need to upgrade the software, the computer. I come back with 1.3 million Hong Kong dollars. You know that in Hong Kong system, the RGC grant wouldn't allow you to use the grant to buy a computer, right? So there's a way, I think, but eventually we submit academic equipment grant matching funding. So our university have a matching scheme, 1-to-1. So we try to come up with the funding to support timely for the undergraduate student, the research. I think this really is something, for me, I think for the AI development, we need all the support platforms, support from the university, from the government, but down to the bottom is really for the student. They really want to have a project-driven, maybe a purpose-driven research project. They need something that need to be taken care by the supervisor or by the university in a timely also fashion. This is something I think would be for something for someone else to think about in that daily, the research, working with the student. Thank you.
Thank you. Well, John, how you ensure human connection?
I'm still thinking about the deep meaning, the sharing about chimpanzees from the Professor Lau's sharing is very insightful. So if I understand correctly, and according to my personal extrapolation, we have to think really a few implications arising from the chimpanzees scenario. Number one, whether at the end of the day, when we come across AI, some countries, some institutions will have access to a lot of resources, manpower. It will lead to inequality, definitely. It will lead to unequal access. So until a point where we have to caution within our system, I mean the macro system, how we can ensure that there's a better access and equality as well as development for AI capability and literacy. Point number one. Point number two, the original question is asking whether we cannot really force people to learn about AI. But people have to understand the importance of AI as a tool, probably not as a weapon. So I think this, again, implies that the co-creation of AI solutions that needs to take into account the ethical aspect, the cultural sensitive aspect, and also truly inclusive. Because according to my reading of some of the recent literature, they start to ask philosophers, they start to ask humanist experts, historian experts to work with computer scientists to develop algorithm calculations to ensure the AI solutions will be broadly accommodating the different cultures and accommodating the different groups of human communities. So I believe this is another direction that we should consider. So the third point is about the balance. At U Hong Kong, we require very importantly the message that all students need to take courses in national security education, legal education, especially including traditional cultural education. I think the balance of learning under the AI era is equally important. Thank you.
Thank you, John. Pershao.
Thank you. I think this is a great question I like very much, and how to ensure technology continues to serve people. I have a very simple answer and a very biased answer. We need more and a better liberal arts education. I think it's biased because Lingnan University has always been very proud of providing a liberal arts education at the university level. Well, the reason is liberal arts education enter personal development, always put people at the center of education. Okay, and then so in research, and then we have AI research. Personally, I'm a machine learner. We always advocate human-centric, trustworthy AI. That's one of the research things out of Lingnan University. So within this team, we have a group of social scientists, we have a group of philosophers, we have a group of computer scientists, of course, and then we have a group of more applied engineers. And then liberal arts education emphasize you read, write, think critically and broadly. And that word broadly is very important because I mentioned at the very beginning issues like health and education, especially education now, is not limited to universities or schools. It's a societal issue. We cannot separate education from the society. With the emergence of AI, we have to think not only it can make our education as we used to do more efficiently, whether it might change the way we think and behave. I think that level of thinking is very important out of universities. I think that's a university role, and that's where liberal arts education comes into it. Because the last element of liberal arts education is to focus on societal challenges. I know for technologists like myself, I would like to take an idea and run with it. But liberal arts education, my colleagues tell me, please consider society implications before you run with it. I think this is a role our university education should provide. Not only internal research in our degree education as well. And if you look at the programs coming out of Lingnan University, at the undergraduate, at the postgraduate, it's all this multidisciplinary, cutting across arts, social science, and the technology.
Thank you. Very well put. I know VX on stage are now sitting between lunch, okay? But it's not fair not to allow each of you a closing remarks. So I take the liberty to control your closing remark. No, don't look at the clock, okay? Down to 30 seconds. Try to do that, okay? Ben, let's start with you.
All right, okay, 30 seconds. I would like to conclude by saying the motto of PolyU. The motto of PolyU is to learn and to apply for the benefit of mankind. Similarly, AI. We learn about AI, we apply AI, but the end of the day is for the benefit of mankind. Thank you.
So by 2035, I hope that City University of Hong Kong would be remembered for pioneering ethical, human-centered AI solutions that advance healthy aging, intelligent lifelong education, and national science and technology self-reliance while strengthening Hong Kong's innovation and technology hub. And we also look forward to collaborating with our fellow universities to ensure that this new horizon, new renaissance that we're talking about truly serve people. Thank you.
Thank you, Anderson. Professor Lau?
Thank you. I was at a high table dinner last night, and the students asked me how my life has been, and I told them that it has been tough because things are happening so fast, and there's so many advances around us, and there's so many things that actually passing me by, and I don't know which, and what I could grab, etc. And then I told them that actually I've only got two hands, but there are many opportunities. All I can do each time is I will pick couple of opportunities, but if we can all work together, lined up together with multiple hands, we will grab all of the opportunities that actually fly past us, and we could share them together. Thank you very much.
Well put. Professor Guo?
I think as a university leaders, we're in the most exciting time. It's not just about AI technology, it's also about Hong Kong's historical role to play to build an international education hub for the country. So I do think we should work together to actually make Hong Kong higher education to be a flagship of the nation.
Thank you. Christian?
Okay, as a plant biologist, I don't know much about AI, but I think I need to learn more, okay? So as many of us, I think we need to be educated and learn more and then try to use them. Thank you.
Thank you. John?
As university leaders and colleagues, I hope that we could nurture professional teachers who could cultivate the hands, the hearts, and also the minds with tomorrow researchers, entrepreneurs, and leaders with well-being and also positive values in mind. Thank you.
Thank you. Yao?
I have one very simple wish is that there's more integration between university and the schools, and there's more integration between university and societies. I always believe education is a societal issue, and that university is there to take the lead, but when we lead this education effort, we should not forget the society at large.
Thank you. I agree with Anderson. I really like the theme of this discussion. It's a renaissance. And I hear from our leaders here, many of you have mentioned about collaboration. We have UGC, university, work together on issues like sustainability, different areas, okay? I think it's high time that we, particularly in education, AI in education, we are all doing something, okay? I think at least we share to each other. Set a committee, have the relevant colleagues involved, share what we've been doing in AI in education and healthcare, okay? And therefore, able to, as a group, work together rather than, become part of chimpanzee problems, okay? I would like to thank all our academic leaders here in Hong Kong, okay? And welcome for your thought and welcome for all of you, spending time listening to us. Thank you, and the session is adjourned.
Thank you, all the presidents. Would you please step forward and pose for a group photo? Thank you so much. Thank you to all the presidents for your brilliant ideas and candid sharing. Thank you. Would you please step a little bit closer and let's take a group photo at this memorable moment. Thank you so much. All right, please face our official photographer In the front, closer please. Are you ready? 3, 2, 1. Would you please remain on stage? May I also invite Professor Nancy Yip to join us on stage, as well as Professor Shing-Tung to join this group photo. Let's put our hands together to welcome Professor Nancy Yip and Professor Shing-Tung This collision of thoughts has painted a beautiful blueprint for the intelligent future of education and health. Please show us your brightest smile. Ready? 3, 2, 1. Perfect. Thank you so much. You may now return to your seats. Thank you. Ladies and gentlemen, this concludes our morning agenda. It is now time for lunch. Our ushers will be on hand to guide our invited guests to the designated dining areas. For all other attendees, you are welcome to take a break at your convenience. Our afternoon sessions will begin promptly at 1:30. Please return to the venue on time. May we also kindly invite our VIP guests to note that the seating arrangement for the afternoon session will be adjusted. Please refer to the seating plan displayed outside the ballroom before re-entering the venue after lunch. Thank you so much. We will see you at 1:30 p.m. for the afternoon session. Thank you.
Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, The IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and Innovation in Higher Education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA
is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and Future City. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan. Charting an ambitious future for innovation and talent, the IAA stands at the heart of this vision. In this new era of Renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force linking Hong Kong to global research frontiers. Serving as a bridge for scientific exchange, IAA is dedicated to advancing knowledge with a mission to advance human progress through research and innovation. In March 2025, the inaugural IAA Forum was graced by Mr. John Lee, Chief Executive of Hong Kong's Special Administrative Region. It established the IAA as an international science and technology organization based in Hong Kong, gathering together scholars from over 20 countries to discuss AI for health and future city. IAA has forged a vibrant global academic network that transforms insights into action. As China's 15th five-year plan launches, Hong Kong unveils its first five-year plan, charting an ambitious future for innovation and talent. The IAA stands at the heart of this vision. In this new era of renaissance, the IAA Forum reaffirms our collective commitment to building a sustainable and humane world. We will keep uniting global wisdom to address humanity's greatest challenges, solidifying Hong Kong's role as a global academic hub. This year, we focus on two urgent global issues: aging and chronic disease management, challenges and innovations, and AI and innovation in higher education. We are honored to welcome world-renowned scholars to envision a people-centered future, harnessing innovation to nurture new talents and build a better world for all. Welcome to the 2026 International Academicians Hong Kong Forum. Join us where insight meets impact. Founded by visionary leaders, the International Alliance of Academicians has emerged as a vital force.
Secured by design, $1,000 cash prize, debuggers. Okay, let's have a group photo for all the special award winners and award
工作人员会调好，他上来直接就是演讲者模式，还是他自己要去？
不用，我们后台去弄的。
OK。
OK。Next, we invite our awards presenters, Dr. Wu, and the Honorable Aaron Brook, and all the winning teams to join us on stage for a big group photo. Let's have a big round of applause to all the winning teams. Thanks again, everyone, for this facilities. Next up, we are thrilled to hear the sharing from our incredible winners. Let's start with the Students' Dream Champions. Please join me in giving a massive round of applause as we invite the debuggers. The team has swept 4 awards this year. Students' Dream Champion. Best ESG Achievement Award, Best Use of AI Award, and Innovative Obscured by Design. Their solution supply chain system from predicting risk to automated responses. Debuggers, please. From Laminators, the team won 2 awards. The first runner-up, the Best Low Altitude Economy Innovation Award. Their solution is titled Orbitron.
Tracking the second run-up of the students' dream, their solution is AI plus IoT minus IoT-driven precision reach and intelligent hub solution. It's time to hear from our professionals dream winners. Please put your hands together to give a warm round welcome as we request the powerhouse team keep data moving NTR Corporation. This outstanding team has swept 3 awards: Professional Sprint Champion, Innovator, UAV Guard, Empowering Low Altitude Economic Growth. Define Pro, Digital Products Passport Control Tower. Final winner sharing of the day, let's invite MainQ Technology Limited, the second runner-up of Professional Sprint, with their solution. MainQ Intelligent Sort System, B2B2C ready, pick-to-light sorting solution for intelligent warehouse operation and management. Everyone, what an unforgettable day it has been. Today we witnessed how collaboration and innovation powered by IoT data can create real impact. Once again, congratulations to all our winners. A big thank you to DPO, Cyberport, HPSTP, our sponsors, partners, judges, mentors, supporting organizations, and every participant who made this hackathon a success. Thank you all for joining us today. Let's continue to push the boundaries of innovation and make a positive impact on our connected world. Before you go, don't forget to visit our winners solution showcases at 4BC booth A32 to 34. You may also scan the QR code on screen to download the casebook of the winning solutions. See you next year.
嘿，我们差不多再过1-2分钟可以换换衣服，试一下方向就坐。然后我们的那个会3号只是张新的那个主持高座位。
Good afternoon, ladies and gentlemen. The afternoon session of the 2026 International Academicians Hong Kong Forum is about to begin. Would you please be seated and please turn your mobile phones to silent mode. Thank you. A warm reminder for all our guests, the afternoon session of the 2026 International Academicians Hong Kong Forum will begin shortly. Would you please take your seats now and please turn your mobile phones to silent mode. Thank you for your cooperation. Good afternoon, everyone. Welcome back to the 2026 International Academicians Hong Kong Forum. We will now begin our first thematic session titled Aging and Chronic Disease Management, Challenges and Innovations. This entire session will be chaired by Professor Chak Sing Lau, Vice President and Pro-Vice Chancellor Health of the University of Hong Kong. Let us welcome Professor Lau, please.
Thank you. Thank you very much, and welcome all back to our afternoon session. And I thank the organizers for giving me the privilege to chair this session. This session, we will have 4 speakers to tell us, the latest advances in the management of the elderly, from inflammation and dementia to sarcopenia, to how we actually use technology to guide how to manage these people, as well as precision treatment for patients with pancreatic cancer. Our first speaker is Professor John O'Brien, who is Professor of Old Age Psychiatry of the Department of Psychiatry at the University of Cambridge, National Institute for Health Research Emeritus Senior Investigator. Professor O'Brien, may I ask you to come on stage to deliver your talk titled Inflammation and Dementia. Professor O'Brien, please.
Well, thank you very much, Professor Lau and the Forum, for the invitation to be here. It's a great pleasure to speak with you today about inflammation and dementia. So dementia is obviously the challenge, and okay, I'll hold it. Is that all right? Can you hear me? Dementia is obviously the challenge, and it's a big challenge. And one thing about talking about dementia, if you're not interested in this from a professional capacity, people beyond a certain age are always quite interested in it from a personal point of view. And it's a big problem. So it affects 55 million people worldwide. The numbers are going to increase because of increased longevity to, it's estimated by 140 million. I see the figures for China are 10 million now, going to 50 million by 2050. So that's a huge increase, isn't it? There are many causes of dementia. Dementia is a syndrome, meaning a global cognitive decline. The main causes are Alzheimer's disease, vascular dementia, Lewy body dementia, and frontotemporal dementia. And those big 4 are responsible for most cases of dementia. And Alzheimer's is the most common. In the UK now, it's the leading cause of death. It's overtaken heart disease, which is quite striking. And it's increasing, unfortunately, in the league table of causes of death in many other countries. And until recently, we only had very modest, not very effective treatments. And these were symptomatic. They controlled some of the symptoms of the disease. They didn't really affect the underlying disease process. But we do now have some treatments against amyloid, which is one of the key proteins that's laid down and one of the, we think, causes of Alzheimer's disease. And these treatments for amyloid, and they're licensed in Hong Kong, there are 2 of them now, lecanemab, donanemab. They remove amyloid quite well from the brain, but the clinical benefit is actually quite small. It's statistically significant. It's been enough for licensing authorities to say, yes, they're okay, but it's not so far been enough for a lot of insurance and healthcare systems to think they're worth the cost. That might be something we return to. So even tackling one of the key proteins involved in Alzheimer's doesn't seem to give as much symptomatic benefit or disease modification as we would want. So why study inflammation? Why is that might be relevant? Well, that's because really inflammation is a component of dementia and, in fact, neurodegenerative diseases. And if you think about the different processes that go on in terms of a degenerative disease, whether it's Alzheimer's disease or Parkinson's disease, we always think of the pathological laydown of the proteins. In Alzheimer's, as I say, it's amyloid and tau protein. In Parkinson's disease, it's called alpha-synuclein, but the protein probably doesn't matter. it's laid down, it deposits, and it causes cells to malfunction in the brain and ultimately die. But that's not the only mechanism that might be targetable. There are other things. There's synaptic transmission, for example. There's other things involved with energy and metabolism. But there's also inflammation, which is a common feature across several of these degenerative diseases. And when we think about Alzheimer's disease, when inflammation was first seen in the brains of people with Alzheimer's, that's the sort of left-hand graph, and it was present even in Alzheimer's first case describing this disease many decades ago. It was thought to be a reaction to the pathology. You get cell death in the brain, you're bound to get an inflammatory response. It's just a byproduct of that. But then there are other lines of evidence that suggested it might not just be that. So one in the middle graph there is that people that have taken anti-inflammatory drugs for several years seem to have a lower risk of Alzheimer's disease and dementia than people who haven't, as if there might be some sort of protective effect. And then the third table is evidence from genetics of a particular gene that affects the response to inflammation. This is a receptor on myeloid cells in the brain that are involved with eating up bad proteins, if you like. If that receptor goes wrong because you've got a genetic mutation, you're much more likely to develop Alzheimer's disease. As if the sort of inflammatory response and these receptors are important early on, maybe in helping protect against Alzheimer's. And this has been shown in other genetic studies. So we now have about 100 risk factor genes for late onset Alzheimer's disease. And 25% of the genetic contribution seems to relate to genes that are involved with inflammatory processes in the microglial function or immune pathways. So for genes to actually be associated with the disease, that strongly suggests that there's a kind of causal link, that inflammation isn't just a reaction. There might be some causal pathway. It's also known that several other risk factors for Alzheimer's disease, some of them are listed there: lack of exercise, obesity, cardiovascular disease, diabetes, we'll be hearing about later. A lot of those are also associated with inflammation, and people have suggested that that might be the reason that all these various diseases are associated with Alzheimer's. We know clinically that infections systemically worsen the clinical progression of Alzheimer's disease. And some studies have linked diet and the microbiome to changes in dementia and suggested that's also potentially via inflammatory mechanisms. So what might these links be? There's known to be an increased risk of dementia in people with inflammatory diseases, whether that's autoimmune diseases or arthritis. And it may be that systemic inflammation causes changes such as increases disruption to the blood-brain barrier that can cause maybe cells, maybe molecules, maybe inflammatory cytokines to pass over. It's also known, and this comes largely from animal models, that if you have increased inflammation in the brain, it can hasten the deposition of tau and amyloid and other proteins. So an inflammatory environment might actually hasten the pathological process. So whereas maybe some early immune changes might be beneficial and help clear up some of these rogue proteins, later on, when inflammation gets a bit more out of control, let's say, it might actually hasten the pathological process. So we've been interested, as have other groups, in seeing whether this is true or not, what's the evidence for this, and the different ways one can study inflammation in people with neurodegenerative diseases. You can do brain imaging and look at inflammation in the brain. You can look at changes in the cerebrospinal fluid through lumbar puncture, in the blood, or through autopsy, studying the brain. And all of these can give bits of information about inflammation. So thinking about brain imaging, there's several potential tracers or lines. Studying one for many years, it's called PK195, but it's quite a well-established marker of microglial activation in the brain. And what you see is that in people with Alzheimer's disease, against a control subject, people with Alzheimer's have a lot more inflammatory response. And the right-hand diagram is just showing you meta-analysis of several studies that have looked at inflammatory changes using PET imaging in Alzheimer's. And most of them, and as you see when you put them together, it's highly significant. There are increases in brain areas that we know are important in Alzheimer's disease, temporal lobe, parietal lobe, but not in other areas, such as those that are related to movement, for example. In studies we've been doing in Cambridge, we've looked at this in different dementias, Alzheimer's, frontotemporal dementia, other types of conditions. Progressive supranuclear palsy is also a condition that causes cognitive decline and dementia. And we do find evidence of increased inflammation on PET imaging in all these diseases, associated, as one would imagine, with the sort of clinical symptoms. So in other words, in frontotemporal dementia, the changes are in the front of the brain. In Alzheimer's, they're in temporal and parietal areas. In Lewy body dementia, which I also mentioned, we've also found changes in terms of increased inflammation. So this seems to be a common feature across the diseases. If we look at whether this has any influence on the clinical course, and this is looking at associations, we can't prove the inflammation is actually causing this or driving it. If we look at Alzheimer's disease, we see over time, obviously people unfortunately decline. That's part of the disease. And we can do brain imaging studies where we do multiple scans. We can look at structure using MRI. We can look at tau deposition using compounds such as AV1451, now called flutalsapir. And we can also look at inflammation using PK1195. And we can see what impact these seem to have on the clinical progression of the disease. And when we do that, we find that some of the predictors are not surprisingly related to tau imaging and atrophy, but there's also quite a highly significant contribution as well from inflammation that's independent of these other changes, suggesting that there is an association between inflammation and decline that's not explained by tau pathology or atrophy. When might these inflammatory changes occur? Well, that's slightly more difficult to determine, but one can look at people who are genetically, they have a gene for the disease, but they're not yet symptomatic. And there are some autosomal dominant genes in Alzheimer's and frontotemporal dementia that if you have the gene, you're pretty much 100% likely to get the disease. And you can do imaging studies like here on people when they're asymptomatic. And again, you see, even though people are asymptomatic, many years before they'll develop symptoms, there's increases in inflammation in the brain, suggesting it's an early change. And this has also been shown in Parkinson's disease. So people with Parkinson's disease, again, are at high risk of developing dementia. But you can divide them when they're cognitively intact into people at high risk of getting it through various factors and people at low risk. And if you look at the high risk group, again, you see increases in inflammation compared to those at low risk. So all of these features suggest it occurs early, suggest that it's associated with poor outcome. So basically, if we just summarize the PET studies, you see increased microglial signal in several dementias. The pattern of inflammation reflects the known patterns of pathology. As I say, there's evidence that it's an early change, even before symptoms occur, and it's associated with a faster disease progression. But PET imaging is very, very expensive, technically complex, obviously involves radiation as a burden to participants. So it's a very, very useful thing to do to investigate, but it's not really a scalable solution to look at inflammation, how it progresses over time or in larger populations. It isn't really scalable. So one innovation that's come along in the last few years is blood-based biomarkers because of the improvement in the sensitivity of assays. And these can be divided into several different types. There's markers of inflammation, which I'll talk about, but there's also markers of pathology. So I mentioned amyloid and tau. So there are now quite good markers in the blood that correlate very highly with amyloid and tau levels in the brain. Something remarkable, something I never thought we would see, a blood test being able to tell you whether you've got Alzheimer's pathology in the brain. And there are also other markers looking at more general things like neuronal degeneration. So neurofilament light, for example, is one of those. So we have exciting new markers in the blood that might be able to help in this regard. And in parallel, or coming along at the same time, we're having these large proteomic panels with very high sensitivity. O-Link is one, Nulisa is another one. And what these do is, because they have double antibody capture, they're able to remove a lot of background proteins and detect proteins that are left with a very high degree of sensitivity, attomolar sensitivity, sort of several-fold higher sensitivity than previous methods. And these now allow the testing of multiple markers, so 250, 6,000, you can almost choose the number you want, with a single blood sample, and be able to look at changes and looking at changes over time. And these technologies are now starting to apply to people with dementias, including Alzheimer's disease. And this is just a recent study that was from our group that looked at a couple of panels of markers, some of degenerative markers, that's the CNS panel, and some inflammatory markers. And what we find is that, as others have, that these markers, and this is blood, remember, are really very good at picking up changes in Alzheimer's disease. So we have high levels of phospho-tau, different epitopes, both in Alzheimer's disease and Lewy body dementia. Also changes in things like neurofilament protein showing neuronal degeneration. And if we look at the diagnostic accuracy of some of these blood tests, they're quite good for separating some diseases from others. So they're quite good at separating Alzheimer's disease from not only controls, which isn't a difficult differential, but from other dementias like frontotemporal and progressive supranuclear palsy, with diagnostic separation of sort of 80 to 85%. It's really very good for a blood test. Again, something I don't think we thought we'd see. However, these things are less accurate at differentiating between different dementias. So whereas we've got diagnostic blood markers that are fairly advanced now for Alzheimer's disease, and starting to be rolled out in clinical practice, though not yet widely, starting to be rolled out, we don't yet have good biomarkers or blood markers for some of the other dementias like frontotemporal or Lewy body, but they are being developed. In terms of inflammation, again, we see many markers that are significantly increased in people with Alzheimer's disease and Lewy body dementia, other dementias as well. And there is some commonality between these, so there are different changes in each, but also there's some commonality. And a bit like I showed with the PET imaging, some of these markers are significantly associated with outcome. In this case, this is a model showing markers associated with poor outcome, and you can see several inflammatory markers there are associated with poor outcome. Again, not proving that these are causing the poor outcome, but suggesting they're markers of it and may well be playing a role. And some of these individually are also predictors of survival. So this is one particular marker which was shown across diagnostic groups to be a reasonable and significant predictor of mortality over the next 5 to 10 years. As well as the blood-based markers, we're now able to look in much more detail at individual cells in the blood, in the CSF. There are some, but particularly in the blood. And looking at these mononuclear cells, different types of cell, T cells, B cells, subsets of cells, and looking again in a single sample at the distribution of these cells. So there's not only the chemicals the cells produce, but the actual cells themselves, to see if there are changes there that might be associated with or reflective of changes in the brain, because it's obviously very difficult to access the immune cells of the brain except through PET imaging. And again, these studies which are ongoing are starting to show changes in the periphery that seem to be associated with some changes that are occurring in the brain. So for example, you see activity of the kind of good immune cells in the blood early on in the disease process, a bit like we were seeing in some of the genetic signals from the brain. But later on, you're seeing some of the sort of more bad immune cells, the one that produce a lot of cytokines and things that we think we know are not good for the brain, being upregulated and enhanced later on in the process. And really, finally, this is moving into clinical trials. We don't yet have an agent we can say, oh, this anti-inflammatory, it helps Alzheimer's disease. But this is a review that's done every year by Jeff Cummings looking at the pipeline of drugs for Alzheimer's disease. And until fairly recently, the only things that really we saw on this graph were drugs targeting amyloid, protein I mentioned, and drugs targeting neurotransmitters, which are the sort of drugs that we have already available. But now drugs targeting inflammation or immunity are now the third biggest tranche of agents that are being looked at for Alzheimer's disease. And I include this one here. I won't pronounce it properly, so apologies. Wuja Yizi. I mention that because there are only 3 phase 3 studies in Alzheimer's disease that are involving an agent with strong anti-inflammatory properties. And one of them is of this agent being done in China. So I think that's quite interesting in itself. So these agents are being looked at and in the pipeline. And as I say, we can't say at the moment they will be beneficial. But the evidence is building, and really that's my point. And innovations have allowed that evidence to build. So just to wrap up, we've seen that microglia, which are the immune cells of the brain, can be visualized using PET imaging and show patterns associated with the known patterns of pathology in different degenerative diseases. We now have new sensitive blood biomarker technologies allowing peripheral markers of degeneration and inflammation to be measured in different dementias. Some of these markers of degeneration show high promise as diagnostics for Alzheimer's disease. We still need markers for other dementias. And we know that the blood biomarkers of inflammation are altered in dementia and associated with outcome. And I think some of these new innovative technologies allow us to look at larger numbers across different populations and over time, which will really allow this field to accelerate. I'd just like to finish there. Thank you for your attention and for everybody that's helped with all the studies that I've been involved with and talked to you about. Thank you very much.
Thank you. Thank you so much, Professor O'Brien, for a wonderful lecture. We ask you to be seated for now because we will have a panel discussion and Q&A session following all 4 speakers. So once again, thank you, Professor O'Brien. Our next speaker is Professor Hidenori Arai, who is the president of the National Center for Geriatrics and Gerontology, Japan, as well as the president of the Japanese Association on Sarcopenia and Frailty. Professor Arai will speak on preventive management of sarcopenia and frailty in older adults with diabetes. Thank you, Professor Arai.
Thank you. Okay, great. Thank you, Mr. Chairman, for a kind introduction. My name is Hidenori Arai from National Center for Geriatrics and Gerontology. Our center is kind of a national institute, Asian in the States. But in addition to research institute, we have a hospital affiliated to a research center. So our research team and clinical team are working together. Okay, so the title of my talk is Preventive Management of Sarcopenia and Frailty in Older People with Diabetes. I have no disclosures. So before discussing the diabetes management in older people, let me present a conceptual diagram of how muscle, brain, and vascular health are linked towards aging. You can see that aging is affecting multiple bodily systems, including muscle, vascular system, and brain health. The red color, arrow indicate a strong interrelationship among these systems. For example, a decline in vascular health can directly impact muscle health by reducing blood flow, while poor muscle health can strain the vascular system. The link between these conditions is both physiological and pathological, creating a cycle that can rapidly diminish a person's quality of life and independence. Now, let me introduce the landscape of diabetes in Japan. In our super age society, like Hong Kong, older diabetes patients are increasing, currently accounting for 77.2% of all Japanese diabetes patients. As age increases, the number of patients with complications such as CAD, coronary artery disease, and chronic kidney disease also arises. As the population is getting older, we have been facing a rise in frail and sarcopenic diabetic patients who present multiple interconnected health problems. For the management of these patients, managing blood sugar is not good enough because the cycle of physical and psychosocial decline. As you can see in the middle, frailty in diabetes is driven by a perfect storm of factors. Low caloric and protein intake leads to appetite loss and fatigue. This is often compounded by poor glucose control, low physical activity, and cognitive impairment. When we add polypharmacy, the result is significantly worse. To manage this complexity, we look to the WHO ICOP framework on the left side, which identifies 6 intrinsic capacity domains: cognition, locomotion, psychological, vision, and hearing, and vitality, I put cardiovascular to manage chronic diseases. Additionally, the use of the clinical frailty scale to categorize the patient is suggested, ranging from very fit individual to severely frail patient who are completely dependent for personal care. Understanding where a patient sits on this 1 to 9 scale from managing well to terminal ill is vital for tailoring our treatment goal. By integrating this assessment tool, we can move beyond simple glucose monitoring to provide truly holistic care for most vulnerable patients. This slide illustrates why frailty is one of the most complex challenges in geriatric medicine. Frailty is a multidimensional syndrome driven by the interplay of biological, clinical, psychological, and social factors. But you should keep in mind, frailty in this context is different from frailty in clinical frailty scale. Surrounding frailty, you can see many contributing factors. On the clinical side, comorbidity, polypharmacy, hospitalization, and poor oral health. Each place compounding burden on the body's reserve. On the nutrition side, anorexia of aging drives muscle loss through anabolic resistance and is further worsened by oral problems and poor dietary patterns. On the psychosocial side, cognitive decline, psychological distress, social isolation, and reduced activity level form a self-reinforcing cycle that accelerates functional decline. So the effective management of frailty requires a coordinated, interdisciplinary approach that addresses nutrition, physical activity, oral care, mental health, and social support simultaneously. Recognizing this complexity is the first step forward, reversing it. Physical frailty, or the Fried phenotype model, is defined by the presence of at least 3 of 5 criteria: slow walking speed, poor hand strength, self-reported exhaustion, unintentional weight loss, and low physical activity. In the cardiovascular health study, the cohort was divided into robust, pre-frail, and frail older people, and participants were followed for more than 6 years. As you can see in the figure, frail older people showed a higher risk of falls, disability, hospitalization, and death than robust or pre-frail older people. So let's go through sarcopenia very quickly. Rosenberg first described sarcopenia in 1988. In the 20th century, sarcopenia was diagnosed based on a decrease in skeletal muscle mass measured by DEXA. However, longitudinal study did not consistently demonstrate the association between low muscle mass and outcomes such as mortality. In contrast, several meta-analyses have shown that low grip strength and slow gait speed are significantly associated with outcomes such as mortality and disability. As such, researchers start to think that muscle strength and physical function are needed to diagnose sarcopenia. So sarcopenia is a progressive skeletal muscle disorder, and its impact extends far beyond mobility. Let's start on the left. Sarcopenic individuals face more than double the risk of developing metabolic syndrome. Furthermore, sarcopenia and type 2 diabetes share a bidirectional relationship. Muscle loss increases insulin resistance, while diabetes in turn accelerates the loss of muscle mass, creating a vicious cycle that is difficult to break. And beyond metabolic risk, sarcopenia is associated with accelerated organ dysfunction, including higher rates of albuminuria in diabetic patients and non-alcoholic fatty liver disease. Turning to the right side, sarcopenia also exerts a profound impact on the brain. It is a robust predictor of cognitive decline and dementia in older people. Perhaps equally important from a quality of life perspective, sarcopenic patients face 64% higher risk of depression compared to their non-sarcopenic peers. The bar chart on the bottom clearly summarizes this burden. Sarcopenic individuals face 3 times the risk of losing the ability to perform daily living independently. These figures should motivate early screening and intervention. Actually, we organized the Global Leadership Initiative in Sarcopenia, GLIS, in 2019 because we had 4 major working groups for sarcopenia: Europe, North America, Asia, and Australia and New Zealand. We had an online meeting every 2 months to discuss how to define sarcopenia based on the Delphi survey, which invited more than 100 sarcopenia researchers globally, and we came up with the definition shown in the following slide. Now, in the GLIS consensus, the diagnosis of sarcopenia is made by the combination of low skeletal muscle mass and low strength. In this consensus, physical performance is considered to be the outcome of sarcopenia on the right side. You can see the other outcomes on the right side, yes. As you know, the Asian Working Group for Sarcopenia, AWGS, was organized in 2013 and published the first consensus in 2014. The first paper received more than 3,000 citations, and then in 2019, we revised our consensus and developed a new algorithm for sarcopenia diagnosis, enabling primary care physicians to diagnose sarcopenia. The second paper also obtained more than 4,000 citations, so our work is quite successful. The photo was taken in Hong Kong in 2019. So this paper was published in 2025. In November 2025, the third paper from our group in terms of the definition of sarcopenia following the GLIS consensus. So this slide places the evolving understanding of sarcopenia in a historical and clinical context. AWGS has been the leading body defining diagnostic criteria for sarcopenia in Asian populations. The earlier guideline focused primarily on diagnosing sarcopenia in older people. This was an important first step, but the field has matured considerably, so AWGS 2025 represents a fundamental paradigm shift, moving the conversation from treating sarcopenia as a geriatric condition to viewing muscle health as a vital sign across the entire lifespan, promoting healthy aging. This is a little bit complicated. This is our new algorithm in terms of the case finding or finding risk factor. I don't have enough time to go through all the risk factors and case finding items, but basically this is one of the, kind of not screening tool, case finding tool. And then after finding the high risk person from middle age for sarcopenia, we measure grip strength. And the cutoff shown is the same cutoff for other people. And we propose a new cutoff for aged people aged 50 to 64, which is less than 34 kilogram in men and less than 20 kilogram in women. And then we measure skeletal muscle mass by DEXA or by impedance. And we also propose new cutoff for middle-aged older people. This slide shows a simplified illustration of the current understanding of the proposed pathogenesis of sarcopenia and frailty. Probably the next speaker will address the same issue. Although the relationship between sarcopenia and frailty has not been fully characterized, both conditions share many commonalities in the proposed underlying mechanisms involving a complex interplay between multiple systems and pathophysiological processes, including aging, immunosenescence, hormonal imbalance, sedentary lifestyle, and poor nutritional status, as well as other comorbidity and also chronic inflammation. So let's look at the influence of diabetes on frailty. This meta-analysis has shown that diabetes can increase the risk of frailty by 50%. We also need to understand that frailty is associated with impaired glucose tolerance, as you can see here, frail patient in the red line, with a poor glucose tolerance. This slide shows the combination of frailty in diabetes patient increase the risk for disability and survival. On the right side, the patient with the data in the diabetic patient. This slide shows the influence of sarcopenia on cardiovascular outcome, and the presence of sarcopenia significantly increases the risk of cardiovascular disease, stroke, heart failure, and myocardial infarction after multivariate adjustment in patients with type 2 diabetes. So frailty, sarcopenia affect the outcomes of patients with diabetes. So the question is whether intensive glucose control is effective in frail or diabetic patients. As you can see here, intensive glucose control did not improve macrovascular or microvascular complications or outcome in frail patients, but it did significantly increase the risk of severe hypoglycemia at the bottom. So regular or fit diabetic patient, intensive control is okay, although we need to take care of the hypoglycemia. But in frail patient, moderate intensity of control should be good enough to keep the safety of the patient. So this is the algorithm came up with the Japan Diabetes Society and also Japan Geriatric Society, dividing the patient to 3 groups, from robust to frail MCI, mild dementia, and disabled and moderate dementia. And we set the goal in each group, basically less than 10% of the appropriate goal for HbA1c. But for category 3, like a disabled or moderate dementia patient, we can choose less than 8.0%. If we use insulin or SU or glyceride, we can up-titrate the HbA1c criteria. So in terms of the intervention for sarcopenia and frailty, exercise number 1. We published the international guideline for sarcopenia, exercise for sarcopenia. And basically, we recommend resistance training twice or 3 times a week, aerobics exercise 3 times or every day, and also balance training. The combination is recommended for sarcopenia and frailty intervention or prevention. And this slide shows the effect of resistant exercise on muscle strength in older diabetic patients. It is quite effective to reduce the incidence of falls in older diabetic patients. And also, we recommend the aerobic exercise as well. And in diabetic patients, both aerobic and resistance training can improve the outcome. In terms of nutrition, this is our recommendation. So basically, we recommend high protein intake for older people with diabetes, and also sometimes HMB, which is a leucine metabolite. And also, we need to supplement vitamin D if your patient has vitamin D insufficiency or deficiency. In terms of non-pharmacological approach for frailty, so this is the standard approach: physical exercise, nutrition, comprehensive geriatric assessment, and multi-domain intervention, and social psychological intervention, and deep prescribing. And also, digital health technology can help improve your patient outcome. So these are the list of wearable devices for health monitoring in older people. I don't have enough time to go through the evidence. We have just published the guideline, which will be published in English next month. For example, this is one of the examples. Does digital health prevent frailty of high-risk non-older adult? And the answer is yes. We suggest digital health intervention, but strength is weak, and level evidence is very low. In summary, the intervention can be categorized into 5 key areas, which almost overlap with WHO ICOPE: physical, pharmacological, cognitive, nutritional, psychosocial, and sensory. These are all crucial for a holistic approach, as frailty is a multifaceted condition. The intervention are best understood through a three-tiered prevention model that adapt to a patient's current health status determined by the clinical frailty scale. First, we have primary prevention, which focuses on patients who are still in robust health. The goal here is to maintain their health and prevent frailty altogether. These involve proactive strategies to maintain intrinsic capacity by promoting physical activity and healthy nutrition. Next is secondary prevention. This tier is for individuals in a pre-frail or MCI state. The objective is to intervene early to prevent their condition from progressing to frailty. Finally, for those who are already frail or disabled, we use tertiary prevention. The primary goal at this stage is to improve the quality of life. These interventions are focused on managing the condition, slowing its progression, and helping patients perform their daily activities. This tiered framework allows us to tailor our intervention to each patient's needs, whether to prevent decline or manage its effect. Thank you very much for your kind attention.
Thank you. Thank you so much, Professor Arai. So we have heard how dementia actually causes disability and what inflammation does to the process of dementia, and how diabetes can cause sarcopenia and frailty, and some of the early principles and basic principles of the treatment of people with frailty. So we now welcome our third speaker, Professor Tae-Yong Kim, who will speak to us on how to manage the aging population through frailty-guided technology-enabled care. Professor Kim is the professor of medicine at Harvard Medical School and a senior scientist at the Marcus Institute for Aging Research. Professor Kim, please. Thank you.
Thank you very much for your kind introduction. It's truly a privilege and honor to speak here at the intersection of aging and technology. Now you have just heard about dementia and sarcopenia and frailty. I'd like to ask something a bit different. Think of somebody that you care about, a family member, a friend, or colleague. How would you recognize if they were becoming frail before it became too obvious? That recognition is the core of what we will reimagine today. Frailty-guided, technology-enabled care that transforms not just clinical practice, but also how we redesign our approach to population health and policy. Let's dive in. As a disclosure, I receive research grants from the US National Institute on Aging, and I'm a consultant to Pfizer. I want to start with a patient story, Mr. C. Mr. C is 93 years old. He lives alone. He values his independence more than anything. He still makes his breakfast every morning. But now he's sitting in front of me. He has a colon cancer. He also has multiple health conditions. And he asked this next question: should I have surgery at my age? Now, this sounds like a straightforward clinical decision, but it's not just about his cancer or his age. Because I've seen this many times. Two patients, same diagnosis, same treatment, and completely different outcomes. One goes home, the other never does. So the question is not just what is the diagnosis, but the real question is how much physiologic reserve does this person have to tolerate the stress of the surgery? And here is the uncomfortable truth. We are very good at treating diseases. In fact, we have built the entire health system around this. But we're not very good at managing a whole person. And rapidly aging societies expose this gap further in our healthcare. When older adults come to us, they don't come with one disease. They come with many conditions. They come with functional limitations. They come with physiologic vulnerability. And yet, we still treat them one disease at a time. For those of you who are clinicians here, think about your own patients. How often we optimize each condition and still fail to preserve independence and quality of life. The problem is that we lack a way to measure whole person's physiologic vulnerability and health status. That missing framework is frailty. Frailty has been extensively studied and is strongly associated with poor health outcomes in old age. Frailty is not synonymous with age or comorbidity. It is the consequence of biologic aging, accumulation of health deficits, and decline in physiologic reserve across multiple body systems. Over the life course, we build physiologic reserve, peaking in early adulthood. After that, reserve gradually declines. But not everyone declines at the same rate. Frailty reflects where a person sits on this curve and how much reserve remains. Frailty is what determines how someone responds to a stressor, like a minor infection such as urinary tract infection, a surgery, or hospitalization. In a robust person with high physiologic reserve, there's a small dip and recovery. In a frail person with a low physiologic reserve, the same stressor can lead to a major decline and sometimes permanent. We see this clearly after surgery. Patients undergo the same operation for the same diagnosis, but recovery path follows very different routes. At the top of this curve, patients with high physiologic reserve, they experience a small dip and recovery within 3 months. As reserve declines, the drop becomes larger, recovery slower, and often incomplete. At the bottom, patients with a low physiologic reserve, a sharp decline, and they never return to a prior level of function. Frailty shifts patient down this curve. We see the same pattern with the medication treatments. In non-frail patients who are taking blood thinner treatment called warfarin for atrial fibrillation for their stroke prevention, the risk of bleeding is relatively low and similar whether they stay on warfarin treatment or switch to a different newer anticoagulant called rivaroxaban. But in patients with frailty, the same clinical decision carries up to a 60% increased risk of major bleeding. We have seen this after hospitalization. Non-frail patients recovered in about 30 to 45 days. Those with mild frailty, 45 to 60 days. Those with moderate to severe frailty, it took almost 90 days to recover. Frailty is not just associated with single outcome. Once you start to measure it, you begin to see patterns for many problems of aging, such as falls, dementia, disability, and death. In other words, frailty makes physiologic vulnerability visible. Now let's go back to Mr. C. Mr. C has a colon cancer, and he's contemplating about surgery. So if I only look at his age, I might hesitate to recommend surgery. But if I assess his frailty, the picture changes. He's mildly frail, and his frailty is mainly driven by impairments in medical domain, mobility domain, and cognition domain. With this information, instead of avoiding surgery, now I can prepare him for it. I can optimize his medical conditions and mobility, implement delirium prevention strategy given his cognitive impairment, and arrange support that he will need for his recovery before the operation. Frailty assessment does something critical here. It turns uncertainty into a plan. It sharpens clinical decision and personalizes care. He also has atrial fibrillation. He's on warfarin treatment. So now the question is, should we switch him to a new anticoagulant drug? If yes, which anticoagulant drug? As we just saw, in frail patients, switching from warfarin to rivaroxaban may increase risk of major bleeding up to 60%. However, switching to a different anticoagulant called apixaban can decrease risk by 29%. So here, we are making a different treatment decision depending on the patient's frailty. Without frailty assessment, we may be making the right decision for the wrong patients. So we can guide frailty to guide clinical decisions. But the key question is, do we have additional evidence that frailty assessment improves clinical outcomes? In a randomized controlled trial of cancer patients undergoing systemic chemotherapy, frailty-guided care through geriatric assessment reduces treatment toxicity by about 25% without compromising overall mortality or cancer outcomes. Frailty is not just about predicting risk. It changes how we intervene and treat patients. In robust or pre-frail patients, we focus on building physiologic reserve to preserve their independence through exercise, nutrition, and strict chronic disease management, such as hypertension and diabetes. As frailty progresses, the strategy shifts. We now try to reduce stressors by simplifying medications that can be harmful, making environments safer, and focusing on comfort. This is the core of frailty-guided clinical management. Now let's zoom out from the patient to the healthcare system. In the community, 1 in every 8 older adults is frail. But in hospitals and nursing homes, this number becomes closer to 1 in 2 patients. Patients with frailty account for nearly a third of total healthcare spending in the United States, and more importantly, over half of preventable healthcare cost. So frailty tells us where we should really focus. Frailty is not just a clinical tool, but it becomes a population health strategy. It allows us to intervene earlier, target resources, and design better healthcare system. And now we are seeing this translate into policy. In the United States, the Centers for Medicare and Medicaid Services, or CMS, have recently introduced age-friendly hospital measures that includes frailty screening and management. It has become how we evaluate quality of care for each hospital. This is a signal that frailty is no longer a research concept. It's becoming part of how our healthcare systems are evaluated and designed. If frailty is so powerful, why is not used everywhere? Here are the barriers. Frailty has traditionally been measured in geriatrics clinic by a geriatrician. It's episodic, time-consuming, and it's not scalable. That is why it has not been widely adopted, but this is about to change. Because we are entering a new era an era where data and technology can make frailty scalable. So what does that actually look like? We no longer have to see a geriatrician to measure frailty. Soon we'll be able to measure it using the data that's already exists. So at the clinic level, frailty informs clinical decisions in your primary care physician's office. With administrative claims, insurance claims, and electronic health record data, we now measure frailty across entire populations. And with sensors, we can monitor frailty continuously in real life. So let's start with the clinical care. One major barrier has always been there are too many frailty tools, and ironically, they are not very accessible to the clinician at the point of care. So we built a platform called eFrailty to bring all validated tools together in one place. It makes frailty assessment practical, accessible, and usable at the point of care. We can now measure frailty using data that already in the system through electronic frailty indices and claims-based frailty indices. These measures use routinely collected healthcare data, such as diagnosis, healthcare utilization records, and other indicators to quantify the amount of deficits in an individual. This allows us to identify frailty in millions of patients without adding burden to clinicians. How well does this work? I'm going to show you an example using a claims-based frailty index that we developed for the US Medicare data. As claim-based frailty index score increases, gait speed declines from about 0.8 meter per second in robust individual to 0.4 meter per second in the most frail. This is not a subtle difference. It represents a transition from an independent mobility to a homebound status. This tells us that claim-based frailty index is not just capturing diagnosis and utilization, but it is capturing real measurable functional decline and vulnerability. Electronic and claim-based frailty indices have been validated across large population data sets. And they show a consistent graded association with outcomes that matter, such as mortality, hospitalization, and long-term care nursing home admissions. But even this is still a snapshot. Frailty is not static, it evolves over time. So the question is, can we detect frailty in real life as it changes? If frailty represents a physiologic reserve, we should be able to see it in everyday life. This is where sensors come in. The first question is, can we estimate frailty using data from sensors? And the answer is yes. Because frailty shows up consistently in how people move in the real world. Fewer steps, slower walking, more variable gait, and slow fragmented movements. And emerging studies have shown that these patterns are associated with a clinical frailty and can predict the future adverse health outcomes. In other words, frailty leaves a digital signature. Once we detect this signature, we can track it, how it changes over time. Here is an example of a gait variability change over time. Gait variability is a simple marker of frailty that tells us how stable our system is. What you see here is increasing instability in the days before a full event. This signal came first, but we are not acting on this signal. This is a missed opportunity. If we can detect this signal, we don't have to wait for the full event to occur. There are many devices, watches, rings, pendants, and other wearables, but the goal is not to have more devices, but the goal is to how to integrate these signals into something that we can interpret and act on. Then frailty becomes something that we can monitor continuously beyond the clinic and respond to earlier. And importantly, this will give individual visibility into their own physiologic reserve so that we can take an action before a fall, before hospitalization, before disability. I'm going to end with another patient story. Miss K, 66 years old. She's doing well with stable chronic conditions. And she asked the following question. I feel fine. How do I stay independent as long as possible? This question has no clinical answers today, not because we lack interventions, because we already know that exercise, diet, comprehensive geriatric assessment, and medication optimization can help. But the problem is we apply them too late because we lack routine ways to detect subtle changes in health before clinical decline occurs. Now imagine a different future, a future where we can detect vulnerability early, intervene before clinical decline, and we don't have to wait disability to occur, but actively prevent it. Early detection creates a window for proactive intervention, a window we can act while physiologic reserve is still maintained through lifestyle optimization, preventive care, and even emerging therapies that target the biology of aging. For example, agents like metformin, an old diabetes drug, are being investigated for their potential to influence the aging pathway, the biologic pathway of aging. Although there are still a lot of work to be done, this is the promise of frailty as a measurable, actionable signal of aging. And with the tools that we now have, we can begin to act earlier than later. So let me bring this together. Frailty is not just a measurement. It is a framework for care. At the bedside, it allows us to individualize clinical decision. At the population level, it allows us to target resources efficiently and intervene earlier. At the system level, it allows us to design better healthcare system around physiologic reserve and vulnerability so that care can be targeted, proactive, and preventive. Frailty is a framework that connects clinical care, population health, and policy. I'm going to end with the following message. Frailty tells us who is vulnerable. Technology makes it scalable. And together, they give us a path to reimagine how we care for aging populations. Thank you.
Thank you. Thank you again. Thank you so much, Professor Kim, for that truly insightful and inspiring presentation. Now, it takes me now to welcome our last speaker of this session, Professor Weng-Ming Hu, who is Vice President and tenured professor at the Peking Union Medical College Hospital. Professor Hu will present on Dancing with the Wolf, Emerging Pathways Towards Long-Term Survival in Pancreatic Cancer. Professor Wu, please. Thank you.
Well, thank you for the introduction of the chairman, and also thank you for your invitation. It's my great honor to be here and present our research and clinical practice. And the topic today, I think, will be aging and chronic disease. But my major for the past 20 years on pancreatic surgery and pancreatic diseases. So I think the first of all, pancreatic cancer is also a chronic disease. From the beginning of the pre-cancerous lesions and the development of the cancer progression, we can see the patient need to experience over 15 to 20 years. So after the diagnosis of the PDAC, the patient have to face the comprehensive and the continuous treatment. And also, PDAC is also a critical disease. We can see the incidence of pancreatic cancer is rising annually, and also is predicted to become the second leading cause of cancer-related deaths by 2030. For the GBD database for globally, for example, in 2023, the incidence about globally 500,000 people attacked by pancreatic cancer. And also you can see the mortality. In the same year, the mortality also 500,000 person. So if we see this curve, we can see the rate of new cases and the deaths from 1992 to 2023. The new case fatality rate nearly 90%. So the living curve and death curve nearly close. So pancreatic cancer carries the worst prognosis. If we put pancreas into all size cancers, we can see all size, the 5-year overall survival would be 70%. And you can see the thyroid and the prostate is nearly 100%, but you can see pancreas only 13%. And so we call it king of cancers. And you can see this is for the past decades, from 1975 until now, the incidence, the 5-year overall survival is from 3.2% to 13%. So that means the limited improvement in pancreatic cancer treatment. So how about if we see a patient in my clinic? We always divided them into 4 stages. For the resectable, we would like to choose a surgical resection plus adjuvant chemotherapy. And for the borderline resectable and also locally advanced lesions, we would like to neoadjuvant chemotherapy with or without radiotherapy. And then we go left or go right. If go right, we can see the patient with metastasis, maybe liver or lung mass, and that would be choose to a palliative tumor-directed therapy. But the pathway is clear, but the outcomes are dismal. We can see after the surgical resection, the recurrence is really high. It's 86% within 5 years, and even for 1 year, nearly half. And we have a lot of chemotherapy regimen this year. You can see this is the very advanced chemotherapy regimen in the recent 5 years with a lot of new drugs. But we can still see most of them, the median overall survival only less than 1 year. So is it all for all patients? And also, the key clinical characteristic of PDAC, we can make a conclusion as 3 high. The incidence is rising, and also high risk of recurrence and metastasis, and extremely high mortality. Also 3 low. That means low rate of early stage at diagnosis, and the low surgical resectability, and the low 5-year survival. And 3 poor tumor biology, and poor treatment efficacy, and also, as the previous reporter said, poor performance status for this patient, because most of patients of pancreatic cancer, they get the incidence median about 60s or 70s, so it's a senior disease. This is the challenge we are facing with the pancreatic cancer, but if we see the innovations, new techs in these years, which brings population benefits and the visual benefits. as we know, the later stage is associated with poorer prognosis. Let's see the figure. Over half is about 57% of the cases diagnosed by the late stage with distant metastasis. Only 15% is localized. And also, you can see the right figure. That's for the late stage, only 3.2% of 5-year survival, and advanced is only 16. But for the early stage, maybe the 1A, according to the TNAM classification, is 43%. So it's a glimmer of hope in the darkness. So let's make a hypothesis. If we can shift the stage, now the current is NAM as about 43. But if our goal is all the patients diagnosed without metastasis, that means detect patient earlier. We can see better overall survival in 5 years. So detecting patients at the non-metastatic stage is expected substantially improve prognosis. But the population screening is very difficult. Why? First is the low incidence of pancreatic cancer. As we know, pancreatic cancer in the United States is for the incidence about the 7th of all cancers. But in Chinese population, that will be 8th or 9th. But it's only 1 in 10,000. So you have to catch one criminal in 10,000 people. So it's not so common. And also, the screening is costly and efficient. It's not like the breast cancer, you can use ultrasound, or colon cancer, you can use endoscopy. There's not so many weapons we can use, just the CT scan or MRI. You know, it's very big machine and you have to put the patient to the big hospitals. And also no robust screening biomarkers until now. And then, you know, the anatomy is very special for the pancreas. It's deep in our abdomen, so it's hard to find. So the realistic screening option we call 3E strategy: enrichment for the high-risk individual, and early screening for liquid biopsy and the image scan, and the early diagnosis use image and the pathology. This is a very famous study several years ago. The Johns Hopkins group, they use HRI, which means high-risk individuals. The definition is history of pancreatitis, cystic pancreatic lesions, new onset diabetes, and the family history of pancreatic cancer, and also the cancer-related germline mutation carriers. They go through these studies over 20 years, and 1,000 HRI included. So the outcomes that demonstrate pancreatic cancer can be traced, but you need a lot of time and enough human power, human resource to do this. So this is a Denmark cohort. They use a transformer-based risk modeling for future PDAC prediction. They use this model, the two figures shows the AUC is 0.88 in Denmark cohort, and they can predict risk up to 3 years before diagnosis. And this is our research. We use a cohort built on PUMCH, my hospital, and the UKB and the CKB cohort. We recruit over 600,000 controls, and we found over 2,000 pancreatic cancer on this series. And we can predict the patient 8 years before the diagnosis. The AOC is 0.75. The second E is liquid biopsies, early screening. But I have to confess, we don't have much more biomarkers for early detecting, early screening for pancreatic cancer. We have a CA99, but it's for the advanced cases, not for the early stage. So, but these years, throughput sequencing of according to the central dogma, the DNA, RNA, and the proteins find a lot of new things, special on the CF microRNA and the exosome mRNAs. And the third E is early diagnosis. You can see all the patients have to move to a radiologist to see the CT scan or MRI or ultrasound to decide if there's a lesion in his pancreas. But when we use radiomics with machine learning, we can diagnosis at before the clinical diagnosis, 3 to 60 months. And also, the model can capture some subtle signals which not found by the doctors. And this is another AI-based contrast enhanced CT for the small tumor detection. We can see the sensitivity for tumors less than 2 centimeters of CNN is over 90%. And the study also detected 11 of 12 occult PDAC missed by radiologists. This is 2 years ago. It's a very famous study called PANDA study by a Chinese team. They used the non-contrast CT. Non-contrast CT is often used when the patient gets a physical examination. They have a chest CT, but the upper abdomen just come into the view. So they train supervision and the non-contrast CT to feed on the PANDA model. And then they get 2 results. The first is the detection. The model can detect the lesion versus normal. And also for the diagnosis, it can discriminate the pancreatic cancer with other pancreas disease. So this is detected and classified pancreatic cancer's lesions on routine CT. It's very important because that means we can use it for the population-based screening. At previous time, we don't have this kind of weapons use a non-contrast CT scan. It's very cheap and very, very fast. And so if we see the population benefits pathway from diagnosis to surveillance, we can see the general population. We use clinical high-risk factor screening and also combined with genetic susceptibility from multi-omics sequencing. Then we put all the data, all the things to the AI module. We will see a high-risk cohort. And between the high-risk cohort, we have to know the real high and the relative high. So some cases diagnosed at the initial evaluation and some diagnosed during the follow-up. This is for the aspect of population benefits, and also we can see for the individual benefits because each patient is a patient. So the patient, when he comes into a medical center, he will get a personalized treatment about stratify, decide, deliver, and adapt. And then the doctor would like to choose therapeutic approaches such as surgical procedures and precision treatment of chemotherapy or other interventions. But because of time limitation, I would like to focusing on, the target drugs and the neoantigen vaccines. The first is the targetable of PDAC. 5 to 7% of PDAC express BRCA and the HRD excesses. But KRAS is the central. 90% of pancreatic patients, there's a dominant driver of KRAS, and only less than 10% of long-tail targets, such as MSI high and HER2 BRAF. It's a rare individual, but it's still a group. KRAS is the central driver of PDAC. It mutated in over 90% of PDAC and the early and the dominant oncogenic driver. It is relative to tumor growth, metabolic reprogramming, and the survival and therapy resistance. KRAS was once believed undruggable for the cancer treatment. About 10 years ago, still think undruggable label, but in the nearly 2 years, the G12D KRAS era comes, and several clinical trials is ongoing. This is an autography of KRAS G12C mutant tumors. This is a phase 2 trial. We can see they recruit 57 previous treated advanced solid tumor, but above the PDAC, the response rate was 33%. And the phase 3 crystal trial now open for enrollment. This is one of my case. We have a KRAS G12C study. It's a phase 2 trial. We can see this CT scan shows 2 years ago, and the latest CT scan for the primary lesion of the tail of the pancreas is stable disease, but you can see for the metastasis in the pelvic cavity, it's shrink very clear. So the patient get a progression free for over 2 years, and the CA99 go from 10,000 to the normal level. So it's a successful case. Now the KRAS G12D is on the way road, because only 1 to 2% of pancreatic patient expressed has the G12C, but 40% with G12D. This is a phase 1 trial. They recruit 21 metastatic PDAC patients, and 67 of the patients in third line setting. The ORR is 24. It's the global phase 3 now enrolling the first line patients. It's a little bit promising. This is the latest research of phase 1 trial. We can see the beautiful curve. The DCR is 80%. It's really high, and the ORR is 30. 104 PDAC patients enrolled, which all late stage. Another innovation is about the mRNA vaccines in cancer therapy. Just several months ago, there's published a paper. The mRNA vaccine used in pandemic of COVID-19. We have two groups: the population with vaccine and the population without vaccine. So in the first population, we see the cancer patients get better prognosis than the second population of the cancer patients. So that means mRNA vaccine can make a whole body response, immune response for the patients. So that will do some help for the cancer control. This is the personalized neoantigen vaccines. This is the workflow and the advantage of the personalized. There's ongoing, published last year, it's a BNT biotech company. We can see from the tumor sequencing and the new antigen prediction, and then the mRNA vaccines use the LNP, and then the chemotherapy and the T cell activation. We can see the living curve. The responders with the immune response with much higher clinical outcomes than the non-responders. So 50% of the patients, 16 patients involved, 50% develop new antigen specific T cell responses, and the non-recurrence at 18 months median follow-up. And also we can see 6 longer relapse-free survival in responders with non-responders. We have our own mRNA vaccines in our center. We have another personalized vaccines. You can see the left side is the living curve. The blue one is gemcitabine, and the right one is the mRNA with gemcitabine. We can see the living curve is much better. And you can see the right upper figure that shows the Alice Sport responses in pancreatic cancer patients. We involved 23 patients in our group, only 4 non-response, 19 response. So the response rate is about 80%. And compared with the biotech surgery, the response is 50%. So for the personalized treatment workflow with comprehensive profiling and biological stratification and mesh treatment, after the monitoring, we have MDT, a lot of doctors from different experts to the reloop of the workflow. Okay, I want to make an end. So we can see innovation creates possible from population survival gains and for the individual. For the population survival gains, our goal is shift the treatment window earlier, and our strategy is enrichment, early screening, and early diagnosis. And what makes it possible is the data integration and AI risk models, liquid biopsy, and AI imaging. And for the individual benefit, our goal to match the right therapy to the right patient. Our strategy was stratification, design, monitor, and optimization. So what can make it possible? We use personalized treatment, target drugs, gene and cell therapies, and mRNA vaccines, even a lot of experts who attend. So survival gains require both earlier detection and better treatment. So this is the last one, and the innovation such as AI tools can empower pancreatic cancer care from early detection to survival doubling. So the AI-driven risk factors and detection and diagnosis pipelines, we use the EMR data stream, and also we to find the early lesions detection using deep learning identities. And also our computational pathology subtyping, we can make the pancreatic cancer into different groups with different prognosis. And also the precision treatment and the survival impact including different kind of treatment. And the most important now, the 5-year overall survival is only 13%, but we have a dream of doubling. One doubling is come to 26. What that means, in liver cancer now it's 22. For the lung cancer, it's 28. So if the pancreatic cancer come to 26, that's not a king of cancers. We can take off his coral. So this is our dream. And 5 key message. Now we are in a tipping point. We use AI tools, a lot of liquid biopsy and the new screen techniques. And now it's happy to hear KRAS is druggable, and also we have mRNA vaccines. AI is a multiplier, not just a tool, and the overall survival doubling, I think, may be achievable in the near future. Thank you very much.
Thank you so much, Professor Wu. Wonderful and excellent sharing. May I ask you to remain on stage, please? We will now move our session into the panel discussion part of the session. Our colleagues will help set up the chairs, etc. So, please. Okay, sure. Okay, right. So now we have just heard from our 4 very distinguished keynote speakers, and I would like to take a moment while we're setting things up to thank all of them for such wonderful lectures, and amazingly, for really keeping to time. We are very, very prompt at 3:05 end of the first part of this session. And it is still my pleasure to serve as the session chair for this discussion panel on aging and chronic disease management, challenges and innovations. And we will delve deeper into the themes raised, and our various panel discussants are getting ready on the stage. And we have, of course, Professor John O'Brien, Professor Hidenori Arai, Professor Tae-Yong Kim, Professor Weng Meng Hu, and also our new panelists. Do I sit? All right, I remain here. And we also have our new panelist, Professor Jacqueline Yuen, from the Department of Medicine of the University of Hong Kong on stage. A big round of applause for all of them, please. Now am I supposed to be over there? Thank you. Thank you. Now, just a quick reminder to colleagues on the floor and also those online that you can actually submit your questions anytime via the QR code displayed on the screen here. And in fact, while I was chairing the session earlier on, I have received a number of questions already. But perhaps to kickstart, maybe I will ask Jacqueline, as an academic and practicing geriatrician in Hong Kong, your takes on the 4 lectures that we have just heard now.
Thank you, Professor Lau, and to our 4 distinguished keynote speakers for your enlightening talks and setting this multi-dimensional agenda for aging and chronic disease management. So from your talks, I saw that we covered the whole continuum of aged care, from prevention in diabetes management to early detection in dementia, to active management of frailty using technology-enabled care, and also diagnosis and treatment in advanced illness in the case of pancreatic cancer. I wanted to make some comments for each of your talks as well. So, Professor O'Brien, thank you for your sharing about inflammation and dementia. And you highlighted the link between systemic inflammation and the acceleration of neurodegenerative processes, and contributing to cognitive decline and dementia, and how knowing this, it can lead to important discoveries of potential biomarkers of inflammation to help us in predicting outcomes of dementia as decline, as well as perhaps creating pipelines for new therapeutics in treatment of dementia. So, one thing that's been on my mind is, while we are rapidly developing these new diagnostic biomarkers, we have not yet developed effective treatment that is curative for dementia. And so I think coupled with these developments, we also need to be able to learn how we should communicate the implications of these positive biomarkers, especially before patients develop symptoms, and the fact that we don't have effective treatments to cure their illnesses. So for Professor Arai, so thank you for your sharing on sarcopenia and frailty in diabetes management in older adults. You talked about the high prevalence of these conditions in older adults with diabetes, and how it's important to be aware of them because they can lead to poor outcomes in older adults, including functional decline as well as cardiovascular outcomes, which is exactly why we need to control diabetes well. And there's a bidirectional relationship between sarcopenia and diabetes, which means that we should also focus on looking at muscle health across the lifespan, right? Not just after people develop diabetes, but actually if we improve muscle health, it can perhaps reduce the risk of diabetes. So I think it does shift the whole paradigm of how we manage diabetes from this target control-oriented approach to a more holistic approach, incorporating assessment and management of frailty and sarcopenia in diabetes care. I think that's very enlightening. Professor Kim, with your sharing about the importance of frailty as not just a measurement tool, but also a way to guide management of older adults as a way to optimize older adults before surgery so they can have better outcomes or even improve outcomes in people with cancer. So I think those are really relevant to care of older adults. And I think it was very exciting that you mentioned how technology can now make frailty assessment scalable in a way that we haven't been able to do in just our geriatric practices. So with the use of big data, such as using EHR data, as well as using sensors, wearable technologies that we have nowadays. So my question related to that is, how, given the utility of frailty guided management, how do we really try to implement this more widely in our healthcare system? Beyond the geriatrics practices, how do we influence our colleagues in surgery, in cardiology, and other specialties? And then Professor Wu, thank you for your excellent and exciting sharing on the role of AI and other technologies in therapeutics, advancements in cancer therapeutics for earlier diagnosis in population-based screening in pancreatic cancer. I think that it's really exciting to see how all of this can lead to, on a population level, how we can improve screening and detection of pancreatic cancer, as well as allow more personalized cancer treatments. So when I saw your title, Dancing with the Wolf, I think what comes to mind is when older adults have cancer, the wolf is not only the tumor, but also the toxicity that they may experience when they receive cancer treatments, the treatment burdens, and its impact on quality of life. And so I wonder how we can also incorporate those elements in decision-making while we have these advances in our modelings, if those elements can also be incorporated into decision-making.
Wow. You see, I am not bad at delegating what I have to do to my colleague. Okay, thank you very much, Jacqueline. And you have had very good comments, and also you've asked each of our panel speakers a question each. But maybe before I therefore ask my questions, I'll ask our panel speakers to respond to what Jacqueline has just asked you. Professor O'Brien, please.
Well, thank you very much for your questions. I sort of agree with them. So the first one was in two parts, really. It was about, we've progressed a lot with diagnostics for Alzheimer's disease. We haven't really progressed so far with treatments. And what I'd say to that is, yes, but the diagnostics have to come first, because without being able to define the clinical syndrome, the diagnosis, you can't develop treatments. And I've seen that throughout my career. So my first memory clinic I did as a very junior doctor back in about 1990. And I remember talking to the consultant who was making a diagnosis of Alzheimer's disease. And I asked that very same question. I said, why do that? Because there's no treatment we can offer the person. And he said, well, no, that's right. But we're doing this clinical trial of a new compound. And unless we diagnose people, we can't enter them in for the trial of donepezil, it's a cholinesterase inhibitor. And they became the first treatments we had for Alzheimer's disease. the first trials of anti-amyloid therapy, the immunotherapy trials, they didn't have amyloid positivity as an entry criteria because that just wasn't widely done. When they look back on data to see that, 1 in 3 people entering those studies didn't have amyloid in the brain to be able to benefit from the drug. So they sort of had the wrong type of person. So I think you do need the diagnostics first. The second thing as a clinician is people come to me wanting a diagnosis. And I think it's good to have all the tools at your disposal so you can give that as accurate a diagnosis as you can to the person that's coming. The second bit of your question was, again, I sort of agree with it. Haven't you got to be careful about telling people the results of these biomarkers? And I think absolutely. And that's one of my big fears, that while I think if somebody's coming to you with a problem and you're doing a diagnosis anyway, you want to give them the best diagnosis that you can, which is going to be using these biomarkers. The danger is that once they're widely available, people will just, get them anywhere and have all sorts of different interpretations. I was actually involved in a literary debate in Alzheimer's and dementia last year on a related topic, which was about giving people feedback on Alzheimer biomarkers if they had dementia with Lewy bodies, different sort of dementia. And a lot of people there with DLB have amyloid positivity. But actually, we don't really know what that means. So I was on the side of saying, no, we shouldn't be telling them they've also got Alzheimer's disease, because that's just unhelpful and it's probably not true. We should be very careful in what we disclose. So I absolutely agree with you. How we limit that is an active debate in the UK, and I'm sure it is here. I saw a very interesting paper, I don't know if you're part of it, from a consensus paper from Hong Kong about use of biomarkers and amyloid treatments, and it had a lot of really good sense in it that was just published a year or so ago.
Thank you very much, Professor Brian.
Okay,
Professor Arai?
Let me answer your question. And also, I'd like to add some comment about the biomarker for Alzheimer's. We have also done the multi-domain intervention trial for the prevention of dementia using several biomarkers like beta amyloid, p-tau217, NFL, and GFAP. Interestingly, for example, patient or person with high GFAP has a high risk to be demented or cognitive decline, but more responsive to the intervention. So if we have a high biomarkers in the plasma, you don't have to, be disappointed. If you can join the multi-domain intervention, you can definitely prevent the development of cognitive decline. So that's a very important message. Also, people with ApoE4. ApoE4 is a high-risk gene for dementia or Alzheimer's. But people with ApoE4 are more responsive to multi-domain intervention than people without ApoE4 gene. So ApoE4 people have a 2 to 4 times higher risk for dementia, but you don't have to get disappointed. If we can provide, or we can provide multi-domain intervention, we can save their life or prevent dementia. That's my comment about dementia biomarkers. In terms of diabetes, so we need more discussion. I'm a geriatrician taking care of older diabetic patient with multimorbidity or frailty, sarcopenia, or cognitive decline. So, but we need paradigm shift. We need to talk to endocrinologists or cardiologists who are taking care of diabetes patient in the middle age. They need to understand those diabetic patients develop sarcopenia, frailty, or cognitive decline in 20 or 30 years later. If a patient's age is 50, like a 70 or 75, they often develop frailty, sarcopenia, and dementia, or MCI. So they need to understand not only, of course, preventing cardiovascular disease or microvascular disease is important by managing the risk factor of diabetes like hypertension or dyslipidemia. But at the same time, keeping the muscle health in middle age is very important for the management of the diabetic patient in middle age, considering the future development of frailty, sarcopenia, and dementia. So that's a very important message to deliver to endocrinologists or cardiologists. So that's would be a paradigm shift for medical society, but there's no incentive whatsoever, as Professor Kim mentioned. United States has introduced EFI system, but not in Japan. only geriatricians are measuring frailty or sarcopenia in a clinical practice, and not other primary care physicians not interested in frailty, sarcopenia, or cognitive decline. We need to insensitize, or we need some incentive for primary care physician to screen frailty, sarcopenia, or muscle health, or cognitive decline, or whatever. So that should be, implemented in the healthcare system, but it's hard to convince the government so far.
Thank you very much, Professor Arai. Professor Kim?
Well, first of all, I want to thank Professor Yoon for summarizing and asking a very important question, which was how to scale frailty assessment beyond the geriatrics clinic. In order to achieve this, we need two things. First, we need to make frailty information available at the point of care. And second, we need clinical evidence and training to how to use that information to inform clinical decision. So how are we doing in those two fronts? I'm going to first address the first issue, making frailty assessment available at the point of care. In my talk, I did mention about there are too many frailty tools. But at the same time, if you ask any of the clinicians who are outside of geriatrics, they don't know what tool to use, and they don't know how to find them. So I think having e-frailty platform resolves much of that challenge by putting all validated tools together in one place with a web-based calculator, so you don't have to remember how to score it, how to interpret it. It's all done with help of the web-based calculator. And the other thing is that there is increasing interest of using data science to calculate frailty score based on electronic health record or insurance claims data. Insurance claims data may have a little bit of lag time to make it available to the clinicians. And then clinician may not have immediate access to the claims data. So claims data-based frailty index has been mainly the research tool and population health tool rather than clinical tool. However, electronic medical record-based frailty indices are becoming more popular, and because it's using the information that is currently in the electronic health records, it can be made available to the clinician at the point of care. So that is a promising area that frailty screening can be done automatically using database derived frailty score. But the accuracy of this electronic or even claim-based frailty index is not as good as clinical frailty assessment. So it's a good screening tool, but has to be confirmed with a clinical practice. In terms of sensor, I believe that it has a lot of potential to make frailty really available beyond the geriatrics clinic. So let's imagine if you have a phone, watch, or wearable, and then there is an algorithm embedded in that device to give a frailty risk score. So you can bring it to your clinicians, primary care physician, or specialist to discuss what I need to do to improve this score. And so that will make frailty information even more broadly available in the population. The second thing is evidence generation. So there are a lot of evidence that show frailty predicts poor health outcome or poor clinical outcomes. That's too obvious, but I think how to use that information to make clinical decision, that part has not been fully explored. So I think we need to really think about, once you have information about this person's frailty, how can I make a different treatment decision based on that information? So that is really important area that we need in the future. Lastly, we have made a lot of progress. Frailty has been integrated in oncology, surgery, cardiology, and now in emergency medicine. So I think there are more and more specialties that sees the value of frailty assessment. So the time is coming, but if we can actually put a right healthcare policy and incentive to this about doing the right thing, we can accelerate this trend. Thank you.
Can I add one?
Please, Professor Arai.
I think e-frailty index is pretty good, and also the UK has also implemented e-frailty index in their electoral chart. The problem is we don't know how to intervene the patient. If we find a frail patient with a high e-frailty index, so that's why we recommend WHO ICO, which is in which intervention can be individualized based on the impaired intrinsic capacity in each domain. So any solution to personalized intervention for frail patient, if you find the patient with a frail patient with electric frailty index.
A very good comment. And please, Professor Kim, you want to?
Yeah, I appreciate this question, Professor Rai. So what I think it's important to realize is frailty is not just the yes/no labeling. It's actually spectrum. It's a continuum. And it is, in addition to knowing who's frail or not and how much of frailty one has, it is important why that person is frail. So patient can become frail for a wide variety of reasons. It could be dementia leading to frailty, cancer leading to frailty, cardiovascular disease leading to frailty. So the management is different based on how patient got to that frail stage. So among the different frailty tools, it may just give a score or a classification, oh, this person is frail. So that may be helpful for risk stratification, but that doesn't really help you how to manage that patient. But if you look at some of the frailty scores that are based on comprehensive geriatric assessment, in addition to giving an overall frailty score, it also gives the domain-specific impairment. So that actually matches what Professor Rai mentioned about ICO model, intrinsic capacity domains. Is it really cognitive domain or locomotion, physical domain, or psychological domain that drive that person's impairment? That information is necessary to come up with an individualized treatment plan to optimize that person's health.
Thank you. Thank you very much, actually, for these further comments. Perhaps, Professor Wu, on your precision treatment for carcinoma of the pancreas?
Okay. Thank you, Jacqueline, for your summary and you raised a very good question. When I prepared my talk, I choose a Dancing with Wolf. I remember it's an old movie, maybe Kevin Spacey.
Yes.
30 years ago, maybe.
What's his name, right?
Yeah. Because what the wolf means, I think, is cancer, but not just the pancreatic cancer. What we see, I show a figure, put pancreatic cancer into all sides of cancers, or the organs. We can see for the thyroid and prostate, even breast cancer, with a very good prognosis. So we can say we can dance with the wolf for that kinds of cancers, because people can live longer together with the cancer. Maybe you cannot eliminate the cancer completely, but you can live with the cancer, but not the pancreatic cancer. At this time, I think it's eaten by wolves, because most of patients have an overall survival about just 1 year. You can live with the cancer. So we proposed some population benefit and individual benefit from the recent techniques. For the population benefits is we can use AI tools. Why we have to use AI tools? Because it's relative lower incidence cancers, pancreatic cancer, not just like breast cancer or colon cancers. The incidence just 1 through 10,000 in the population. And you have to put a patient into a CT room, MRI room, and you have to find a very experienced expert radiologist to find the tumor. So it's very difficult for the population to screen. But if we have AI tools, just, especially in China, a lot of general population, they get a physical examination with very good centers each year. They have a lot of routine CT scans. So that is give us these weapons. Another way is individual. In recent years, many new therapeutic approaches approaching. So I think Dancing with Wolf is our dream. So I made this name. Thank you.
Yes, I used to use a very similar description on the management of my patients with systemic lupus erythematosus as well, when prognosis was very poor many years ago, but now, of course, with advances in almost everything, that we are able to manage them better. Thank you all very much for this wonderful, comments and also answers to Jacqueline's questions. I have indeed prepared a number of questions on my piece of paper, but then on my iPad, I see a number of questions from the floor as well as from online as well. I'm going to pick two questions to start with. One very simple, I think, straightforward question for Professor O'Brien, and another one for all four of you, okay? The first one is actually on the role of vascular aging in dementia. Now, the second one is actually very, the role of vascular aging in dementia. The second question actually concerns all of you. In fact, we have spoken so much about how we could early diagnose and early predict and then provide precision treatment to our patients. The question is actually on, what about the families? What about the caregivers? Now, can technological systems not only monitor the elderly and the patients, but also actively provide decision support and psychological respite for caregivers? Can you provide some examples, if any? So maybe Professor O'Brien to start off with vascular aging and dementia.
Thanks. It's not actually an easy question, but I will be very brief. So there are two answers, I suppose. One is that vascular dementia, which isn't always dementia after stroke, but can include other sorts of dementia where you get silent infarcts and white matter changes, is recognized as the second most common cause of dementia. So that is important in its own right. There's a much more interesting story, I think, about vascular contributions to Alzheimer's disease, where it does seem to be an extra pathology that exerts effect, both in terms of altering the threshold for developing dementia. In other words, if you have vascular brain changes, you're going to get dementia at an earlier stage if you develop amyloid and tau pathology. And also there's some evidence that vascular changes themselves actually accelerate the deposition of amyloid and tau, so might accelerate the changes. So I'll just leave it there probably, but thank you very much for the question.
Thank you, thank you. So maybe we'll come to the question number two then, but Professor Arai has already got his microphone on.
That's a very difficult question.
Caregivers.
So I think our future will be the combination of personal health record, PHR, plus wearable device monitoring for frailty or physical activity. So, and then we should give some incentive to each person. Otherwise, nobody will, incorporate PHR assessment. PHR should be fine, but they don't buy wearable devices to check their physical activity. So we need some incentive. And then we can detect the early sign of frailty, sarcopenia, or cognitive decline using personal health record data and also daily activity measured by wearable devices. That's one of the goals. And the question is how to give some incentive. Maybe one of the incentive would be to lower premium for healthcare insurance. Currently, in Japan, the premium is pretty expensive for most of the people. If they can get some incentive or discount for health premium, they might adopt some such tool for daily life and report to their doctor, and can be early sign of many diseases can be detected at early phase. But I'm not so sure whether we can implement that system in Japan. In terms of family education, I think we need to talk to the industry because many people, middle-aged people are working in the industry, and we need to tell the company that the education for healthcare is important for their employees. They're taking care, they have parents of older age, but most of the, employees don't know how to care dementia or how to prevent cardiovascular disease or how to, improve muscle health. So those kind of information should be provided for the employees, and then they can see their parents, and if it's lucky, they might be able to teach their parents to change their lifestyle. So I think that's one of the solutions for us to, provide some education for family members. And also in our center, we provide family education class for patients with dementia. So we invite the patient with dementia with their carer or family members. And family member understand how to care to prevent PTSD or other, ADL decline. Those kind of education is important, but there's no incentive whatsoever in Japan. So those need to be, implemented in our clinical practice, but it's hard to get some incentive.
Thank you very much, Professor Arai. Professor Kim, you have anything to add?
I just want to just echo the importance of caregivers in geriatric care, especially when you think about like how to define caregivers. Actually, caregiver can mean a lot of different things. It may be a family member or paid or unpaid caregivers who are not family members, and also making important treatment decision, care decisions, or providing actual physical assistance at the bedside. So I think it's important to really think about who's taking this like a specific role for the patient's care. So the other thing is we may have, so we encounter this in the United States when I practice. A lot of times when I see patients, their caregivers, mostly adult children, are heavily involved. And they're really playing a crucial role, not only providing care and supervision they need, but also actually assessing patients' health status. So I gather more information about the patient health status from the caregiver. So in terms of when I think about frailty assessment, I gather a lot of information about the patient's frailty. I mean, not only from patient themselves, but also from their caregivers. So I think educating caregivers about their role and providing accurate information, and also making sure that what patient reports are confirmed by the caregivers who know about the patients are really important. And also the last thing that we often find challenges is that in electronic health records, sometimes even though we're sending messages or sending letters to the patients, it's often the caregiver or adult children who are responding. And so how can we actually, ethically and legally, do these proxy assessment without any challenges, especially it's a patient records, but the caregiver is actually using it on behalf of the patient. So how much of information we can share? I mean, that's a different challenge that we need to have a more clarity on. So, I mean, some of these are challenges, and we need to work on this issues in order to have a better support system for our older adult population.
Yeah, I cannot agree more. As a rheumatologist myself, I look after patients with chronic arthritis like rheumatoid, etc. And we did a study earlier on actually asking, when a patient is sick, who do you look to? And then besides the doctor and healthcare professionals, their caregivers, etc. So educating their caregivers, providing support to them is very important. Professor Wu, do you have anything to add, you know, in the management of such aggressive disease as CA pancreas? Caregiver support?
I want to share something. Because the topic today is aging and chronic disease, as I mentioned at my talk, pancreatic cancer is also a chronic disease. I have a very similar words, like the frailty. It's cancer caucasia. So cancer caucasia expressed with sarcopenia and also frailty. And we see a lot of elderly patients with pancreatic cancer diagnosis. They may be 80s, maybe 90s, because the incidence average age is above the 60s. So we see a lot of senior patients in our clinic. So we have to face the same question, like the colon cancer example. Can we make a VIPA procedure or distal pancreatectomy for the patients with 80s or 90s? I think now we have a very good palliative therapies, very best support therapies. So we can perform procedures on some selected patients. So I think such as pancreatic cancer and not least liver cancers, lung cancers, we have to use our aging policy or our chronic strategy to treat all these patients. So we have to establish for the surgeons, for the oncologists with this kind of thoughts. Thank you.
Thank you very much. And Professor O'Brien, I think managing and caring for patients or people with dementia must be tough.
Well, it is. No, it is tough. But because it's tough, it's been an area where there's been quite a lot of research in terms of carers of people with dementia. And there is very good evidence that a support package put in place, not a support package, a sort of educational package put in place fairly early after diagnosis improves outcomes not only for people with dementia, but for carers as well, in terms of lowering levels of anxiety and depression in the carers and lowering levels of agitation in people with dementia. So there's good evidence that early support in a manualized form can actually help.
Thank you. Thank you very much. I know we only have just over 2 minutes left, but I see a very interesting question here, and I would like to test our panel speakers and discussants. And that is, in fact, if you were asked to describe the ideal state of chronic disease management in 2050, 25 years from now, using 3 keywords, what 3 keywords would you use? I accept one if you
I missed the vital word.
The ideal state of global chronic disease management in 2050. Describe it in 3 keywords. I'm sorry, testing you here. Perhaps, yeah, Professor O'Brien.
The ideal stage would be there is none, because we've solved the problem.
Okay, right. Fair enough. Professor Arai?
It's a very difficult question. So maybe I need to answer to your question by providing 3 keywords in my expertise. So muscle health, frailty, and living well.
Good. You have given me more than 3 words. Professor Kim?
I would say person-centered, individualized, and proactive care.
Wonderful. Thank you. Professor Wu?
3 keywords, I think, for my specialties, MDT, and innovation,
team,
and the last one, to long-term survival.
Thank you. Toughest for you now, Jacqueline. You have run out of words.
I want to steal one. I also thought of patient-centered care that provides high value, and also focuses on health span, not just lifespan.
Wonderful. Okay. I think with this, I really must thank all of our 5 discussions, for wonderful discussion that we've just had, and also once again to thank our 4 speakers for the wonderful lectures that we've just had as well. And I think I'm doing quite well. We have 35 seconds left. And with this, I thank you all very much for attending this afternoon's first session. Thank you.
Wonderful. Thank you for such an insightful discussion. Would you please step forward to pose for a group photo all together? Thank you. Please step forward. And please step a little bit closer towards each other, please. Thank you. Would you please face our official photographer in the front? Thank you to all our distinguished panelists and speakers for your exceptional contributions. Ready? 3, 2, 1. Would you please remain on stage? May I also invite Professor Wenwei Tu to the stage to join the photo taking. Professor Tu, please. Thank you. So your profound insights, rigorous analysis, and thought-provoking exchanges have made this session incredibly rich and rewarding. Thank you so much, all our guests. Thank you. Please return to your seats. Thank you so much. Ladies and gentlemen, this concludes our first thematic session. We will now have a 15-minute coffee break. Please return to the venue at 4 p.m. sharp. Please feel free to proceed to the foyer to enjoy some coffee and refreshments. Our second thematic session on AI and innovation in higher education will start at 4 p.m. See you later in 15 minutes. Thank you.
唔到遲都未，確實咁。辛苦你啦，同學，希望盡快有 update 啦，同學。咁先可以 mark 實個檔期，同學。請隨時話我知，同學。希望一切順利，咁太好。21號11點半冇問題，同學。到時時間關係，我哋嗌麥當勞包啦。夜晚我可以見工人轉多少少餸俾你拎去拎走就好，咁你就唔驚冇再落啦。Welcome back, everyone. We will now begin our speaker. Innovation in higher education. This entire session is co-chaired by two distinguished academic leaders, Professor Hong Gong, Vice President and Co-Vice Chancellor, Development of the University of Hong Kong, and Professor Yi Ke-po, Provost of the Hong Kong University of Science and Technology and Director of the Hong Kong Generative AI Research and Development Center. Please join in welcoming Professor Hong Gong to the stage first.
Ladies and gentlemen, the second thematic section is about to begin. Would you please return to your seats and please switch your mobile phones to silent mode. Thank you. Once again, a warm reminder for all our guests. Our second thematic session titled AI and Innovation in Higher Education will begin shortly. Would you please return to your seats now? Thank you so much. Welcome back, everyone. We'll now start our second thematic session titled AI and Innovation in Higher Education. This entire session is co-chaired by two distinguished academic leaders, Professor Peng Gong, Vice President and Pro-Vice Chancellor, Academic Development of the University of Hong Kong, and Professor Yike Guo, Provost of the Hong Kong University of Science and Technology and Director of the Hong Kong Generative AI Research and Development Center. Please join me in welcoming Professor Peng Gong to the stage.
Good afternoon, distinguished guests. I'm honored to serve as a session chair for this session. As we all know, that the current development of AI has, since November 2022, has caused a dramatic revolution and earthquake to many professions and to our daily life. So every university everyone in the society actually are thinking of how to harness the opportunity and how to best advance AI, and in universities that people are thinking about how to make AI to revolutionize higher education. This actually extends to a lot farther, to kindergarten, to schools. So today we formed this session. We're really very excited to have three very distinguished thinkers on AI and higher education to share their thoughts about our next move. And may I invite Professor Tianyan Liu from Zhongguancun Academy, and the chairman, he is the chairman of Zhongguancun Institute of Artificial Intelligence. Please. His topic is redefining talent development in the age of AI. Professor Liu, please.
Yeah, thank you very much, Professor Gong. It's my great pleasure to be here in Hong Kong and talk about AI and higher education. I'm Tian Liu from Zhongguancun Academy. And Zhongguancun Academy is a new research institute, research and education institute we built from scratch in 2024 with the mission of redefining the talent development in the age of AI. And before that, I worked for Microsoft Research Asia, spent about 2 decades there, leading her AI research. And today, I'm talking about how to redefine the talent development in the age of AI. You can see in the title of my talk, I chose the word redefining deliberately, not updating, not improving, because I believe the changes that AI is bringing into the world is not incremental. It's disruptive. It basically touches the very foundation of every aspect of AI and education, like how we identify, cultivate, and evaluate human potentials. So I think without any doubt, AI is really entering the domains used to belong to very top human talents. As you can see from this slide, so for example, for this GPQA Diamond, which is a PhD level benchmark, the human specialists, like human PhD students, they can achieve a score of just 65%, But frontier AI models can achieve a much, much higher score, like a Gemini 3.1 Pro can achieve a score as high as 94 or 95%. And in the 2025 International Mathematical Olympiad, frontier models, many frontier models actually, the OpenAI GPT, Google Gemini, and also the DeepSeek models all achieve golden medal level results. And you know, that's not easy for just common people. And not just for those benchmark evaluations, AI today can also achieve something that usually cost our human experts tens of hours. Today, AI agents can autonomously complete coding tasks that take human experts 14 and today maybe even longer time. All those things just tell us that AI today is not just, you know, getting smarter. They can complete very complex tasks. And it is not just about the capability of AI. It is also about the pace, the speed of AI development. For example, in February this year only, we have seen more than 10 frontier models being released in very rapid succession. And also the cost of using AI is dropping significantly. Previously, AI is something expensive, which is only accessible to large enterprises. But today, any student, even middle school students with a laptop, they can access AI capabilities in their day-to-day life, study, and work. So in another word, AI today is not just advancing, it is democratizing. But you know, AI is moving very fast. But if you look at our educational system, it is still slow. It is in our traditional pace. And it is not functioning well to cultivate those talents needed for this AI era. Then the question is, what kind of people are really the demanded talents in the AI era? Now, let me give you some examples. Like Demis Hassabis, everyone knows about him. He is the co-founder of DeepMind and invented AlphaGo, AlphaFold, and other foundational AI innovations. Demis Hassabis is a kind of a foundational researcher who cross many different disciplines, lead large team to achieve something which other people are leveraging to change the world. We also see some other people, typically, in this AI time, like the Cursor team, just 4 people forming a startup and quickly get the market evaluation over around $30 billion US. They know the real needs from the Generation Z and even Generation Alpha, because they are just from that generation. All those people are just in their 20s, with an average age of 23. They have already built very successful companies with valuations of over $30 billion. We're also seeing, people like Peter Steinberger, who invented OpenClaw. I guess many people in this room have used the OpenClaw in your day-to-day work and life. And Peter Steinberger just grabbed some real needs of his own. Like there are many AI tools, but still, he does not really have a personalized AI assistant. Can manage his own computer, handle personal life and work. And he used AI to build such an AI assistant without writing many codes by himself. And this OpenClaw is one of the most successful open source projects ever in the history of software. So if you look at these examples, these so-called AI talents, what's in common? I think none of them follow the traditional academic playbook. They are boundary crossers. They are risk takers. They just build something using AI, for AI, and change the whole AI landscape. But we understand those are the people demanded by the AI community, by this AI era. But unfortunately, our own education systems haven't provided a solid foundation for us to cultivate such AI talents. Let me tell you why. So if you look at our current education system, in many of our courses and training programs, we emphasize memory, pattern matching, precision, and consistency. All those things are designed to solve those standardized tests or competitions. However, all those capabilities are exactly where AI can outperform our human very easily. But on the other hand, what has unique values in the AI era is curiosity, taste, critical thinking, courage to prototype and iterate. But if you look at our own, traditional education system, we haven't emphasized those aspects sufficiently. Give those students training programs or environments to grow their curiosity and critical thinking. Those new capabilities, they are used to handle uncertain problems, challenges. So in other words, traditional education system emphasize the training of the so-called I-shaped talents, but in the AI era, we are looking for the T-shaped minds, which can cross many different things and find a solution to real and uncertain problems. And if we compare these two columns, the traditional education system basically will grow those people who can easily handle or solve predefined problem of yesterday. But in the AI era, we are looking for new talents who can define open problems of tomorrow. So I think that's the big gap. So with that in mind, if you look at what's missing in today's traditional education system, we can see at least three aspects. The first one is a curriculum. In a standard university, we usually update the curriculum every 3 to 5 years. But on the other hand, we all know AI is progressing much faster than that. In every 3 months or half a year, there will be a big change in AI. If you remember, early last year, people in the world are still talking about large language model pre-training. But in the middle last year, like summer, the focus has been moved to the post-training era. And then later on, the whole world is talking about agents. So even within this AI field, the technology progresses and the focus shifts have been happening very, very fast. Now, how can we reflect that faster progress using a curriculum which is updated every 3 or 5 years? That's a big challenge. And second is about the evaluation. When we train our students, usually we will depends on the peer review system. Let them write a paper, submit it to the research community, let others to evaluate, and close the loop. But in this AI world, sometimes paper does not really make a lot of sense. Let me tell you one interesting research project in my Zhongguan Academy, which is called AutoSOTA. A group of students and professors, they built a research agent for any paper published in top AI conferences. After a week, this research agent will re-implement that paper and do some self-improvement, will beat the algorithm published in that paper by 10%. And then the source code generated by that research agent will be automatically open sourced. That AutoSOTA project just want to let all the researchers in the world know writing a paper, achieving a SOTA performance means nothing. AI today can beat your SOTA within a week and get all the source code opened, and other people will get that capability. So in this new situation, publishing a paper may or may not reflect the value of a research. We need to pay more attention to the real world problems. Those may not be really written as a paper, but can make a huge progress in the industry will generate a lot of values and productivity. That will make more sense. The third one is the structure. I think in the traditional universities, the department walls are still very high. Students are trained within a relatively narrow discipline. We say and advocate cross-disciplinary research for a long time, but the reality is most students are still trained within a very narrow discipline. But if we look at people like Demis Hassabis and others, they really have this T-shaped minds. They know a lot of things, although they really have a special expertise in some particular domain, but they know the language of cross-disciplinary setup. So those people can collaborate across boundary. So with all these limitations in mind, we need a fundamentally different education system that can tackle those challenges and bring our talent cultivation to the new level. Let me give you some real examples showing the limitation of traditional education system. If you look at the recent big breakthroughs in the AI field, like ChatGPT, like AlphaFold, it's unfortunate that none of them were created by people in academia. They were created by the industry. Like, OpenAI created ChatGPT and DeepMind created AlphaFold. It is somehow understandable because people in academia, just you and me, we care too much about the publications and the citations. We usually say H index and other criteria to show I'm powerful, I'm famous. But those people in the industry, they care more about the practical usefulness and the real-world impact. It is not just about those the academia versus industry. If you look at ChatGPT or AlphaFold, they were basically invented by startup companies. OpenAI and DeepMind, both of them are startup companies. So most companies, they're brave enough, bold enough to build new things, new direction, new paradigm without fear, so that they can do many 0 to 1 builder-like things. But when we emphasize publication, when we give our training to our students, somehow we give them the implication that doing incremental optimization is a shortcut, because in that way, they can easily get many papers published. And if they are trained in that way, the best case is that they will become very good executors, but it will be very difficult for them to really invent something from 0 to 1 to become those really breakthrough innovators. So all these things really ask for some big changes in the education. And then, although no one knows, what is the perfect education system, but in the past 1.5 years at the Zhongguancun Academy, we are doing some bold and somehow aggressive experiments. We have 3 missions in our academy. One is cultivating next generation AI leaders. The second one is doing disruptive AI research. And the third one is empowering AI revolution of the industry. So Zhongguancun Academy is something quite special. It is not just a university, not just a lab, and not just an incubator. It is something like all-in-one. So it is an integrated platform that connects talent development, frontier research, and industrial transformation. So the first question we ask ourselves is, what kind of students should we select to further train to be the next generation AI leaders? Different from traditional universities where paper test, coding test, or interviews are the major approaches, we are looking for new signals. We emphasize open source contributions, entrepreneurial experiences, interdisciplinary skills, and also problem identification skills. So in a formal admission camp, every student needs to go through 2 very interesting and special activities. One is what we call open challenge, and the other one is called a hackathon. In a 12-hour open challenge, the students are given 4 very difficult industry-level problems to solve. For example, they are asked to design a new algorithm which will output a molecule, the drug molecule, which can bind to a specific target protein and will not bind to some another set of proteins. So those are real problems. And to solve that, the students need to understand the whole drug design pipeline, need to understand how a protein is represented, and how a protein will fall into its 3D structure, and how interatomic binding means, and how to calculate and optimize that. Many students don't have any knowledge about that. But the good news is that they are given a laptop, which is connected to the internet, and also linked to a GPU cluster. So the students can learn all the knowledge and find open source code, use AI models to help them, and run some codes, and program on these GPU clusters. But they need to finish all of this, the learning, the practicing, the iteration within 12 hours. And the AI hackathon is another thing. So they need to finish a startup process within 12 hours. From forming a team, to find an idea, to using AI to prototype, to write the business proposal, to do this pitch presentation, and everything within 12 hours. So all these tests just want to see how the students respond when the problem is unfamiliar, when the clock is ticking, and when failure is an option. We will identify those students who have the skills and capabilities to handle uncertainty. Instead of saying they know everything, they can get a 100 score for a predefined question. And after finding the right students, the next question is how to design the training curriculum to ensure that those students can grow as we expected. We believe the very timely knowledge update is essential for AI students. So we ask our professors to ensure one thing happen. After 3 to 6 months of any major AI breakthrough, the corresponding knowledge will be, absorbed into our curriculum by means of the so-called mini courses. Also, we believe students must learn from doing things rather than just reading papers, reading books. So we adopt project-based training. We provide hundreds of different projects to the students, most of them with strong industry background. We also allow students to propose projects by their own, even without any professor in their team, as long as the proposed topic is really interesting and they can pass the evaluation of our committee. And the third one is that, different from some universities where the use of AI tools is forbidden for doing homework and examination, in Zhongguancun Academy, we encourage our students to use AI in every possibility to realize their potential, amplify their value. Because we believe in the future, after their graduation, when they go to the real world, no one will disallow them to use AI. And the capability of leveraging AI is essential for them to get a good performance and potential in this new world. We also emphasize the empowerment of industry a lot. So we build a supporting system, which include AI, the incubator, AI, funding system, and also the AI business school to empower our students to get familiar, transfer their technology to the real world, and really doing some startup activities. We regularly assess the commercial value of every research project. If they are close to the market, we will push that further, provide them with some market-oriented support at the proof of concept stage. Furthermore, we made a bold decision that, for the criterion for them to graduate, running a startup with reasonable funding and revenue can also be counted as one achievement, similar to publish a very top-tier conference paper or journal paper. So with all these new things, those new experiments, although Zhongguancun Academy has only 1.5-year history, we have achieved something really interesting. First of all, although we do not emphasize papers at all, those students still published a lot. Within the past year, they published over 150 papers, mostly at very top conferences and journals, including 7 in Nature and Science. They also won a lot of best paper awards and international competitions. And some of the research are really interesting. For example, they have made the world's largest DFT, density functional theory computational tool, which now can compute the energy and forces for a molecular system, the irregular molecular system with 100K atoms. That is impossible before this tool was invented. Traditional DFT tools can only compute systems with around 1,000 atoms. They have several other research results like that. There's one thing in common in all those research projects, is that the goal is not to publish a paper, but really to make this tool useful for real-world application. For example, the reason why they spend a lot of time enlarging the scalability of their DFT tool is because only with that scalability, we can really do some quantum chemistry calculation for real-world proteins. Otherwise, they can only do some small molecules, which has nothing to do with life science. The other thing is that our students do not only build papers, they also build companies. Within last year, there are around 10 startup companies incubated by Zhongguancun Academy, with 3 of them are quite outstanding. Collectively, they raised an investment of over 300 million RMBs, and with a post-investment valuation of around 2 billion RMBs. I think that's a lot for students because, those companies are just running by people in their 20s and within a year. There are also some very good product IP and tech transfer happening, like this Z212. It is a drug designed for tumor treatment, and it has very good performance in the PCC stage, much better than the very famous medicine you may know, the Keytruda for tumor treatment, much better than that one within this PCC period. Some big pharmaceutical companies have already been approaching us to buy that IP. So what's even more encouraging is that behind all those achievements, we actually see the growth of our students. When they came into our academy, they are just, a little bit better than traditional average students. But after this 1.5 years, they become more, brave. They have a lot of imagination, creativity, and they have this courage to tackle real problems. And they also demonstrate a strong leadership. They can, work with a group of people to achieve something that can never be done by them, any of them alone. So our experiments is still short. Zhongguancun Academy is a baby with just 1.5 years old. But we have already seen some very interesting things happening. We are learning, we are iterating, we are moving very fast. One thing we have seen is that the pace of AI has rewritten the rule, and the best way to prepare for an unpredictable future is not to really predict it, but to nurture people, our students, the young talents who can adapt, create, and lead through whatever comes next. And I think this is why we build the Zhongguancun Academy. And we welcome every one of you to visit us in Beijing and to explore collaboration opportunities, because we believe the future of AI in education is not something that can be done by any single institution of its own, but something we need to and should do it together. Thank you very much.
Thank you very much, Professor Liu. What a wonderful speech. Please be seated. Next, let us welcome Professor Dragan Gasavic Distinguished Professor of Learning Analytics and Director of the Center for Learning Analytics at Monash University. He'll speak on From Hype to Evidence, Advancing Human Learning in the Age of Generative AI. Professor Kasavik.
Thanks so much, Professor Gong. It's my honor to be here and to speak about some of the recent thinking about the implications of generative AI on human learning. So previous speaker did an outstanding job in terms of the ways how we can reimagine our institutions and the ways how we can also graduate next generations of graduate students that are doing the work that is at the forefront of the impact. But I want to also go back to the journey of the people who don't necessarily have that kind of level of capacity and at the same time also at different developmental ages. And think through the ways how we can also think the ways where some of the promises of AI are, at the same time, what are the implications of AI on human learning. I would actually say that one of the major aspirations when we are thinking about human capabilities and human learning is to develop human skills while benefiting from the power of AI. And this has multiple implications. One implication is obviously that we want to boost human capacities along the way. But the other one is also that we want to have humans and AI working together to solve very difficult and hard problems. I want to be looking today in this problem from the existing evidence. This is what is the aspiration and what we want to see as a desirable goal, but at the same time, I also want us to dive in to see where the current evidence is and what are the things that we need to be working on to potentially maximize some of these opportunities. I want to give you also two quick takeaways as well, because sometimes we academics like to ramble on, and I may lose the focus. So I want to basically say two important things. The first one is that we can see lots of really promising things that we can bring in AI to help our learners to learn more effectively in certain situations. But the situation is also not as clear, and there are certain limitations that we need to pay attention to. But the other important thing is also, what are those future-ready skills? How we need to reimagine them. And at the same time, also, what is the assessment of these skills? How we are assessing that and where we are going is really a big, important other issue that we need to think from today's talk. We're going to first talk about the use of AI to change some of our existing practices for learning and teaching. And one of the major promises, and I've seen many institutions around the world as well, are trying to create a chatbot for course A, course B, course D. One of the institutions here I know as well in Hong Kong empowered all their educators. They want to have, I don't know how many hundreds of chatbots for every single thing. First out of the gate was the Khan Academy. They announced immediately their Kamigo, and they were building it with GPT-3 before even the ChatGPT was a thing. And then there are many different interesting projects. I find really this one that is developed at PolyU quite interesting, the Socratic Playground for Learning. That is one of the interesting things that builds on lots of that existing research. But then, what is the evidence? Are these chatbots really useful for human learning? What is happening there? So there was a study done at Harvard in physics, and they found large effect sizes in students' learning gains. And it was quite effective. The issue, though, is that they were not using just the chatbot off the shelf. They pre-fed all the possible answers into that one. So in other words, what I would call in our old-fashioned AI way, they were knowledge engineering everything manually to do the chatbot. So in that case, you cannot scale up this type of an approach very easily because it requires significant amount of the manual work if you want to have this similar effect across the board. Kamigo, Khan Academy, the champion and poster child of the chatbots to be used, they just published the study in PNAS. And what they found is almost null effect on students' learning gains. They were significant. Well, of course, they would be significant because they had 200,000 participants, but the effects were smaller than 0.05. And obviously, the students were also not using them so much as well. They were using them on average about 5 to 10 minutes. Because students don't know what they don't know. And if they don't have the abilities how to use some of these chatbots effectively, they may not use them at all. So then you may ask, well, this is maybe not necessarily the only thing. And I would say yes. One of the major things that large language models are really good at is to provide certain information on a given prompt. You can also ask them to be providing the tutoring of the students. But what they don't know is where the student is. What is the level of the student's knowledge? What is the level of the velocity? What is the speed of their learning? What are those different types of attributes? That's what we call in the literature in AI and education learner models. And these learner models are really substantial. Without them, intelligent tutoring systems cannot adapt to the individual student's needs. There was a study last year as well published, which demonstrated that LLMs alone cannot adapt as well to the student needs as the conventional intelligent tutoring systems that have these learner models. In other words, they are capable to track what students know and what students don't. Obviously, there are other things where we can see potentially beyond just the tutoring, where we can actually instrument and build the technologies that are tracking what students know, how students are engaging into certain cognitive and metacognitive processes, social processes, affective. We can, based on the student's interaction with the system, clicks, mouse movements, obviously chat logs, make these inferences. And based on that, we can also provide simple nudges in the right moments in time, what students are doing and what they are not doing. We can say, hey, you are working on this particular lesson, but you didn't even check what are the expectations, what you need to do in this lesson. It's very commonsensical for most of the learners, especially the people in this room. But for an average learner, that's not necessarily the thing that they are doing always. So what we found is that in this way, we ran a randomized trial in 6 countries last year. We found that we can get much better learning strategies when we are using these type of approaches. And this is particularly significant when I start talking about students and AI teaming and the ways how students are interacting, because the improvements in the learning strategies are actually trying to encourage students to think more about their own thinking, about their own learning. In other words, what we use in a fancy way in the literature to be more metacognitive in many ways. So what we are also seeing much more promise is this type of hybrid approach, where the educators and the AI are together trying to orchestrate the way how we are creating the students' opportunities. This really has a direct implication for our curriculum, for our professional development, for educators in higher education, so that these type of systems still have a fairly strong human control, while at the same time the students are benefiting from the AI support. That requires the clever designs of our courses in such a way that in the right points and the right places, we introduce some of these AI tools, while at the same time, we also then bring that back to the classroom and discuss the issues and the challenges. Another thing, and I'm going to be talking in the second part of my talk a bit more about that, give an example from the medical education, where I see the great amount of the opportunities is to use the multi-agent systems for creating simulation-based learning opportunities. You can think of these type of exercises in medical education, language learning, legal practice, any other opportunities where students need to interact with others, or where you want to create the opportunities for students to have something which is more an authentic environment in which certain activities need to happen, so that they can practice their skills before they also go out in the wild. And I'll also make an argument later, these type of opportunities and the environments are creating for us new setting in which we can also assess the students, not only on what they produced, but also how they produced and how they interact with others when they were producing something. While obviously, generative AI technologies can produce some potential implications for our existing practices. To me, these new challenges are something that we need to be grappling far more and thinking about what happens now with the human skills and the human capabilities. And that big question is really that we need to reimagine skills and knowledge people need to have. So how we approach with that type of a problem? Well, some people are talking about hybrid intelligence. And hybrid intelligence can be defined in many different ways. But one of the fairly operational way is that we can define it as a synergy. And the synergy is that the human plus AI, through that interaction, can be more effective than human alone or AI alone. So in other words, the human AI team beats human alone or beats AI alone. Literature is also very clear. It's really difficult to achieve. There was this meta-analysis in Nature Human Behavior published 2024 that shows in less than 25% of the cases we can do this level of synergy. The next level is also, or the level below, is augmentation, where the human plus AI can beat human alone. In other words, that a human can be more productive, that human can achieve more, or can do certain things faster. So that's typically called augmentation. When the AI alone is better than human and AI, that really leads into automation and begs the question whether the human skills are essential in that space. So when we are defining then the synergy, then it's very obvious thing that we need to then teach people to use AI. And there's lots of investment into the AI literacy. How we are prompting AI, how we are also asking students to understand what is the beneath of it, what are the moral and ethical implications of the use of AI, and many other things. And I would say that's really necessary, and that effort is really beneficial. But I would also say it's not sufficient. Because the issue when people are using AI and interacting with AI, they can perform better in certain types of tasks. But the performance doesn't mean that they are learning. They are potentially just inflating what they are actually able to produce with this type of technology. And so then the question is, what type of that signal that a better performance for the student is offering to the average student in certain situations? Does that signal perhaps motivate students, or it's actually give them the signal, well, you don't have to put more effort into this because you already nailed it. It was really easy peasy for you to do it. So to me, the major challenge here is that the generative AI and the AI technologies are, in the educational terms, decoupling learning from performance. Conventionally, when we were basically expecting students to perform, they had to have certain level of knowledge. They had to have a level of ability that they can perform particular types of skills. But today, they can, in principle, perform without necessarily having certain types of abilities. So I would actually, when we are tracking these type of dimensions, one dimension is this performance dimension. And typically can be also achieved through the use of different types of AI supports or different types of AI assistants. Even ChatGPT is primarily designed to emphasize the task performance. People need to have the skills to use it, and the AI need to be a good fit for the task. But the issue when we are going across this dimension is that when people have low-level skills and also don't use AI much, they are floundering, they are really kind of in this limbo, they need some support so that they can progress. If they don't have much ability, but they can still perform certain types of tasks with AI, they're kind of able to offload some of these things to the autopilot. And they get this impression of the autopilot performance. But that autopilot performance is potentially the zone of really big danger that is related to the education. I'm going to be talking about certain pitfalls as well that are coming from this autopilot performance zone. The other dimension is the good old learning. We basically need to provide good teaching practices, in the literature on educational psychology, we are using a range of different types of scaffolds. These scaffolds can also be implemented through AI, like all these different types of chatbots as well. And they're really aiming to promote effortful learning. Learning is difficult. Literature on psychology of learning is emphasizing one potent type of learning strategies that are called desirable difficulties. They're, for a reason, desirable because they are also promoting much more effective longer-term learning gains. So what we want to achieve is really this masterful synergy that is coming from the human and AI capabilities. But you can see from this model, how I conceptualize it also, is that this synergy sits on the assumption only to happen when humans have high level of capabilities. I can really effectively use AI in many different types of tasks. I often feel that I have this kind of assistant that can speed me up. But I have more than 20 years of experience in what I'm doing. What happens with somebody who has no day of experience or knowledge of a particular type of a thing? How they can know what they are doing and what is happening there. So in other words, this really gets us to the point that human skills are essential to achieve the synergy between humans and AI. So then what is then the biggest skill that we need to be promoting? Ability to know when and how to onload and offload to AI. In other words, know when is the good time that I can actually offload something to the AI. AI is good for this particular thing. I can potentially, in certain situations, trust the AI's judgment. But in other situations, I don't trust the judgment, but I know it can also perform relatively laborious type of task for me. I have a bunch of notes, I have all my good ideas, but can put it in an initial first draft that I generated this bunch of notes. That generally what we are calling is knowing when and how to use certain things. Abilities to learn, abilities to think is the metacognition that is really essential as we are going forward. But there are, in this space, 4 major pitfalls that we identified that are all coming from this autopilot performance. Number 1 pitfall is coming due to the fluency. Fluency means, hey, ChatGPT generates really nicely looking text. Looks very nice. That high readability of text is already documented more than 20 years ago to be associated with the reduced metacognitive engagement of the people. We had a study in which we found, and we labeled this phenomena metacognitive laziness, that students increased the performance, they did not increase or didn't have any learning gains, but we were also having the whole sensor instrumentation, how we were measuring metacognition. They were engaging far less into the metacognitive processes of planning, of the evaluating what they were doing, and also thinking about their learning strategies. So then, what we need to do in this case, how we are battling this beautiful design thing that is nicely readable, is the need to have the designs that are producing what we call the productive friction. Specifically, what we are talking here is about desirable frictions. That's where we are learning the most. So in other words, we need to have the designs that are challenging the students to ask the questions when the generative AI is offering certain things. That is trying to have these micro prompts for them. When they are also prompting AI, and AI is then giving them certain types of judgments, they need to be also pushed to judge themselves, to speak back into certain types of situations. These desirable frictions are really essential part of both our learning design, but also the design of the AI technologies so that we can mitigate the problem of the metacognitive laziness. We studied this phenomena across the board in many different writing projects as well. Learners mostly do not change almost anything that AI is offering. We call this phenomena, it's also documented several other related things, pitfall of coherence. The issue of the pitfall of coherence is the fact that AI not only is generating some content for you, but it's also offering you the full level of analysis and give you even the steps to choose what to do next. So in other words, becomes really this very helpful subservient that is over offering certain things to you. That whole experience looks very coherent for the learner, but also is reducing the space of the options that the learners are potentially considering when they are doing certain types of things. So what we need to do is in design of our tools and potentially the also technologies that we are creating, but also design of the courses that we are building is to have much more balanced aid. The aid for the students that is not over-prescribing and over-analyzing everything in a similar way that over-scaffolding the students can also create them over-dependent on the teachers. We also need to have just the right amount of the information for the students to potentially complete a certain types of task, but without creating this coherence and reducing the potential choice space that they may decide to have. The third pitfall that we documented so far in the literature is we call it the pitfall of pandering, which is really, if you put it, slightly scary. It goes beyond the education. It talks about certain things that AI can offer. There was a recent study that basically demonstrated that when students were interacting with AI, that was intentionally also biased in a particular direction. You can take it in terms of the health, politics, or whatever. People were shifting their attitudes and aligning with AI's attitude without being aware that they shifted their attitudes. When that same information was presented on the paper to the people, they were not shifting these attitudes. And also warning the people that this may happen when they were doing certain things with the AI did not change the outcome. In other words, they were still biased towards whatever AI was also taking as their attitudes. So what we need to do, as what we are proposing, is we need to think about how we can have this engineered dissent. In other words, we can also create the agents that are contrarians in certain types of situations. We just had a study in which we analyzed these agent personas, contrarian versus supportive. Contrarians were actually really creating much more metacognitive arousal, if you wish, for the students when they were engaging in certain types of situations, while at the same time also making students to feel less psychologically safe. So it's a powerful weapon, but we need to also use it carefully. And the final pitfall that I'm going to mention today is this pitfall of transparency, that AI is kind of posited to be really important to have explainability and all these type of things. The issue with the explainability is that it can be also very nicely done and hiding all the uncertainty that is behind the AI. So what we need to do there is we need to create for students the opportunities that they have this contextual verification, to think about what that uncertainty AI hidden in the nicely looking explanation so that we actually prevent the students to offload their metacognition and judgment. Before I wrap up today, I'm going to just touch briefly on the assessment, but that's a really big theme on its own. So, one important thing is knowing what I just said and the decoupling between human learning and performance is then to have the illusion of human skills if we continue just assessing the products. In other words, I just create these essays and I keep assessing essays. Is that a good proxy of what we want to assess? Because we may end up just assessing automation instead of assessing synergy. So if we want to assess synergy, we need to have the assessment of human alone skills and also how students are performing together with AI. That's one important thing. The other important thing is also that we must not conflate learning and performance. There were several meta-analyses done on this topic that completely conflated performance with learning, showing that students' performance increased for almost 1 standard deviation. My question is, who cares in terms of learning? That's fine maybe for organizations and companies, but we care about learning gains. When we replicated that meta-analysis, where we decouple learning from performance, these learning gains became small effect sizes. So we need to have the right measures of what we are assessing. The other important thing that I want to emphasize is that while the product assessment and performance is good and important to have these synergistic approaches, we need to use also the process data. In other words, all the students' interactions with AI and other tools that they are using, they are signals, very potent signals, as well as all the different types of judgments that we want to ask our students and assess them on. When we build the models, computational models for assessment, what we are getting with this type of data and these three types of signals, we're getting far more reliable models that are also preserving all the validities of the construct that we are trying to assess. So I'm just give you an example in the environment in which we did it. So this is the platform Flora. We did this as a collaboration with Peking University and Peking Union Medical College. We had a randomized controlled trial with them for almost one full semester. And what we basically were asking students to practice their clinical reasoning skills and history taking, and they were basically working with the virtual standard patients. But they could also get the different types of other agents. They basically could ask a more experienced colleague for advice, and that was primarily aiming to promote their learning, to scaffold them, to promote their reflection, to actually tell them, slow down, think about that. Did you consider all these things? Did you consider every other thing? And then at the same time, we allow them to use just the naked ChatGPT, just embedded into our platform so that they can actually also use it as a helper to help them solve the problems. So we then randomized students. Some of them, they had just the scaffold at the beginning. Others had only AI all the time. Some of them got, after some time, the use of AI in the scaffold at a time, and so on. What we found is that the learners who were having initially only scaffold, doing things by themselves, far outperformed the learners who were only using AI from the start. Especially this was really interesting when these students were then using only the task as well with the AI alone. They already had the skills how to do it themselves. And even more interestingly, they have far more superior skills when they were asked to diagnose the patients without AI, any support one is that removed. So those are really important lessons for us as well in terms of the timing when we are trying to introduce some of the use of AI. All right, few final remarks because I think I'm over time and everybody's keen to see me going. So I think we need to really have much more nuance in this discussion about the implications of AI and human learning. We need to broaden our understanding of learning with, about, but also despite generative AI, because it's potentially preventing it as well. And we need to be clever how we are actually doing these type of things. We must not confuse co-pilots with autopilots. We are creating co-pilots for the learners or professionals, but they think it's an autopilot that's going to do all the work for me. I need to know when and how I can offload that to the co-pilot. And the final thing is also that we need to really have the assessment that center human learning and productive interaction with AI. In other words, what we want to assess the human abilities and also abilities of the humans to have a productive synergy with AI, ideally by using process data, not just the performance, what we are doing traditionally. And on that very note, thanks so much for the attention and look forward for the further conversations.
Thank you so much, Professor Dragan Gasavic. So the two talks, I'm so excited. The first one is very large framework on AI and society and learning and training. And the second talk is more focused on learning and, the new pedagogies and, toward human performance and the harnessing of the AI capabilities. So great talks, the first two. And now let's invite Professor Shing-Tung from he's the founder and chief scientist of the HKU Shanghai Cross Innovation Lab, and Professor at the School of Computing and Data Sciences. Professor Zhang.
Thank you. Good afternoon. It's my pleasure to be speaking in this forum. Let me begin with this familiar images. I think Tian has already went through the list, but it worthwhile just revisiting, right? So when ChatGPT could hardly do any arithmetics correctly, it already got like 100 million users in 2 months. And barely a year and a half ago, we're witnessing another performance jump, which is a reasoning model, which is a GPT-01. And in Spring Festival last year, DeepSeek came out with a 10x price cost performance improvement that redefines the economic of the large language model. And during the whole year, last year, it's mostly about vibe coding, meaning that you just code without actually writing any code. I probably knows about the open cloud movement these days, and the rumors that they have their own church, their own religion, and so on and so forth, right? Now we are really witnessing AI, building AI. So it's not becoming, it's just here already. So the key thing that I think many people in this room will share, is that this time feels different, right? All previous revolution has two phases: 0 to 1, which is invention, and then 1 to 100 is deployment. It takes years, but this time feels like 0 to 100, right? It's not because the ones are not there; it's just because they skipped over very, very fast, right? So the tsunami, of course, is very destructive. But on the other hand, I think there also brings us new opportunities. So I'm somewhat optimistic, but to be optimistic, I have to be somewhat critical about the existing time frame, the pipeline. Okay. So this pipeline, starting from K-12 and college and universities and the graduate programs, it seems permanent, right? But in the entire evolution history of humans, this occupies a very, very thin slice. It's about 80 plus something years old, right? So we start with kindergartens and then so on, more colleges, so on and so forth, right? So this pipeline is optimized for efficiency. It is highly, highly institutionalized, right? It has a large ecosystem around it. And now we have AI. What's going to happen? So AI is going to move the boundary a little bit, make it accessible. But the sad truth is for human learners, it cannot shortcut biology, right? So essentially, here's a fundamental tension, right? We have the exponential force meeting fundamentally a linear learning system, which is human, right? That's where all the tension is. Now, what does this pipeline do, right? This pipeline is geared towards growing specialists. So you are experts in a certain area, so are also good at some adjacent areas, and that's what we call a success. Now, this pipeline never intended to build genius like this, have multiple, genuine contributions across different domains. It was not built for that. So if we zoom out, I think this pipeline has two structural problems. The first problem is it has a very narrow gate, right? You have very good institutes like HKU and many, many good institutes here in Hong Kong and the mainland, but majority of the people will fail at that gate, right? And this system, as a pipeline, is designed to filter, not to lift. Now, the issue is, for people who cannot make it through, they do not have the critical thinking skills, they do not have the necessary knowledge repository. So without critical thinking and knowledge scaffolding, they are vulnerable to misinformations, which spreads 6 times faster than truth. And I think the statistic is that it's even faster, right? I used to think this is a problem of technology, that everybody has a microphone, everybody can speak, but really it is not. It is a problem of the education system and amplified by technology. So as a whole, I would say we have a failure here. So the second problem is for those of us who actually made it through, right? So as it turned out, each discipline would have its own shared common sense. The way that we look at the world, the kind of methodology we adopt, right? For example, scientists always think there is a ground truth somewhere. And to question this existing theory of truth is to get closer to the final truth. So that's our trait, right? Every scientist, whether it's a mathematician or physicist or chemist, we share the same worldview. And that's why scientists can sometimes appear to be a little stubborn, right? Even cynical, okay? That's just because how we think of the world. Now, we learned engineer together with science called STEM, right? But actually, engineers have a very different way of thinking of the world, right? We work under the constraints with the first principles. The cost of performance trade-offs is what we essentially are after. So we have a very different view of what a scientist's view is. So STEM actually needs to have 2 different kind of work views. Now, for business, they were talking about efficiency, return of investments, etc. All the liberal arts talk about expression freedom, right? The way to express things and communicate. Very rarely we have talents that can hold this different kind of worldviews simultaneously, let alone apply them. Now, that is not what the future leaders need, right? So Tian talk about leaders for the AI, etc., but I'm talking the future leader of the society. For that, you need really to have equip different kind of lens to look at the world, look at the problems, and know when to switch, right? This pipeline does not grow such talents. Now, I have been working in the computer science field for quite some time. I studied as a computer architecture, systems, operating system, data science, and later on machine learning. So I wear a few different lenses. But predominantly, my own lens is the one of architecture. So I come with my own bias. And the way that I look at higher education is like a building, right? So you think of the university as a huge building, so you have different floors, different rooms, etc. Every room, you can think of this as like an apartment room is a course where you have those functions that you do the content delivery, do the assessment, do the projects, and so on and so forth, right? Now, so if we think of innovations, we think of how do we innovate holistically. Think of it in terms of the unit of course. You have content delivery, you have assessment, projects, so on and so forth. Now, we can, repaint the wall, right? Hang some new curtains, but in the era of AI, what we really need is principled renovations. We need to knock out some windows to let the new lights in. And we have to deal with this in a principled way. And when I come to HKU, when I talk to many faculties, was very inspired because many of them are very keen on innovating. So this is like in this room, you try to throw out some old furniture and build some new ones, right? But many of the innovations today stop as an experiment. The grants run out and that's done, right? You write a paper, that's it. They do not become the asset that sticks and scales. Now, the building metaphor does not work unless you think of who travels inside it, right? So the students go through the courses, they leave footprints, They go from course to course, floor to floor, right? What's really happening here? If you take away all this, outside buildings and so on, what's happening in the university is the embodiment of knowledge, right? So the university task is to grow that knowledge, and with the students within this building to accumulate these knowledges. So you can think of them walking from one knowledge point to another. Maybe the size of the node is the time they spent on mastering certain knowledge. Maybe the colors represents them as how well they are doing that, right? Now, this is what's really happening in the system, but it's not really being taken by any professors, because any professor just taking care of one course. And students just lost. They may not remember what they have mastered already, right? So that was a thing that Professor Dragon earlier talking about. If you do not know where the student is, how do you even teach, right? So this trajectory, what I call the portfolio, should connect across courses, across years, across faculties, and it just grows along with the students. It lets students know where you are in terms of your knowledge boundary and the direction you can go to next. So this is beneath the GPA. The GPA is a very condensed index that tells you only how you do, relatively speaking, to the cohort and the courses, right? It is recall performance under pressure. But really what is happening is what you learn about these knowledges that really, really matters. This is not around these days. So how do we make this transformation happen? We have to think of some new ways. For instance, out-of-box thinking. So out-of-box thinking, you think traditionally, this is what's happening because the goodies is outside the box. But with AI, what is really happening is you're looking at the box in the wrong way, right? So you have this AI coming in, so it's shaking things up. So let me just use one example to explain how this can principally become a dimensional shifting force. For instance, how do we teach a course? Okay, is AI better or teacher better? So in the traditional classroom, you have teachers with 100 students and so on and so forth. There are things that the human teachers will not be replaceable. Okay? A good professors will not only know the names of the students, they walk the classroom, they look at students in the eyes, they read the vibes, they slow down or accelerate, right? And for many of us, we can always recall some of the great teachers that affect our trajectory, right? They become the role models beyond the content. This is never gonna be replaceable by AI. And for students, one of the incentives in the classroom is to be witnessed, right? You raise the hand, you may ask a very smart answer, you crack a joke. Those ambient presence is never gonna be replicable by AI. AI, on the other hand, has something that human teachers cannot match, right? It has infinity patience. It never judges you, no judgmental. It can adapt to your priors, given that your prior is known to the AI. It meets you where you are, not where the syllabus assumes you are. Can adapt to the personal taste, your life story, your preference of music, any of those, your previous performance at the different classes become informative to have the AI to leverage to teach you. This is never possible with human teachers. So you think that is all there is, but no, there's a secondary effect. So in the traditional classroom, we talk about one of the incentives is to be top student, is to raise hands, to be active, and so on and so forth. But the problem is, when you're being witnessed, the other people, the other students just shy away, right? We all have this experience. There's always a few, young lads raise hands, wants to impress some pretty girls in another corner of the classroom, and so on and so forth. And the rest of us just, we do not want to appear stupid, right? So they just stop asking questions. That happens in any classroom where there's a shared presence. That's just the constraint that physical classroom has. Now, if you think the AI has this advantage that being infinitely patient and no judgmental, well, wake up. In the real world, your future boss, your future peers are going to be biased. They're not going to have infinite patience, right? One of the issues to use AI to help you is once you step into the real world, you might find it's very, very hard to adjust. So my point is, just look at this small problem of how do we deliver content. The answer is not binary. It's not about who wins. The real answer is how do we combine them adaptively such that we can get the best of them, right? So AI transformation is not just to let AI to deliver the contents, or on the other extreme is that just have an AI tutor and a professor deliver it just the way that we do today. It's much more subtle and nuanced than that, and we need to do experiments to do that. So in HKU, I'm working on a project called ARC Junior. I like the name because the tsunami is coming, so we need an ARC to get out of the mess. And Junior means that it's an experiment, but also means it is for the students. I'm not going to talk about too much detail into that. I'm just going to run through the list. Now, for instance, for the content delivery, we talked about how do we combine the AI teaching and with human teaching, right? How do we free the human teachers from the mundane, repetitive teaching, but switch their role into a coaching, facilitators, project leading kind of roles? That requires both building the tools, but also requires the teacher to adapt to different roles. Now we should get rid of just dry PPTs. There's many, many new technology available that you can use dynamic HTML widgets and on-demand videos, and you can update your curriculum on the go, right? So how do we author the teaching material becomes the issue. I think assessment is extremely important. I think everybody talked about it. We heard of Tianyan talk about his assessment is getting your company, right? So that is pretty extreme, but I'm very excited about that too, right? So it's not an assessment only after class projects, problem sets also, but during the course of delivery, we can embed assessment. We could do more than just multiple choices. We could have Socratic kind of dialogues and challenge the AI back and forth. And finally, I think the most important thing is to have a memory street. That's what we call the student portfolio that connects the dots so that you can be personalized learning and also know where to go next. Now, this is only part of the problem. I think the issue here is dealing with how do we teach, how do we learn is only one aspect. The other aspect is about what to teach and what to learn. I think across different disciplines and faculties, there are different gains and losses. Some of the domains, like dentistry, I think it's a net gain. But some of the domains like computer science and data science, actually we will have a lot more to think about how to change and what to learn and what to teach. So there is a saying that the only constant is change, but I think there is more to that. I think some of those points echo the several previous speakers' point. The first skill, I think, is to ask the right questions, because the quality of the answer is a function of the quality of the questions. If you ask a stupid question, you're going to have stupid answers no matter what, right? And the answer asking the right question is hard, as Dragon was saying. You have many years of experience, therefore you actually can ask the right questions. Now, ask the right question, ask questions requires you to know that you do not know something, right? So this is very tricky to train. And knowing what to ask requires knowing what you do not know. So that's a tricky part. The second thing is to spot the problems and pushback with style. Right? So the errors does not come announce itself. I'm giving you a wrong answer. I'm not saying, by the way, I'm giving you a wrong answer. So you have to be really engaged to see that the answer coming from the other part, other side is wrong, right? And the other thing about that is disagreement is a skill. So a disagreement takes courage, and it's especially hard for Asian cultures. So in Silicon Valley, you might have heard there's glass ceiling for Chinese engineers. They reach maybe department managers, but they could not go to VP level and so on and so forth. I think there are many reasons for that. One of the reasons, culture-wise, is Asian people, they do not know how to disagree with style, right? They find it very hard to push back. And that is something that we also lack of. Finally, even when the answer is somewhat wrong, it's imperfect, you should get prepared to be inspired. Because it sends you to look at some direction you were missing, right? So getting the wrong answers that inspires you is more valuable than getting the right answer just without even thinking, right? So one of the tricks I teach my junior staffs to do is very simple. So whenever you ask questions, before you hit the return key, stop. Think what your answer would be. Think hard, right? 5 seconds, 10 seconds, think about it. This is where you can voluntarily introduce friction. So now, when the answer comes back, you have the very interesting situation, right? There are some, maybe the answer confirms what you're thinking, which is great, because you spend time thinking about that. And there are answers that's unexpected, right? You disagree. Now, some of them, you think that genuinely you are right. Then you should push back. And some answers you didn't thought about, but the AI inspires you. Now you learn something. You have to manually choose how to use AI in the right way. Introduce frictions when you need to. Now, those skills, if you watch any human-to-human intellectual conversation that is dynamic, is interesting, that's what's happening. They are challenging each other, they're asking right questions, they push back, they disagree, they get inspired. You can have two philosophers talking hours on end. If you watch, that's what they do. So these three fundamental skills is there, no matter you're working with a human or with AI. What I'm hoping for is our existing pipeline does not hone those skills very well. The traditional classroom kind of teaching discourages people to ask questions, discourage you to disagree, does not give you a chance to get inspired. And that's something that we could cure, I hope, with the AI transformation. Now, let me end with the 3 goals. These 3 goals, this slide is very old, actually, by the way. This is about at least a year and a half ago. I was giving talks elsewhere in China about my view of AI education. I think the first goal is not about stop people to use AI, but to redefine your API, right? So if the AI is making learning something easier or faster, if it indeed does so, right? We heard Dragons talk about how do you actually learn. So that's a different story. But if it can help you to learn faster, to make it wider, yeah? Make your knowledge, make it faster and so on and so forth. Just increase your KPI by fractions. So we want to make tomorrow's exceptional performance today's norm, right? So we already use AI. So why do we want to stop students using AI? We need to use them in the right way. The second thing is about you should think like a Renaissance scholar, okay? So for many of the liberal arts major, I think many students, including many of the professors, what I witnessed, they lack some of the fundamental scientific concepts that can be very useful for them, right? So probabilities, statistics, and so on and so forth. People hear causality and causation are different things, but that's just surface. Many people do not really understand that causation and correlation is actually a very deep scientific problem. They do not understand why sometimes they confuse causation with correlation. People know about different kind of biases, selective bias, survival biases, and so on and so forth. They do not know there's something called a Bayesian learning, which explains what happens and have a principal ways of solve that. For the STEM major, it's the reverse, right? Students are ignorant about history and society and so on and so forth. We're not asking them to like poetry, but for any technologies, when you invent them, there are always a social context, and it also has a social and historical impact. And the STEM majors should know that. And that is one of the things I think the current pipeline fails people. And finally, I think if you have AI, you fly, right? You should really, really enhance. But without AI, you should still be able to walk. If you are paralyzed, you stop or freeze, that means you are completely offloading your intelligence to AI. And that is not what we want. So we want you to be better than pre-AI days. Thank you.
Thank you, Professor Zhang. Please remain on the stage. This is really remarkable. I already almost feel that these three talks, we want to thank the three speakers. These three talks, ladies and gentlemen, distinguished guests, I feel in the past 5 years, it's the best presentations I've ever listened. I think they will transform the future in education. Their impact is going to be long-lasting. So let's give them a big round of applause for everyone. Thank you. We will now move into the panel discussion of this session. You can submit your questions at any time while those QR codes. And to moderate this exciting exchange of ideas, please join me in welcoming our co-chair, Professor Yi Ke-kuo.
Thank you. May I also invite the two other panelists coming, please? I see. Right, we're in a final session where between the panels and also the cocktail, right? So we have to be efficient. Right. Good afternoon, and I'm Yi Ke-kuo, and I'm an AI guy. So I was there to listen carefully about the three very remarkable presentations. I'm deeply impressed. So this session is a panel discussion. I think what we do is we'll have some questions from the audience. But before that, I would like to inspire some of the discussions based on your talk. We had a lot of I think in the last 3 years, we had a lot of this kind of discussion presentations on the AI for higher education. I think this is becoming the well-understood problems and a very hot subject. I would like to really ask, during the 3 years, what kind of progress we already made? And what kind of common consensus will already be built? For example, what the future teacher will be, and what kind of human capacity we need to maintain, and we need to further develop. We're never lost. So what do you guys think, the state of art? Tian, please.
Okay, I think this is a great question and also a difficult question to answer. I guess the world is still moving very fast. We do not really have a kind of conclusion what is the consensus. But I just want to share some of my own perspectives. First of all, during my talk, I have shared with the audience that at the Zhongguancun Academy, we have been doing some really interesting experiments. I think in the past 3 years, although people are talking about AI plus higher education, but it is not easy for any organization to do such kind of aggressive experiments. I guess you have a lot of limitations, but Zhongguancun Academy is new, and we can build many things from scratch. So that's our advantage. And also talk about what kind of characteristics or capacities human need to stick to in order to maintain our advantage in the future. If I just have the chance to name one, I would like to say it is the capability of identifying and defining meaningful problems or meaningful questions. So AI is developing so fast, it can solve problems in a much faster and a more comprehensive way than we human does. But to define and identify some really meaningful, practically meaningful problems, I think it is still a very challenging task for AI. Let me give you one example. In Zhongguancun Academy, we have spent over 3 months in identifying some really key questions and problems to solve in the field of AI plus material design. How we achieved that? We sent our researchers and professors to the key material companies, go to their factories, talking to their first-line engineers and technicians, and also researchers for 3 months to uncover all those, different kind of phenomena and eventually identify some really, really key problems that determines the future of those companies. That process contains a lot of knowledge exchange and people interactions and many things happening in the real world. I believe that is very difficult for today's AI to replace. So that is one example. I think there must be many other examples in other fields. But anyway, identify key problems, real problems from the industry is something I think only we human can do today. And hopefully, we can train our students to have that mindset. Instead of just solving problems, they need to be very sensitive to real-world challenges to identify new problems by talking to people, by understanding and getting embedded in the industry. Yeah, that's my share.
Thank you. Professor Gatwick.
Yeah, no, thanks so much. That's a really, I echo, it's a difficult question. I'm going to go back to some of the things that are potentially positive. I think it's great that higher education institutions are recognizing the importance of AI. Up until a few years ago, they could not be bothered to think about some of these things and the potential. Also, it's really good progress as well that we are not only seeing interest in these sciences, but also even certain advocates, strong advocates in the social sciences as well, that are recognizing the potential and the needs. And I think in particular, we need social sciences because I was talking about some of the potential implications as well on human learning, but we can think about, for example, these pondering things that I was talking about in terms of misinformation that might be also happening on the web. So I think we need to prepare the learners, and that really kind of brings to me much clearer the position that we need to prepare the learners for this new changing world as well, and the changing world which will have far more changes as well and potentially accelerated. We'll see that. It's also positive that institutions are investing to teach people AI literacy. And so I think there's broader kind of consensus on that. We studied also AI literacy across the world. There's really no consensus on what do we mean exactly by AI literacy, how we are measuring, etc. But we are trying to do it to recognize ethical and all other issues. But to me, the state of the art is also that I don't think that many of the conversations as well are maturing enough as well. In the worlds that I'm operating as well, some of the countries like Australia and other places, the conversation is still, oh, ethics, we should ban it, or we define a policy and policy will change everything, right? And then hope for the best. So to me, that conversation is really not. What we are really missing is to think about what is the new different skill? And then what we are trying to assess with this new different skill as well. What the learners need to do. I agree with Zizi, if you are assessing students' AI synergy, then the tasks need to be 10 times harder. But if you are assessing just the students' abilities alone, then it's the student's ability alone. But one thing that we must not be mistaken with is the fact that our cognitive architecture, our brains didn't change just because of AI. We still need equal amount of time to learn certain things, right? So AI can offer many of these signals, but many of them are quite a distraction as well. And we need to be preparing also learners for that type of world. And I think that information also need to cut into the broader policy conversations as well, so we can create the more productive ways for the learners as well to engage. What we don't still understand entirely, or there are some pockets of the innovation in terms of the teaching capacities, what a teacher needs to do, etc., is the use of technology alone is not sufficient. The technology that is well embedded into the pedagogy, or technology that has a method behind it, how we are teaching the students, is the only way that we actually have something that is effective. So that's the thing that we, I think, are not conveying sufficiently, and that's not something that we have widespread great practices. The other final thing I want to basically say is in terms of the assessment as well. I think we are yet to figure out how we are going to do that, right? I think we are still pretty much driving blind and hoping for the rest. My view is that technology is a problem, and also technology is part of the solution as well, and we need to engage with that.
I agree. That's very good comments. Professor Johnson, please.
Yeah, so I just want to echo what Dragon was just said, right? So in my slide, I also talk about AI can blur the boundary, make knowledge accessible broadly, but it cannot shortcut biology. That's the sad truth, right? I hope we can rewire ourselves, but that's not the truth. In my talk, I may appear a bit optimistic because I was focusing on the existing pipelines problems that we can had an opportunity to tackle. But let me just talk a little bit about short-term pains, which I think I didn't mention in that talk. There are a couple of gaps that existing, we have to solve in a more immediate window. The first is curricula, right? Some of the degree programs are soon to be automated. What do we do with them, right? Some of the program skills yet need to be combined and merged. It's happened so fast, we do not have time to adjust. So I talk most about what to learn, but how to learn, how to teach, but what to learn and what to teach. We're just figuring it out right now, right? That is hard. The second thing is somewhat structural, right? If you think of professors, innovating classroom experience is not going to occupy much weight on their promotion ladder, right? So that's different from the trajectory. So that's just rationality, right? So the professors, teachers, in general, do not have the incentive to change how they teach. I speak as a professor myself. When I was in Shanghai, I teach one course. I hope to just teach that forever, right? Just small tweaks here and there, because research is priority. So that's structural. We have to adapt to that. We have to change that too. The second thing is, I do believe a lot of fundamental classes, the content delivery part, AI can do better, provided we harness it in the right way, right? We have to challenge the students and so on and so forth, not to have them have frictionless learning. But now what? The human teachers, what do they do? Maybe we should go back to Confucian time, to the Socratic time, become tutors, right? Facilitators. There's no training for them these days. They have to change their roles, because they will play a very important role in the human learners as well, in addition to AI. I'm against to use AI just as the only solution to teach, for instance, right? Finally, assessment, right? So assessment is extremely difficult. The performance versus your own capabilities, that's different. Which part you're amplifying, which part is your true strengths. And also about, how do you frame the questions well? Can you integrate different domain knowledges, right? Get inspired by imperfections. Those things that we really, really care, right?
So Tian talk about curiosity, but those are the manifest of curiosity is to ask good questions, is to push back, right? So if you do not have the skill built in, you have no way to surface your curiosity to begin with. Thank you. Yeah, thank you. Yeah, I understand. This is a really a serious job, right? The education is lasting for the whole entire human civilization. Change it in some fundamental ways difficult. Now, my next question is, we all know we need to change, and we are now pushing the change, and you all devoted a lot of efforts to make this change happen. And two of them from Microsoft now. And are now working in the university and leading this kind of change. It's very impressive. But my next question is, who will drive it? University, government, you mentioned the policymakers, or maybe the society, parents, students, or international consortiums? Who will drive it? Who will coordinate it? What an effective way? I would like to share some of the discussion with yours. Maybe Professor Johnson first. Yeah.
Well, I'm all in, right? So I think before I retire, I think there are a couple of projects I wanted to do, but I think in terms of a social impact, I think the education is the only problem I care, right? Because the pipeline goes in and goes out, and all these existing things going to have a lot of destruction. So I spend a lot of time there. But ultimately, given the existing system has this resistance, that the professor so on and so forth, we have to start actually doing experiments and let students voice. So if we do it well, right? Let's say take a class that you take X numbers, X percentage of these lectures using AI to deliver in the right way, and use human to deliver. You can ask students what's the effect. If they still think that is better, or which things that they think that need to be improved, they will propagate and push people who are stubborn, like a dragon. They want to, I'm just joking, right? To push the reform, right? To push the reform, start from students. But we have to do the first leg. Right? And study from the university too. University should not asking, we should not use AI or not, but the right question is how do we build better human learners because of AI? That is the question. It's the right question to ask. You begin by asking this question.
Thank you.
So it's a really interesting question. We in computer science departments always struggle with the university IT departments because of cybersecurity, all sorts of limitations and everything, and they kind of try to cut off our cool innovation, right, across the board, right? And so I would maybe look at here as just like wearing my computer scientist hat as well. Is some universities basically have a separate network for all sorts of things that the computer scientists are doing, and they can actually put these applications, and then if something goes wrong with the cybersecurity, they are just basically not really damaging anything outside of that network. It doesn't go into the university finances, doesn't go in everything else. So to me, one of the key things is in that space is how can university create that innovation space as well? So you can kind of fence off to say, hey, I have this small part, I'm actually innovating education parts. I'm actually experimenting with the credentialing, I'm experimenting with these types of things. Last time when we had a similar debates, not really as large as this one, but they were actually quite shaking for higher education, was the year of MOOCs, about 14 years ago, right? And many people were thinking, oh, we need to kind of now experiment with the credentialing. I know an Australian university that experimented with the credentialing, and they created a really great business model for the startup they had. And then they realized, oh, if we let this startup go, we are actually ruining our own university business model. So roll back, and they were basically incorporating some of these things. But it can at least be good test cases as well for the universities to try different things that are not happening inside the normal university curricula and they are not constrained. That's one thing. The other thing that I want to also still emphasize is why universities will maintain its value and presence. Accountability is the single word. Because you need somebody to be accountable for certain things that will happen. So physician, lawyer, software engineer as well. Somebody will have to be accountable for certain things. Right. So that's one of the major things we as institutions matter still, is because of we are producing the people who will be accountable for certain things.
Very good comments. Yeah, please, Tian.
I think Professor Go asked an excellent question. So AI is going to make a huge change in our educational system, but who will drive that to happen? I think for the long term, eventually, we have to depend on the education system to have some self-awareness by itself. Those self-driving force is the thing that maintain long-term, revolution. But for the short term, maybe I'm biased, but from my perspective, it is really difficult for a system to disrupt himself from the internal. And we'll talk about the AES impact on education system. I believe in the short term, it will be the industry or the government who will make a huge change. I will take Zhongguancun Academy as an example. Zhongguancun Academy was established by the government. The government wants to do an experiment, how AI talents can be cultivated in a different way. And when they selected the president of this academy, there could be many choices, but eventually they select me because I came from the industry. I think that's the answer. They want someone outside the education system to do some experiments and without all the constraints. And at least this is the short-term solution I can see. But once again, I want to emphasize, for the long term, it depends on every party in the society, especially the education system itself, because the AES impact on education is something we cannot prevent from happening, and we have to, be prepared, be adaptive to its happening. So that's my view.
Very good, very good. I think three speakers all give the three perspectives from your background. It's very. My last question, I think, given the time limit, my last question is: can you actually give your perspective in next 5 years? What will be the biggest fundamental change in the higher education caused by the AI? Open imagination, 5 years. What will be the biggest fundamental change in higher education caused by the AI? Professor Gasvik, please. That'd be fair.
Yeah, no, thanks. Somebody smart said it's really hard to make predictions, especially about the future, right? So, so to me, the cynic in me says that the university will be still fairly similar as they are today, and I believe that they will still stay the same. Where I think some of the things, and in terms of the fundamental changes, I hope it'll happen, is that we'll recognize much more opportunities on the, especially research space as well. I think those are the major breakthroughs, that's I think the particular thing that what Professor Tian was talking about is especially how we can then promote more talent. So in other words, that the university might actually be the place where the talent can even additionally be accelerated in that space. So that's number one. Number two is that I hope in the 5 years as well that we can find some of these alternative modes that people are not necessarily always coming just for the 4-year degrees, but they're also coming for the shorter mission type of approaches as well. So they can actually get ready for the current technological push. That requires bolder experimentation and braveness of the universities, but I think that at least we can have that one stream there.
Okay, Professor Liu. Yeah.
I would say within 5 years, maybe the biggest change will happen to the evaluation system and the philosophy. Just as I mentioned in my talk, in Zhongguancun Academy, we have a project called Auto SOTA, which is trying to remind people that publishing a lot of papers, achieving SOTA performance means nothing. And there's even more, inspiring things than that. For example, today, AI scientist, the automatic AI agent, research agent, can write a very high quality papers already and reaching the top conference bar. Suppose if we have deployed thousands of GPUs and run those research agents Then every year, they can produce billions of papers. And they submit those papers to the top conference and journals. Without disclosing those papers were written by AI, then imagine the entire peer review system will be destroyed.
Absolutely.
So the impact of AI on our current human-based research system will eventually be disrupted very, very soon. I think within 5 years that is going to happen. Then how we can evaluate a researcher, a student, how we can define their growing path, how should we guide them from a freshman to a successful scholar. So all those things will be just totally different from today's world. So I think that is going to be something we have to pay attention to.
I cannot agree with you more. Thank you. Professor Zhang?
I think the future is very hard to predict, right? So I think it's a curveball. But I think the result will depends on our response to these two questions. First is, how do you grow a better students because of AI, right? Why do I need to send students to university we're all AI, but you are institute. You use AI. If it's a better learner system, then I send my kids into this, right? So that's the first question. The second question is, can we do better research if the AI can do research itself? Right? Because the university has two missions. One is to students, the talents, but also the expanding the knowledge. There are two missions. If you fail these two missions, if you succeed, of course, the answer will be rosy, very great, and so on and so forth. But if we screw up, things will, it's not going to be pretty. So I do not know. So I'm slightly on the optimistic part. If you do well, we'll write it out, because so many institutes are experimenting. So we learn from each other, like what I learned from Dragon, learned from TN today. So we learn from each other. This is our common mission. If we have so many experiments and many people are doing this and learn from each other, something will emerge. So that's my hope.
Okay. So as usual, sorry. Yeah, the time, 8 seconds. In the 8 seconds, is the usual way, right? You have to give one word or one message to the audience, to the university leaders, student faculty members about how to be successful in the AI area based on today's discussion. One sentence each, please. Start from you.
I think we have to get prepared. The very short sentence.
Very good. One word, please. Professor.
Just building on my talk. Oh, sorry. Just building on my talk is basically learning when and how to offload to AI.
Yeah,
I think.
Thank you.
Well, my hope is really for the students, right? You need to go somewhere, even if AI is not here. If you fail that, you fail it. I think that's the most important thing. I speak of, majority of the people in the campus are students. So that's my only message is for the students. And everything else goes from there.
Right. Thank you very much. It's a good discussion. Thank you.
Thanks so much. Remain on stage and let's take a photo together. Thank you.
Oh, can I ask a question? Okay, please. Yeah. They ask question. It's out of schedule. Please, yeah. That's good. It's good. Yeah.
Thank you, Chairman. I'm Dr. Chow. I'm an eye surgeon in Hong Kong. Now, we are moving from narrow AI to general AI. And now we are arriving at super AI. I'd like to ask the panelists to comment on singularity. The singularity, Raymond Kurzweil, talked about 10 years ago in his book, Singularity is Near. And last year, he's publishing another new book, Singularity is Nearer. And this year, Elon Musk said, Singularity is now. 2026 is undeniably the year singularity we have arrived. Now, when we arrive at this stage, what would happen? Will it, like Professor Zhang said in his slides, a tsunami wiping out the human race. What should we do now or in the near future? Would that happen? Thank
Okay.
you.
Yeah. All right. You three. Who go first?
Probably you should really share your comments.
Oh, my comments. I should be the last, right? Yeah. Okay. Okay. Be fair. Be fair. Right. My view is singularity is always will come, but will never reached. Right? It's always people will tell you singularity will come. Somebody is very blunt. For example, Elon Musk say we're already here. We're already here. It's no mystery anymore, right? So basically, it's kind of goal, kind of the dream, and kind of a expectation. It always will be there, but you will never reach it. Okay, that's my view.
I kind of agree with Professor Guo. I personally do not really worry about singularity in any way. What I really care about is AI is growing very fast. Then how to ensure our human being can catch up in a similar speed? That is even more important question. For example, if AI can achieve a singularity someday, if we human beings stay in today's pace and stay here, then it will be a disaster, a tsunami, right? But if we can advance and in a much faster way than before, with the help of AI, then we're happy to see AI's advancement.
Yeah.
Let me give you one example. So if we use AI to ensure we can learn in a much higher throughput, even during our sleep, we can learn something. If we use this BCI to ensure people can think in a much faster way, can control what we cannot control before, can absorb knowledge in a different way, and then in the future we can imagine that carbon silicon integration world will be fantastic. I will look forward to that. Yeah, so that's my view.
I'm on the same boat. Singularity, AGI, just the marketing terms. They become pointless at this stage. So I don't buy into any of that. It's the fog of marketing at this stage. To me, I think you hinted at something that is really important. How much we sleep. Do we sleep? What we are making for the betterment of the humans as well. From that perspective, I think some of the reports are showing, and I anticipated it as well. There was a hypothesis 2023 is that AI is going to intensify work. So there was a recent study as well in Harvard Business Review. So it's not actually, eliminating work, but it's actually make you work harder. Oh, I can do this and I can do this other thing, etc. So then the question is, if people are getting less sleep, how they are learning better with the less sleep. I think the sleep is really essential for learning.
I want to share a couple of thoughts. First of all, I think the term artificial AGI needs to be defined. It's always kind of confused me. People start talking about things without clearly define what the concept is. So the reason I'm saying this, I've been saying for a few years now, I think the AGI is here already, because if you look at use human as a baseline, what do we do day to day, go around? We are pattern machine too, right? You say we're conditioned pattern machines. So if you look at the large language models, what it does internally, it's just pattern matching, except it's pattern matching on the large scale. So in that sense, the AGI is already here, right? So SGI, super intelligent, we need to yet to define that before we can talk about it. Otherwise, it's kind of empty. I mean no disrespect to you, but I think we have to define the pattern. But does that make you feel better if I tell you AGI is already here, right? Now, the second thing about singularity, I think that singularity can happen tomorrow or even yesterday. If the madman, we know there are a couple of madmen in the world right now, right? If they get a hold of the AI, they muscle their old power, the world ends tomorrow. Just drop nuclear. So it's always there. I would say it's a miracle that we're not there, right? So I think it takes the collective will to deal with this kind of tension. So that's it. Thank you.
All right. It's a very good ending of the discussion. Another question.
Sorry, that's because time is really running out.
I suggest you can have a glass of the champagne and then we have a discussion. All right? So it's better to discuss with the wine.
It's a perfect
Thank
idea.
you very much. Yeah.
Thank you so much, Professor Guo. Thank you. Would you please step forward to take a photo together? Thank you. Please step forward. And please face our photographer in the front. Thank you to all our panelists for this incredibly rich, engaging, and interactive discussion. Would you please remain on stage? May I also invite Professor Peng Gong and Professor Wenwei Tu on stage to join the next photo. Thank you. Let us welcome back Professor Gong and Professor Tu, please. Welcome. So your diverse and valuable perspectives have sparked so many thought-provoking ideas and given us all much to reflect on as we navigate the future of AI in education. Ready? 3, 2, 1. Perfect. Let's put our hands together to thank all our guests on stage. Please return to your seats. Thank you. Ladies and gentlemen, this concludes our second thematic session. Thank you to our co-chairs and all the distinguished experts for your profound insights. Would our guests please return to your seats? Thank you. Ladies and gentlemen, after a full day of enriching and brilliant academic exchanges, the 2026 International Academicians Hong Kong Forum is now coming to a close. Finally, may I invite Professor Wenwei Tu, President of HKAORS and Secretary General of IAA, to deliver the closing remarks for us. Let us put our hands together to welcome Professor Tu, please.
Thanks. So, distinguished guests, esteemed speakers, fellow academicians, ladies and gentlemen, as we come to close of today's forum, I would like to extend my sincere appreciation to all of you for your presence and participation. Your support has made this occasion both meaningful and memorable. Today's discussion has been insightful and inspiring. Through the plenary lectures, the President roundtable discussion, and keynote speech in the afternoon session, we have gained valuable perspective on the evolving relationship among innovation, technology, AI, education, health, and society. I would like to thank all speakers, moderator, panelists who contribute to the session throughout the whole day. Your thoughtful insights have greatly enriched the quality and the depth of this forum. I would further like to thank our co-organizer, partners, support institutes, and all the college and volunteers whose dedication and hard work behind have made this event possible. And to our audience, thank you for your attention and engagement. Your active participation has contributed greatly to the success of today's forum. As we look ahead, Hong Kong has a unique role to play in collection of talent, research, and innovation across the board. With continued collaboration with universities, industry, and the wide community, I'm confident that we can make meaningful contributions to the future of innovation and technology, both regional and globally. Thank you once again for joining us today. I wish all of you a pleasant evening and a safe journey home. Thank you.
Thank you, Professor Tu, for your summary and remarks. Please be seated. Thank you. Let us take a few moments to thank everyone who made this possible: the International Alliance of Academicians, the Hong Kong Association of Overseas Returned Scholars, all the supporting organizations, sponsors, speakers, and every single one of you in the audience. IAA will continue to uphold the mission in fostering global collaboration through openness, advancing scientific progress through innovation, and working together towards an intelligent future for health and education. Once again, thank you to all the leaders, academicians, experts, scholars, and guests for your presence and support. The next few minutes will be the attendees' academic exchange session. Please feel free to mingle and discuss. For those invited to this evening's events, please note that a cocktail reception will be held now, followed by a wrap-up dinner at 7 o'clock, both in the same venue here. We wish you all a wonderful evening in Hong Kong. We look forward to seeing you again next year. Thank you so much. Please enjoy.
他们自己调完就有人再听。
对，他们调完我们去年也是这样子。
晚宴吃不起。